think we are live, guys. Welcome in. Let me check my. Yes. I can hear myself, which means we are live. I hope you are doing great, guys. Today, our goal is to study not lead code, actually, slightly lead code, but also we're gonna study some Python as well. Um, Currently, like yesterday, we have developed this application which is amazing. All right, I can select one and press space, and now we are in recall mode, guys. And as I tab, like as I press tab, it shows what should I tap or type. So basically, um like we're gonna memorize, guys, today. Forget about learning, forget about long term, forget, like, of course, I value learning more than memorizing, but we need to do this like a, in a, in what manner, in a good manner. All right. Because if you value like a learning more, but if you don't memorize anything at all, then it is not a good way. It's like a balanced manner, right? So for example, now, okay, it says contains key, all right, contains uh, key, and like now we see that, all right, um map hash map has a contains method, all right, and you give a key basically, and you are trying to find what, um, but what does it return? I guess it returns its value, right? hmm I may need to move this here. It returns the value, all right, or is it like, does it return true or false? What do you think, guys? What do you think? And it contains, we have like a contains, not key but value. Now we are searching with value. hmm for example, let's say 100, all right, and actually I really wonder what they return. Actually, they should return boolean. They should return boolean, right? um let's see, if we have remove map remove, uh I guess we should pass like a give key argument. So we literally remove that entry from our map. We have size, all right. What is this size? Actually, it must counting the number of entries. Oh, Americano, welcome in, Americano. See ya. Buongiorno, my man. How are you doing? I hope you are doing great. I have some surprise for you, some new comments. All right, you can try them out. I guess you're gonna love them. And we have like is empty, all right. Map is empty. Is empty means we don't have anything in our uh, map basic, all right. We can now press done. In 3 minutes, guys, with 100% accuracy, we've got it. All right, strike one, wonderful. And let's open another one. Like I have solved it, so let's let's study this one, right? What do we have? We have a for loop. uh I guess we have something like a key map values, all right. Map values. Yeah, you can use this color comment, American. um what kind of color is that? We have limited number of options, Americano, but we can add that color as well. Map values. Oh my gosh, what is Koku Elikot, man? I haven't I haven't seen it. I was just testing the water. All right. Now it became red. We have values. All right. Let's make it integer values as well. Integer values and a space. Hmm. Oh, there's a space after the for loop. Yes, Americano. Like you are in control. You are our VIPs. One and only VIP, all right? You have some control over my, applications. And also, you also change the color of our VS Code, all right? Wonderful, isn't it? You both now have like ability of changing the color of my VS Code and also the color of that application we have created yesterday. I'm not. What do you mean? I'm not worthy. Like you are VIP. What do you want, man? It is the highest, you know, level you can get. What do you mean? Um, it value. Um, After the value, we have a space. So we have all the values now. Even after the closing parentheses, we have a space. I cannot tab. Maybe I should use CMD and tab. All right, because I may need to use system out println. So system out println and value. The thing we are returning. So we literally get the values. Like imagine we have a key and key value entries line by line, and we let's say like imagine we have a like a database, right? We only get the value column, all right? This is how we iterate. All right. It's been again 3 minutes, so I guess I can type all of them in 3 minutes. This is a key set. Let's study, guys. We have a for loop again, guys, and integer value. No, what was it? Integer k. Since it is k, we use k. Map dot key set is the method for us. All right, now we open this, and this looks nice. Yeah. Thank you. I thought you were gonna like it, and like you can pick like that. We have, I guess, 16 or 18 colors. Um, so you are talking about the application. So like I figured, like learning the fundamentals, learning the logic is good. We don't have white. Learning the logic part is important, but also memorizing stuff is also important. The canvas looks very nice. All right. Thank you. All right. So now we can, system out parent ln and a k, I think, right? Wonderful, guys. And it's been 1 minute. Done. 100% accuracy, guys. Plus magenta. We can add though. Oh, we have. Wow, these colors. I like these colors, Americano. Look at it, man. This looks nice. This looks nice. We have map continue if absent, like a method that I don't know. Like map compute if absent. Computer, not computer if absent. Compute if absent. Then what? A key and a function. What was it? Anonymous function, right? Key new array list. We are initializing an array list. Yes, we have done it. And now we are adding a value to that, but we close. So we get the output of this compute and if absent method. Oh, it has that feature now, the 100% accuracy. This looks very nice as a study material. Exactly. Like Americana, we're gonna learn, all right, Java and Python in no time. there is no escape. We're gonna done it. All right. And this is gonna help us. All right. Like you press tab and see the code. All right. And as you type, if you type wrong, you literally see the red, like in red. So you literally see, you realize you are making a mistake. All right. We're gonna memorize all the methods, all the functions, everything Americano. All right. We're gonna done it. Uh, add add what like we use compute absent method and it returns something and we are adding something to it and that something is value. We don't know where value is coming from. This is on the current version on GitHub. You are asking an amazing question. It may not. Let me push the code. I have done some changes. Run git status and then I guess we have committed that new like a new features, but I need you to push the code to remove. In a second it will be. In a second it will be American. And now we have a for loop, an integer array it takes. All right, and edges. Where did edges come from? I guess it is something like only an array. All right, I'll test this later. Honestly, it's just like fire. Thank you, thank you. Like now I'm committing. It's gonna be on GitHub in 30 seconds. In 30 seconds. Um. All right. Map. Again, we have. This is, I guess, another. Sorry, another. Another use case basically. Pushed. Now the code is pushed. Americano, you can get it. You can start using it. Map compute if absent, we get the first, like a first item. All right. New array list. We are initializing an array list and at, I guess, E, right? But edges returns an array. Like each element of edges is an array itself, so we cannot add E right away, but we need to reach its element. All right, so I don't know how this works, but in 4 minutes we could type it 100% accuracy, guys. So we are just perfect. All right. So today my goal is to like study these. Like I'm gonna create some new nodes. Nodes about maybe binary search, two pointer approach. Maybe, oh, maybe like we have questions from our greedy list. We have solved them mostly, and we can try getting their code, right? All right. Um, maybe we can start with this. All right. It is pushed now. The skill we have was think canvas db, and also nodes. All right. And the table was this one, and from this topic, not topic but node, I wanna get the code of those lead code problems. I mean the solutions. We need their solution, but how, like maybe we should create some boards, or in a single board we can have all of them maybe it will be great if we divide them into 20, like a 20 number of uh, code blocks, basically 20, maybe 25, 25, 25, and 25. But we may need to create some other mm, subcode blocks, because having this full solution in a single um, code block may not be helpful. All right. But we should manually do that. I mean, we need to specifically indicate that. Uh, oh, there is no background music, right? I guess there is, but it is too. All right. All right. So now we need you to get all the problem solutions, like create 3 boards, all right, and divide them into 25, all right, to create 3 boards. Fetch the greedy problems solution. You can read the problem's name, and then you should generate the solution of it and create a code node in our board, and then we're gonna read those boards, and then we're gonna create some other code blocks, because having the solution of a problem in a single code node will not be helpful. But first, let's start with doing that, and then we will create some divisions of each particular problem. All right. But about the positioning of those code blocks, maybe you can place some space between um, between codes. All right. Because we will create some new code blocks around that's around the solution of a particular certain problem. All right. um yeah, let's see, guys. I'm using Monaca editor, which is open source code editor, and it works amazing, basically. And we're gonna, let's say, practice. All right, we're gonna practice. We're gonna memorize basic all the methods, guys. Let's look at this part, for example. What do we have? Like, we literally iterate the key. It is entry set. That is interesting. We now iterate both key and value at the same time, not value or key each time. I mean, both of them at the same time, not individually. And the way we do is map.entry. Oh my gosh, look at it, guys. So this is the type. This is the type. We literally type the type for map class. In map class, we have entry class again, I think, and this is its generic type. All right, and there is a space after the comma, and I think after the arrow, no, after the arrow. All right, we can type E and map dot entry set, right? Entry set, and do we use parentheses? Yes. Because if we don't use parentheses, it would mean a property. It is function. All right, this seems nice. And now we can get the key, right, by what? E dot. How do we get the key? Get key. We have a method get key. Nice. And for value, I guess it is v. Nice. E dot get value. We already have. All right. It's been almost 2 minutes, guys, and 100% accuracy. All right. All right. This is how we get key value together, basically. All right. What do we have here? I don't want to study this, but let's see. What is this? Let's see what it is. Again, we are like this is key value together, right? But we have a list, and the item of that list is key value. Okay, key value what is the name of key value entry? And we the way we initialize is also strange. Like we initialize like array list, and inside we may need to look at how we initialize an array list with items. Yeah, do we have do we have something like that? Do we have some? No, like this is not an array list. We can create a board for array list. How do we create an array list with items, basically, right? And let me also check our website. Let's trust. So if you every day, all right. Um, it is creating our boards. Let's see what boards we have. We already have this. All right. We can also create. Um, what was the name of the command, guys? Think, right? Think canvas. Can you please create a new board about array lists in Java? For example, how we initialize it, how we initialize it with, you know, with initial values basically. Because I've seen an example where we initialize array list using the entry entry set method of map. It is strange. So, like in this board, like after studying this board, I want to be able to create different kind of array lists basic, all right? I'm also studying some generic in Java, so maybe you can also add array list classes, like a blueprint, like a pseudocode of array list, so that we can see which methods it has, the overall structure of it, and which classes that it implements, which classes that it extends basically, all right? The chain, like extend, like a inheritance change the chain, and implementation interface chain, uh, because in lead code I may need to use different kind of array lists based on needs, all right? And also it would be great if you add some lead code examples where we need to use these different kind of array lists, all right? um, and maybe you can also create a normal text node where you list the advantage of using array list, because last time we were solving a lead code problem, we needed a data structure where we can dynamically add new items. And the first data structures that come to my mind was, I guess, heap. It is over complicated. Like I mean, um, array list is kind of simple, right? And also, like, I create a text node about the time complexity of using these array list, basic adding an item, removing an item, right? We want to see we want to see all right, the color is changed. Why? Did you do it, Americana? Why the color changed? um I did not. Why the color changed, bro? Oh my gosh, are we getting hacked? Or maybe do we have some sort of duration or something that I forgot? Thank you. Violet is good. Maybe we have like a 10 minutes duration or something. Um, we can check actually. In our color command, do we have some sort of um, you know duration for active duration basically? Let's see. Mm, all right. It is cooking, guys. It is cooking examples for us. Um, like I've seen this for example, I've seen this before. But like, to be honest, I haven't used it even a single time. Maybe something like color hexot optional time limit, blank for no limit. Hmm. Yeah, we can do that. We can do that, but like I need to have those hex codes in both my VS Code extension and on this application. Hmm. We will figure out something. Optional time limit. All right, all right. Blank for no limit. No, no, no. Like we can do it. We can do it. Since I have a limited number of colors in these applications, but we can make it such way that we can literally set the hex code given, so that alongside with the dedicated color palette, color group, we can also use the dynamic. Yes, there's an auto revert duration. Oh, we have 15 minutes idle auto revert. I didn't know that. We have a duration basically 15 minutes. All right. My engineer friend suggested us to use hexa code for the color assignment. So um, we need to do this carefully. You need to read the the Think Canvas, all right, and also our Visual Studio Code extension, and update their code basically, and make them able to use a dynamic assignment basically, all right. um how can we do that? We're gonna do this, americano. All right. Like this looks strange, like map class and an entry. Like I need to look at the implementation of this, but for the sake of time, let's memorize it. This is the structure we are familiar with actually. This is actually generic, right? But like what makes us use two values here? Maybe I want to use three of them, like integer, integer, integer. There must be something about it, so we need to find the um, let's try finding one. let's Let me type map dot entry, right? As you see, guys, we have key and it's basically key and value. All right, key and value. So entry, come on, man. And yes, press enter and then go into that. Yes, this is an interface. And all right, this is an interface basically. All right, get key returns the key. All right, all right. We have studied these generics with americano and we completed some rabbit holes. Now we can easily understand how they work basically. So the type that you entered in the in this part will be used when we return basically. Like that type will be our return type. All right. Let's see if they created what's on it. Yes. I guess now we have our nodes, guys. Let's study them. Hash map in Java, array list in Java. Oh my gosh, guys. Array list in Java, growable index accessible list. After this board, um, you should be able to spin up any flavor of array list on demand. Section 1 to initialize. This is how we initialize, guys. We know it. With initial capacity. Oh, initial capacity. What do you mean? Oh, this is the capacity. This is not the items. Oh, like actually, for it to be items, we should have used like a curly bracket, right? Brackets. Since we literally use an integer value. Add an API so people can connect it to an external taser they can attach on their hand. So every mistake, yeah, like we are the way the place we are going is there. Yes, like I'm imagining a robot on my desk, and I imagine like you can control that robot basically, right? We can attach some camera on top of it. You can drive it basically. Yeah, like we are going there. Yeah. And maybe like each time I make a mistake, like a scream, all right, you can generate scream sound. Yeah. We will maybe one day we will have it. Um, so this is the size, like this is the capacity, guys. The list of, like, I don't know the usage of list of. I've seen it in lots of places. It kind of resembles the way how Python handles creation of arrays basically. Um, so we have like this is an integer list. So list of, all right. So instead of using like a new list and then arrows and then curly brackets and then typing the elements, you can literally use this. But the thing is, like, maybe guys, like we should observe, we should examine, all right? Let's type list of here, right? And see the implement. Come on. Yes. So, all right, it is generic basically again, and it takes any type of argument and returns list of it basically. I mean, actually, we don't see which kind of argument it takes, but we see the return type, and actually we have studied this E, but I forgot the meaning of it. Let's see. Let's open. Let's create another one. So here, I forgot the first E's meaning. All right. I mean, in definition of interface, um, we have we have the generic type, right? And but here we use it before the return type of the method. So can you please teach us? Welcome. Thank you for the lurk, C program lover. I hope you are doing just fine. Let's see. All right. This is a list interface apparently. No. Yes. We have an interface like this. Yes. This is the list interface, and this is the method of it. But where is the implementation, guys? Where is the implementation of this of method basically? Right? But this returns something. So, but we are interface, but we are returning. How come? Maybe we should also ask this as well, right? Good question. Let me ask. So another thing we wonder is like, uh, this is an interface, right? But it returns something. I expected to see a method definition without implementation because this is an interface. But I guess after certain Java version, interfaces got a new like a feature or something, right? What was it? Can you remind us? Yes. So for example, there are some other methods that we only have their like a without their bodies, basically, right? Only the definition, basically. But we have also other methods. Maybe those methods are coming from sequence collection uh, interface. But again, if an interface extends something, hmm. So my another question is, when an interface extends another interface, um, like it doesn't have to implement that method, right? It just actually, like, does it need to do anything? Because we delegate the implementation responsibility to the class that implements our interface, basically, right? From the interface perspective, that doesn't need to have the implementation, right, of the class that it extends, which is not a class but interface, right? Let's see. And also, let's read it, guys. Let me also make it bigger. There are actually two different places generics show up, and they mean different things. Yes, generic type parameter declared on the interface. Yes, and here. And here is declared right after type name. So for example here, yes, this E belongs to the whole interface. Every instance of list picks a concrete type of E, and every method in that interface can use the same E. Yes, the generic type parameter declared on the method itself. Yes, now look at your screenshot. That leading E is separate, independent declaration. Read the method left to right. This is modifier. This is, I'm declaring a type parameter named E for this method. The E before the return type is saying this method introduces its own type variable called E. You must declare a type variable before you are allowed to use it. Exactly like you must declare a variable before using in the code. The return type, why does this method needs own E? Yes, because it is static. A static method does not belong to any particular instance of the class, so it cannot borrow the class level type parameter. The class level E only exists once you have an actual object of that type. Nice. Maybe, guys, we can go like take a screenshot of this part and add it into our notes. And tag is generic. And let's give some colors. Alright, so this is our first question. T declared on the class. Yes, we use it. Here, U declared on the method, which is static, needs its own. But how do we declare its own? Get get reuses um get reuses the class must declare yourself. You showed this, and I really wonder, like, what is the meaning of declaring its own, um, declaring its own type, basically, right? Like, how do we do it when we are calling this method, basically? Oh my gosh, we have lots of to read, guys. This was our no. Oh my gosh. No, yes. These are first. These are second. All right. Exactly. Your memory is serving you well. This is one of the bigger changes to interface in modern Java. Java 8 introduced two kinds of methods with bodies interfaces: default methods and static methods. So in our case, we have um, static. Like our method is static basically. So that's why we have an implementation basically. Before Java 8, alright, this is a good information, guys. About interface. Nice. The method in your screenshot is a static method, which is one of those Java 8 editions, guys. Because it is static, it belongs to the interface type itself, not to any implementing class. Implementing. You can call it as since it's a static. So we literally call a static method of an interface, guys. Isn't it just astonishing, right? When the time limit is left blank, what should happen? Until reset. How should viewers type the plain numbers? Cap on how long a viewer can set. Explicit limits above to keep the 18 name columns to or H on it. Keep both. Alright. So we literally we are literally calling a method, like a static method, from our interface, guys. How cool is that? The other Java 8 edition is a default method, which is the one people usually find more surprising. Has a body lives in the interface. That's nice, guys. That is just nice. A default method does get inherited by implementing class, and a class can override it if it wants. Default methods exists so that library designers, guys, we are gonna be libraries, can add new methods to an existing interface without breaking every class that already implements it. There are some classes that implement our interface. Alright. Imagine, guys, imagine. There's an interface and you want to update it, alright? You want to enhance it. You want to add some new methods. But as soon as you do that, imagine you add a new method, basically, right? Then all the classes that implements that your interface has to, basically, right? Override that method, implement that method. It is not very, maintainable. Alright. So you can add this one and they can. But in this case, you can add this method, but in this case, like in this case, you don't make your subclasses like enforced to have the implementation of this method, but You have the implementation. Hmm. All right. So list sort and collection stream were added to collections. Oh my guys. Uh, collection stream were added to the collections framework without forcing the entire Java ecosystem to rewrite their implementations. Yes, yes, yes. To summarize it, the timeline of interface evolution is this. Before Java 8, interfaces had only abstract methods plus constant. Only abstract methods plus constant, yes. Java 9 then added private methods and private static methods, which let default and static methods are share common helper logic internally without exposing it as part of the public control. Oh my gosh. Let's paste it as well. There is one important distinction worth burning into memory. A static interface method belongs to the interface and is called as yes. It's not part of any object's behavior, objects that implemented this interface. A default interface method belongs to every implementing object and is called as the off method you are looking at is a static. Alright, so we got it, guys. You got it exactly right. When an interface extends another interface, it does not have to implement anything. Your reasoning is correct. The implementation responsibility keeps getting passed down until it finally lands on a concrete class. Oh my god, machine there we go. Yes, yes, yes. Copy here. Lay me layout. Alright. This is an interface. This is another interface. So doc implements pet, then it should implement two methods basically. Doc is where the buck stops because doc is concrete class. Concrete. It must provide bodies for every abstract method it has inherited through the whole chain, guys. Through the whole chain. So the chain of response. Now I have another question, guys. Now I have another question. Civil extends animal and comparable. Just merges all those contracts together and still implements nothing. A couple of points worth nailing down. An interface can extend multiple interfaces at once. Mm-hmm. Alright, this is an interface because an interface cannot contribute an implementation but only through a default method. If an animal had given it a default body, then pet would inherit that. Animal eat. Animal. Alright. Had given it default body, a default body, then pet would inherit that working implementation. There is also the case of an abstract class implementing an interface. An abstract class is allowed to leave some methods unimplemented too because it is also not complete. It can implement some and pass the rest down to it. All right. It's like an intermediate. Wait, quick question though. To what extent do we need to learn how to code and memorize? To what extent do we need to learn how to code and memorize? I mean, of course we should learn and understand, but to what extent? That's a question. Nobody knows. No, no, no. Like the thing is, like in my previous experience, I've seen some senior, you know, senior engineers basically. After a certain amount of time, you got familiar with what we are doing, all right? And since you also have some code bases, like you've written some code, all right? After let's say 1, 2 years, 3 years, you have already a code base. some certain methods that you can use in other places as well. So you don't type them, you don't code them from zero. You basically copy, all right, from some project and paste it in another one, all right. Um, but the way our focus now is on memorizing is because we need to go fast, all right. While learning, we also do excessive memorization, basically, all right. Excessive learning and excessive memorization, all right. Um, you should, for example, for your as an example for your question, for example, you should know americano. You should know like this method, like a list dot of method. If you want to create a list of integers, right? You should know the like a for example the method of like you should know how to initialize an array list, right? You should know the collections, for example, dot n copies, right? You should know these methods, right? You should memorize basically. Um, you should basically memorize these because without them, you cannot even type any code, right? For example, you should know how you iterate key value together inside the for loop. You should you should know. Like I didn't like I've seen this before, but now I want it to be fresh in my memory, right? When I need it, I don't wanna need to look anywhere, but start typing right away. Like this is not too hard, basically. All right. For example, there are 5, 6 methods in each class, basically, that we need to memorize. Amazing, look at it. We have a summary of array list class, pseudo of the class. Amazing. We have a add method, get, set, remove. Like for example, these, right? Like I don't know the usage of merge method, for example, in HashMap. Yesterday or the day before, when we were like solving lead code problem in the solution, I've seen this, and which is, I mean, this one is better than using um, basic another method. This handles elegantly. Like we should also study this this convention, for example. I don't know it. We're gonna memorize. We're gonna do it, Americano. Don't worry. Don't worry about it. All right. There are like there isn't unlimited number of methods that we need to memorize. There are limited number of like a hash map classes method, array list classes method. All right. Um, we should like a string class, integer class. Like we should be familiar with the methods of those classes. All right. This is expected from us. Now we are learning. For example, this is learning phase. There is also the case of an abstract class. All right, all right. Let me take a screenshot and make it abstract. But I had one question that I was gonna ask, but after I saw this abstract, I forgot. I think, but that question I think was, uh, it was a good question though. I should have asked right after I had it. All right, maybe I will remember. Let's read it. Let's continue reading. Mm, AI can write codes faster than a human. Yes. It has every method of every language memorized. Yes. Why focus on coding rather than focus on the theory and the architecture? Like we are doing that too. We are doing like from our last streams. I mean, until until today, like we mainly focused on this architecture and the theory. Not being pragmatic here, but at the current rate it's going, yes. By the moment I graduate, yes. It should be like mid-level at first and senior level at best, yes. The commercial models, I mean, I just see the value of learning more and more methods and memorizing stuff more and more redundant as time goes on. Maybe just me finding excuses. There is a limit to that. I get it, Americano. But there is no harm memorizing a few methods. Let me tell you that. All right, because for example, they are kind of even same. Like for example, in Python, we like add items like using append method, and we use append method in array list, like in Java. So the even you get familiar with the convention, all right. In case you forget, you can try a few of them, and you can type. And this is not too important, but there are some parts that you should know basically, right? Because during an interview, imagine face-to-face interview, and imagine you don't know the method of that string class, all right? For example, a value of, like, this isn't good. And since AI can, like, Americana, let me show you this, man. Like, let me show you this, man. Like, I would have, I mean, we have to basically arrange this node by myself, and it would take some, let's say, 10 minutes or 20 minutes, all right? Like, this is the array list class, but we only see a part of it. When we open this array list inside like a real Java, right? We see, let's say, 1,000 line calls. I told AI that give the pseudocode part, the important parts. Important parts mean which classes it extends, which class, which interfaces it implements, right? And some methods. So AI generated this. So the learning, like we can learn, we can memorize faster than ever. All right, faster than ever. So no excuses, my man. No excuses. Makes sense. Yeah, yeah. So like look at the beauty of this code, Americano. Like we have created this application yesterday, right? Look how beautiful it looks. You can even change the color of it, man. No excuses. Yes. So you can even change the color of it, man, from your home, right? Imagine like this is privilege, man. So um we're gonna we're gonna we're gonna do it, man. We're gonna do it. We're gonna do it. So the question we had, let me show you what declaring its own type means from the color side. Yes, because that is where the abstract idea becomes concrete. First, the key mental shift: a method level type, um, a method type variable like e is filled in fresh every single time you call the method. Oh my gosh! But since our method is static, that kind of makes sense. It's not fixed ones. Each call gets. Oh, Carcass, welcome in. AI can write code faster than human. Is that code any good? Usually not. We have run tests at work, and out of the code AI produced, we would end up rewriting 60-80% of it, as it is slow. So in the end, it is faster to write it ourselves. So this is perspective of a senior engineer, all right. Um, but it gets better and better, like compared to last year's version. Like imagine, Carcus, you can now change the color of the application I'm using right now. Like AI generated this, all right. I made AI handle my OBS setup. Like for example, you can also change the color of my VS Code extension, right? You can literally change. We have a color comment here in our chat. Like this is good actually, because now it started handling the logic part as good as the front side. I mean, the visual part. It handles the visual part better. That was the past. Currently, it's like very nice, like even getting the gestures right. And yes, we can do this, for example.
Let the focus flow through you. The code bends to a calm mind.
So like we literally have done this using AI. So it includes some logic part. all right, not only visual part. um, and by 3 or 4 years from now it will be near perfect, and at least high mid, I it seems that way. And it can generate so very quickly, so you can test and change quickly, I think. Yeah, yeah, yeah. I heard that, like, we are learning these design patterns, like object oriented principles, right? Like, they are created because the maintainability of these codes previously, I mean, was hard. All right, there are, let's imagine, 40, 50 engineers working on a single project, or so maintaining that project is kind of hard, right? But imagine a world where generating code is not expensive. So it may mean you don't need to use those concepts that much, basically, because the cost is low. In case you face a problem, you just recreate that no code, basically, right? Um, but of course, I value knowing these concepts because I strongly believe that they will, help you capture the overall architecture better. That's why I focus on this. That path is right now. AI is nowhere near to produce high performance or secure code. Yeah, so these are the edge cases. My friends in cybersecurity love AI though. Um, Thanks to it, there is no shortage of work for them. Yeah, 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 yeah. So the performance and security, like, is the next level, maybe. Yeah, but it can handle that part too, I suppose. AI eventually will get that place, I suppose. I haven't watched the recent video of Neat Code. He published like a video about the, AI slop. I was gonna watch it, but I postponed it. Maybe I can find valuable thing in his video. Uh, let's see. Neat Code. The AI delusion is getting worse. Something dark is, yes. I haven't. Oh my gosh. Sorry. Let me mute.
Recently, we started to get to a really dark place. In the Wall Street Journal, the earning reporting and AI is really steep. We talked about a lot of things in this, one of which being somebody tried to sell.
Let's see what he says. Wasn't Fable very good security wise? Wasn't that one of its selling points, to the point that it was used by government? Yeah, yeah. So, like, it should like, it should be capable of writing code better than humans. I mean, it should be capable of doing that. I think there are two sides, doomers and glazers. I think currently we're somewhere in between, but over time we'll slowly move to better and better models, and over time, I think maybe in a few years or so, not decades. Yeah, yeah. So, like, if you ask this question 2 years ago, I would say, like, I said this, alright. Like, I said, AI won't be good, because the models I was using back then was generating bad code. Even the simple thing, like, I'm saying change this part, and it says now I change it. Look how beautiful it is, but it break the code, basically. It was, able to find the correct place for changing the numbers, but the value it was using was too wrong. Now it doesn't do that. you know of course there are some insecure parts, but it is much better. It is much better. Yeah, I've seen I've seen this clip, and the students booze him, right? As he said, mm, use AI and it is, you know, unescapable. We all should use AI, he said, and after that he is gonna boot. Yeah. And I've seen another video, and there she said, you know, you didn't have to boot that, you know, professor. I think, I suppose, you should use AI, and you should, you know, use it for finding more jobs. I mean, I guess, what was her name? I don't remember, but I can maybe find that video as well. Like, to be honest, nobody knows. Oh my gosh, nobody knows how it is gonna be like in in 5 years. Nobody knows. Streamline auto AI resume maker JavaScript and auto apply. Yeah, yeah. Um, like, it's a good practice, but I also want to send some cold emails. You know, the downside of it is there are others that you like, does this, right? And um, so there are 1,000 applicants for a single job, and yes, I guess I have found her. And like, how you plan to be more like a unique house of, yes, it was one of her videos. mm, I don't know which one. In one of her videos, she also showed that video of that boot professor. There are lots of videos. Oh my gosh, she's making lots of videos. Oh, Nextcloud. Yesterday, one of our friend mentioned about Nextcloud, and now I see, um, news about it. It was Flickmash. Yes, Flickmash. There are lots of videos, man. I guess she's also working in college or something, or maybe she has quitted. I don't know. Mm, no more results. Anyway, the NVIDIA CEO said that almost every person sitting on tech forum stage would have insisted that it is vital for young people to learn computer science, to learn how to program computers. In fact, it's almost exactly opposite, according to Hang's counterintuitive sense. Oh, have a nice stream, but thank you. Welcome, welcome in. How are you? How are you doing? Um, Today we go slow. We created this application. We're gonna study some Java and a little bit of Python, and I want to also create some videos for my YouTube. Actually, it's getting better and better every day. um yeah, like I was gonna call you soon. Maybe today after the stream I'm gonna call you. I hope your leg is also doing good. It's good to hear, man. Okay, wait. Alright, I will um let's see. So the another part is, guys, the way they talk in front of the cameras and the things they talk behind the cameras, behind the doors, basically. Like, of course, they are different, right? So, um, like that's why I don't follow the news, basically, right? I created a path for me. American, I'm telling this for you. I created a path for me, for myself, actually. Like, if I know these very well, like lead code, Java, Python, if I am a good communicator, all right, if I am trusted person, right, um, then it should be good, man. It should be good, all right, because nobody knows, all right. Even look at the Nvidia CEO, like he changed the perspective he was using after 2 years. So nobody knows. Even NeetCode doesn't know, because 1 year ago he said that, like, look at that, like AI creating a slope code. But now AI doesn't do those mistakes that he was mentioning that back then, all right? And he also changed his mind, um, because they keep getting better and better, all right? The models, I mean. And also there is a fact that ChatGPT, like they were about to sign an agreement about video generation, like a maybe $5 billion or something, maybe even more, maybe $50 billion. But they resigned. Why? Because the cost of generating those videos was too high, that even the $50 billion, was not enough for them, alright? Um, Oh, for the Sora one, heard about. Yes, yes. Like, even like, imagine the money. Like, they were gonna earn that amount of money, but the cost of earning that money was higher, even higher than that. So, um, even today, like we are using cloud, but I know that I'm burning like a $1,000 token, but I pay $100, right? Um, there is someone paying that money for me, basically. So, um, so they should find a way to make the cost, get the cost lower, basically. This is the way I have found. So that's why I'm doing these streams in English, so that I use English even better, right? And I share the journey with you guys. I appreciate you being here. It's fun to learn, to get to discover together. And I'm hoping for the best. So this is what I can do, all right? And I'm pushing my limits. So last Sunday we were, about to do 18 hours long session, but sadly the stream got cut. I think, I don't know, and after 8 hours we stopped. But I will try doing another one on this Sunday. So it's quite fun to study and learn these. Time to look. Yeah, yeah. We're gonna do this. Like, I guess there's an issue with my internet. Like, after a certain amount of time, it may cut like a 1 minute or something. But even 1 minute is enough for Twitch to end the stream and start a new one. Yeah, I guess I was talking this about this video. I don't know. Yeah. 2 years earlier. All right. But he also like here he doesn't say this, but in that video he also said, I mean, maybe the before, like even before that video, AI was AI is creating slow code, so uh, AI cannot take replace engineers. He also said this, but of course he doesn't mention about it. We have users who do hundreds of tasks a week. The consequence is the cost can go very high. Microsoft exploring DeepSeek over OpenAI, and Anthropic as Copilot cover moves use page pricing. They are expensive, guys. They are literally expensive to use. Um, the infrastructure that you need to build is costly, basically, all right? Not the running the models. For example, we are asking question to cloud, and I suppose there are two H200 GPUs connected, maybe even more. They answer, like they are the one that answering my question, answer my question. So, and the cost of those GPUs is like, I don't know, it was, let's check it. Price of H2 GPU. It is $30,000, guys. It is this is why it is costly, all right? Like, for Claude to be able to answer our questions during our streams, we need two of them, right? This is a price of a car, basically, and I'm paying $100. I don't pay $30,000. I cannot pay. Waste their money by asking stuff. Claude, who is it, Jason in my copy? Okay, they send annual salary of yes. Like they are costly, even sometimes using one of them is not even enough, right? Like, I hate the term AGI, all right? Like AGI, like I have AGI for me, all right? If I'm able to create this application, right? If I am able to create the game that I mentioned earlier, I have AGI on my hands. Don't expect AGI to be, super intelligent or something. If it can follow the rules and apply it basically, and find where it may be making mistakes, right? This is enough. AGI is overrated, I think. Assistant is the more proper term. Yes, quite better assistant. Like, look at the code, like look at the node it generated, all right? This is enough for me, guys. I didn't have to, like I would have to spend 10 minutes to generate this code by myself, right? As a node. But it generated in 1 second. So this is enough, guys. And for example, we have an application, and I shared the screenshots of it, and it created this application, and this is enough, guys. This is enough. And I didn't know about the Monaco editor. I asked AI that, I like, is there any open source library that we can use? Because this little thing we see here, guys, it is hard. Like, it is like created by Microsoft engineers, right? Even though this looks easy, like there are tons of little things that we need to handle. So like even you can create that library by yourself, like using AI, but it's hard. So instead of creating this IDE basically, right, we used open source one, and AI is quite capable of using open source libraries, all right? This is good enough, guys. A few polishing here and there, and I think this canvas might blow up a real cool. Yeah. Like, this is good, man. This is good, guys. Let me tell you this, right? And like, I can press dot. Like, look at the camera movement, guys. right? I can press space and I can try, I can I can start memorizing. Look how beautiful it is, right? I can go that, I can go there. And even we have a search bar over here. I can search for a put method, right? Like it cycles through all the put methods we have. So in case we forgot how to use put method, we can look at it. All right, here. This is a platform to practice and memorize, Java, Python, any code, lead code, everything basically. Now it changed. I'm watching the ad to support him basically. Let me mute that. All right. Oh my gosh, another. I need to buy premium. Anyway, guys, the point is he also admitted, all right. Nobody knows the future, so forget about trying to guess or know the future. Let's focus on what we can do. We can learn this method. So where were we? We were reading these, right? The key mental shift, a method level type variable is filled in fresh every single time you call the method. But now the question is, how do we call the method exactly? How do we provide this information? It is not fixed once. Each call gets to pick its own E. So the method declares its own time really means every call to this method privately chooses what E is for that one call. How do you supply? Yes, provide, supply. There are two ways, almost always you use the first one without even. Let Java infer E from context. Java looks at the surrounding code and figures out what E should be its own. Java looks at the surrounding. What is this guy? How does alright. This is funny. Java looks at the surrounding code and figures out, alright, the Java is smart, guys. It is smart. Alright, this is how it reasons. The variable on the left wants this, yeah. So for this particular call, oh my gosh, that's nice. This is very nice. So yeah. The compiler does this actually. For this particular call, it must be string. Nice. So the way it understands the value, the type that it should use is string by looking at this part, declaration part. You never type string inside the call. Yes, like this is what I was talking about. All right. Java inferred it from the assignment target. This is called target type. Oh my god, we have even convention about this, guys. Um, convention about what, guys? Generic, right? Why don't we have? Yes, we have generic. Oh, lazy skimmer, welcome. Welcome. How are you? How are you doing? Type interface. Hmm. All right. We can also type interface as well. Here. Let's see. All right. We have this one. All right. So, how about this? Now, how does it understand it should use string? Let's see if we have an explanation for that. Same method, two calls, two different is like a string integer. When the method takes arguments, inference comes from the arguments instead of the assignment. But the thing, guys, so this is initialization of a list of integers basically, and there is also another way of doing this. All right, uh, I thought actually we can use also like we can add integer here, like a 1, 2, 3 here. But here in this example, all right, they are a little bit different, but let's look at what we have. It was array list, right? Or even better, guys, we have a search, right? List. Let's see what we have. So yes, we can do this too, yes. But we can also use var, and so that it can also understand the type of the inputs by looking at the arguments. Inferred as string, like this is the term we need to use, inferred as string from the arguments. All right. Tell Java explicitly the witness syntax. Oh, this is also nice, guys. Actually, guys, we can also add a feature for pasting images to these nodes. Like this looks kind of cool. Okay, XP we can explicitly, and the other convention we have was, what was it, guys? Target typing. Target typing. All right. Let me write it down. Target typing, and the other one is explicitly witness. The witness syntax. We have a witness, guys. Don't worry about it. All right. Class level T chosen once when the object is built. Nice. We have studied this and we have learned about it, guys. This is cool. As we initialize, the T is now chosen. I mean set. Method level, like a class level and method level. For example, here is a string. This is in here. It is integer, and we also like in the first two examples, inferred as based on the type we have inside this, and at the last one we are explicitly saying that this is gonna be your type of your element for your elements. When would you ever need way 2? Mostly when there is a genuine nothing for Java to infer from. But how can it be? Somewhere ambiguous, like passed straight into another method. Nice. This is nice. Yeah. We don't have the declaration part. For example, here we literally pass an instance of an empty list. And this is where we may need to explicitly say the type. This is nice. Oh, we can. Oh, that's nice. That's nice. All right. I have remembered, guys. We have a skill, right? Um, let me call it timestamp. All right. Instead of taking notes each time we have an important information, let's make timestamp. Update the timestamp skill. All right. Now we have talked about why we will need to use explicitly saying the type for list.off method, right? Create a note in our website for today's stream, basically. All right. Press enter. Yeah. It would be great if I started earlier, but I forgot, guys. Stream note skill. This is important. All right. Color Azure. Let's see. Oh, this is nice. This is nice. I like this color. All right. Let it add this into our website. This is good. Gotta go for a bit. See ya. All right. Americano redeemed. Rosemary roll sniff. Let's sniff it, guys. This smells good, man. Now my brain cells are gonna function better. Thank you, Americano. Take care, by the way. All right. Yes, create it, and after that, give the link. All right, we have learned about this. Now, what can we do? What other nodes we have? Okay, greedy part 3, 2, and 1. Let's see. Oh, we have an army of questions, guys. Look at this. we have an army of. All right, let's start with the first one. Like, for us to be able to use the dot, we should select, but without select there, maybe we can create another cycle interval where we don't need. Maybe we can use comma and cycle through nodes from starting from 0 to basically end. This is maximum product summary. Oh my gosh. Let's try typing. All right, we have a class solution. Let me try this, guys. I kind of remember the cadence algorithm, basically. Public, yes. Integer max product. All right. It takes integer array. All right, it can. We should also handle this tab thing. Maybe I should also use CMD. I should also maybe hold CMD. Integer. So we like typing this like this won't teach us anything, I suppose. But let's try what we get. We are initializing max. All right. This is the first. All right. This is the first item, right? This is how we basically find max among a list, right? We also have minimum, and we also set it to to the first element. We're gonna compare it with others and update it as we go. So this is initialization phase of our algorithm. So we have a for loop. The for loop will iterate true nums, I think. Oh, what? A space. Integer nums, yes. Ah, we are using index base. All right. We in cadence algorithm, since we need a prev, we start it from 1. All right. Because as you see, we get the first one, so we literally have a prev. So we start from 1, and actually now the thing I'm doing, guys, is trying to remember the animation we have, right? Like here we have. That's why the animations help. Like I don't try to memorize or remember the code or algorithm. I literally try to memorize the animation. Let's see. We start and from 1, and we in each step we were deciding if um, we need to start fresh or extend, basically, all right? Like a extend or start fresh. We were doing this by using max method, but what were we assigning the result? Like we had something like a math max, and the first one is let's say start fresh option, right? And the second one was extend, basically. So we need these two operations, basically. How do we handle it? So to extend, we need an answer, like array basic. So answer, I think, is our array, right? No, we don't have an array except the argument nums. Maybe extending means, so we don't need to simulate an array, like a dynamic array. We don't need to have an array list and dynamically add or start fresh, all right? We only need the value, the summation of the current array. So we have max and mean. In each, like I'm trying to remember the animation. So in each step we were compare. Another trick was if the prev is negative, we don't need to try extending it. We literally, there is only one option, and we literally need to start fresh, right? So maybe we can have an if statement where prev, basically, but how do we reach to prev? Where is our prev, guys? We have max and min. Maybe I should use max. Like, I mean, if I had something like prev, or maybe even index, right? Instead of values, like here, like if we had something like prev index, right? Then I will do like a nums, all right? Prev. If it is smaller than 0, then I will start fresh. But how do we represent starting fresh? Yeah, how do we represent starting fresh? Like, I know the core idea. Core idea was, if the prev means prev is sub problem, basically. It can be extended version or start fresh, doesn't matter. But we can imagine our previous a sub problem that we have its answer, right? If that prev gives us a negative, we should start fresh at this index, at index of I, right? If it gives a positive value, we should extend our current window, basically. So this is how we find the max product. But the question I have, Now you can create. Oh my gosh, I was talking whole time. I didn't realize I was talking during whole time. It's gonna create a huge long transcript, but um create another timestamp. Now we are trying to solve recall, basically maximum product summary problem. And the part I am struggling with is like I know the core part basically, right? um like we should literally start fresh if the previous gives us a negative one, but I couldn't figure out how we represent, you know, prev basically, and how do we start fresh basically, like the representation, the code representation of those ideas. um so knowing, understanding the, you know, core idea is something, and typing, like knowing the representation of the logic is kind of different. So if the prev, but we don't, actually this is not the correct way of getting the prev summation. Actually, where do we hold prev? I guess we are, like, we have the prev here in max, guys. All right, we should think about or min. What is min? I don't get this. let's let's watch, guys. We have a running sum. That running sum, if it is below zero, we start fresh. But here we don't have running sum. Like, I mean, either max or min is running sum, or maybe combination of using these two. Let's see. Like here, for example, the running sum was -2, and we literally start fresh, and our sum is running sum was 1, and we come here, and since the, you know, running sum positive, we add the current one, and now it is negative. And in the next step, we're gonna you know, get rid of the negative running sum, and we're gonna update running sum with the current element. Maybe that might be the representation of starting fresh. The update, let's use max as a running sum. All right, if max is below 0, we make max equal to current element. All right, if it is not, we should extend. How do we extend? We add, I mean, we add the current element. I mean, if we had a running sum, it would be great, right? Like if we have running sum. All right, and we can set this running sum to nums 0, right? And if that running sum is below 0, we update that running sum with the cursor. We literally start fresh here. And if it is, maybe we can add continue here. I'm typing what I have in my mind, basically. If it is below 0, we start fresh and continue for the next iteration. But we should also store this. Alright, the store mechanism is something. The correctly handling the running sum is another. All right. Now focus on the, you know, handling the running sum. And if it is 0 or above 0, we can assign this. I mean, add this. I mean, add our current number onto this, right? yeah, so I guess this is the way how we handle the running sum actually. This method won't return the correct answer, but it will be handling running sum correctly. But we have like a max method, um, but I don't know how to use it. Let's see. Now we have talked about, you know, we imagined what would happen if the in the answer we what would happen if we have running sum in the answer, and I tried typing the code, typing the part where we update running sum. All right, and in this code we update running sum. I mean, we start fresh basically when the running sum is 0, and the representation of starting fresh is updating running sum with the current element basically, right? And we continue. And if the running sum is 0 or positive, above 0, we extend basically, right? The running sum. And when this for loop ends, so if we add a mechanism to store this running sum, I mean store the maximum of this running sum, we can return the maximum of it, I guess, right? Let's try typing like a using a mathmax, right? Current running sum, or now I kind of remember it was something like running sum or running sum plus current character. So this means extending, right? This means no, it should be nums. This means starting fresh. This means extending. So in each step we don't do this actually. Like we don't like based on the condition we don't eliminate the other option. Like since we have a continue here, we eliminate. I mean finding the extending basic. Instead of this, we literally discover each option and take the max, and we're gonna of course we're gonna assign it to this one. So this means all right. This means calculate this one, and update based on the condition. All right. Because in the previous version, all right. So let me take a screenshot as well. I think we are getting. So this is a new version, and in this new version, I realized that like we don't need to eliminate discovering other option. Like in the previous code, we were literally using if statement, and we were using the continue, right? If it is below 0, we literally starting fresh, and we don't discover the expanding option, expanding choice. But actually, we need to do this both, and if we get the maximum of it, then it's gonna be good too. But I think it would be also great to see the if version of this max actually. Actually, it is easy. Like literally calculate. I mean, we can use another if, but the previous if I was talking about is kind of different. I mean, here we calculate both of them basically and take the maximum of it basically. But in our previous code, we were literally not discovering basically. So this is how we calculate the running sum. Now we so by the I mean, do we get the maximum running sum by the end of this for loop? This is my another question. So we calculate these running sums, and after we get off this after we leave this for loop, what do we have at our hand? So after what I mean is after we leave this for loop, what do we have in running sum variable? Do we have our result basically, because I remember there was another mathemax case, mathemax line of code where we managed the storing this information, but I don't see any reason to do that. I mean, currently we literally, update it when we find bigger or greater than, right? All right, let's see. So create a timestamp, all right, and then answer my question. Like, I don't want to look at the solution because I guess the solution we have now is slightly different than the solution I remember. I'm trying to remember. But I remember the part where like there is a logic to store the answer globally, right? But sadly, interestingly, or let me put it in this way, I think this is enough. We extend, we start fresh, we extend, and we store the maximum, right? And if we return, I mean, the running sum, that's gonna be it. Let's see. All right. So, loop ends, but running sum 3, but the real maximum is 4. The peak happened at I0, then got dragged down. But forget about having the max peaked at index 0. Would be able to get the correct maximum. Forget about having max peaked at index 0. If we have peak in other places, basically, would be able to get the correct max using this method. Maybe this other max line is specifically for handling that edge case. Can it be, guys? Yes, the whole point of updating answer every iteration. Wherever the peak lands start. We need it. Hold on, guys. The peak being at index 0 was just the easiest example. Let me put it in the middle. Alright. The best subarray is ending at index 1. Alright. Why it works when the update fires? At index I, running sum is the best subarray, ending exactly at I. Here's the guarantee that makes the method complete. Every possible subarray ends at some index. The optimal subarray ends somewhere, say index k. When the loop hits k, oh my gosh, I don't want to understand this. The only thing to find the running tells you is the best ending at the last element. This is what I'm trying to understand. I mean, the running sum does not mean, we have found the maximum subarray, basically, right? But then what it holds, the meaning of it is kind of different, guys. I mean, like, I thought, like, we have, what does this running sum mean? Running sum means, yes, this is the best solution that it has calculated until it is indexed, basically 0, 1, 2, and it's gonna be 3 now. Yes, now the highest value that it could get is 4, which is max. So actually this max is different, guys. This max is the highest point that running sum get. There is a slight difference, all right? But if we return the running sum is running some. All right. I kind of slightly understand it, and like create another timestamp, all right? Because like I have, like we have the animation of it, all right? We have the animation of it, and when the running sum is negative, right? We start fresh. So like I need to understand the meaning of running sum basically, because I imagine running sum as an answer for, let's say we have a prev, all right? Let's say we have a sub problem, like let's say we are at index I, and the answer, that the best answer we could get from prev, like I minus one, is, let's say, running sum, right? This is the answer coming from our, like it's from sub problems, and this is the best possible answer that can come, right? And now we are processing the current element, and after processing this one, we should have, up until this index I, what is the, best result basically. But apparently this doesn't work like this. There is a difference. We should explain this. So the way I internalize has some flaws apparently, guys, because in my, like the version I have, I remember, um this should be enough basically. But like 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 running sum, like in my perspective, based on my perspective, from my perspective, running sum holds the best result. um I mean, previous, from our previous options, running sum is the highest one. And if we process the current one and calculate the, new running sum, then it will be answer basically. But it isn't apparently. And let's see, guys, this is important. um Nice, you define subproblem wrong. All right, yes, this is the mistake we have, I mean I have done, guys. And that one wrong, that one wrong word is everything. Yes, here is the model you described. At index I, the best answer we could get from prev is running sum. After processing the current element, we should have the best result up until index I. Yes, this is just what I remember. That phrase, the best result up until index I, is a loose definition. It means best summary anywhere. Yes, and you are right. That is not what running sum is. That mismatch is the whole confusion. Alright. The real definition is narrower. Running sum best subarray that must end at index I. So what is the difference between these two? Like I don't see any difference. It is forced to include numus I. I guess the difference. The difference is this. I mean, the difference is only the fact that if we include the current one, or we don't. If you include, like this is the correct one, if you include. But in my design, running sum was the previous best answer. Actually, in the logic part, it is the previous. I mean, so let me ask you this. Ask him. So now the question I have is, like, in the logic that I learned basically, like at least the way I learned it was, if the running sum is negative, there is no need to, accept our history, our inheritance. So we start fresh basically, all right? And this logic works correctly. But when it comes to typing the code, you tell me running sum means something else. Running sum, you are telling me that running sum includes the current character. Like, I mean, so based on, then you should answer me based on what we decide. Either we include, or I mean, either we extend or we start fresh. maybe the enlightenment moment, guys. Maybe we just don't. We don't decide based on either, if it is, if the running sum is smaller or good or bad. We literally explore everything and get the maximum of them. I guess I need to shift my understanding, but seeing this as like seeing running sum as the best answer from our sub problem was good, because imagine like a house rubber problem in its recurrence relation function. Like we defined our current problem using our sub problems, and I thought we were using the same thing. Like, could you please clarify on that? Because I guess they are different, and it is quite important. Like, honestly, guys, frankly, guys, like I literally imagined Cadence algorithm. I understood Cadence algorithm as the DP problem called house rubber. There we had um like we had houses, all right, and we can rob the last house. I mean, we cannot. The rule is you cannot rob the neighbor houses, all right. And we literally defined our recursive relationship. Like we can either um you know rob this house or not already. So we defined these two states. What do we get by robbing? By robbing, we get its value. All right. Let's make it index I, right? We get its value, and then the sub problem we should solve becomes this part, right? I mean plus func I minus 2. So if you calculate this sub problem and then add the current value, then this is the first state. The second state is you cannot, you don't rob the house. Then your sub problem, let me, come on, man. Let me remove that part. And the sub problem then becomes this one. And this is the func I minus 1. So we now our function definition, the the real, the original function definition becomes getting maximum of these explorations, basically. All right, like, but I thought they resemble to each other. Let's see. Yes, is house rubber study, but one word in the state definition differs, and it is everything. Let's see what that is. I have also, I don't have the juice on my phone. Let me charge it. I'm back. So it is everything. You are absolutely right that this is the same family as house rubber. Current defined problem current defined from subproblems. The difference is what the subproblem means, and it explains why house rubber needs no separate answer but Cadence does. In house rubber, function definition is best using houses from 0 to index I. All right, from 0 to index I. In Cadence, best subarray ending exactly at I. What is the difference, man? Best subarray ending. So we don't define the start point, I guess. Like, this is the difference. So like they quite resemble to each other, guys. So difference is we don't have this start point in Cadence, basically. Recurrence relationship is taking these, I explained this earlier, and here it is something. It doesn't mean anything. An answer Last cell is the answer. That is something interesting. I think n is length, and this is the house. I mean, it means the function I. If we calculate this one, and if we manage to return some value to our color, then we're gonna get um, an answer basically, right? But here in cadence, yes, this is why actually. This is why. The answer is maximum. Hmm. All right. So actually, the answer is this. I didn't understand this, but the answer is this. All right. Um, because in house rubber, the last like func I, right, is the answer. But here func I isn't the answer. Why the difference? One word, contiguous. House rubber is a sequence problem. Gaps are allowed. Rope house I plus the best from is legal even if the best leaves a gap. So DPI can safely mean best anywhere up to I. The loose definition composes because you never need. So I guess, guys, the answer is gap basically. In house rubber, we may have gap, so we define our problem like a best answer, func I minus 2, the best answer coming from that sub problem. But in cadence, it should be contiguous. Yeah. So yes, we know that, but and because it's best up to I mean, so DPI can safely mean best anywhere up to I, and loose definition composes because you never, the word composes, because you never need adjacency, and because it's best up to I, DPI minus 1 already carries running maximum forward, guys. The last cell is the answer. No sweep needed. Caden is subarray problem, must be contiguous, no gaps. To attach nums I, the previous chain must end at I minus 1, guys. Yes, this is the. Alright, this is answer. This is the answer, guys. The previous chain, alright, so like this line, guys, is our answer. The previous chain must end at I minus 1. They touch. In house rubber, we don't have this rule. We say the best result that you can get until I minus 1, like there is a difference, all right? The best result you can get until I minus 1 versus the best you can get, and that answer should also, like, must also end at I minus 1. So there's a difference. So DP is forced to mean ending at I anchored. So, but an anchored value isn't the global max. The winner ends at some index, not necessarily the last, not necessarily. So you see, oh my gosh, you sweep, answer, you sweep, answer. What does sweep mean? Answer equals, so you sweep, you search, baby. The rule, if the recurrence needs adjacency, like a contiguous, your DP must be anchored to I, and then you sweep for the answer. If gaps are allowed subsequent, I'm familiar with this one, guys, I think. DPI can be best so far, and the last cell is the answer. Oh, like I really like this one, guys. I really like this one. We have lots of full screen. I guess I cannot. Yes. Let me. Where is our nose, guys? I think this is our. And let me open the capture. Do we have something DP? Yes. Uh, this is good, guys. This is good. So you were right to see Cadence as Hausreber style DP, same machinery. And the single difference is that subarray forces anchor state. The anchor state is what splits running sum, the composable subproblem from the previous chain must end at I minus 1. So DP is forced to mean ending at I anchored, but an anchored value isn't the global max. The winner ends at some index does not necessarily. Yeah, so like I guess we have. The rule. Yeah. So you were right to. All right. Want me to drop time step coupling? All right. All right. The way I remembered was from perspective of Hausreber, like without needing to have like a touching mechanism. In this problem, they should touch, and the meaning of touching is it literally changed the way we define our problem, our function, our DP array, right? Our definition, since the meaning of definition of our function changed, now we needed a new part. See ya, Duje. Duje. Welcome in Americano. I am hungry. I wanna have my lunch. But I also wanna understand and wrap up this part. We figured that like it is good. Like I'm happy that we have tried typing the code, because I literally remember the Hausreber problem and this differs from that. Oh, all right. Yeah, so let's see the answer. Like I don't want to see max, I want to see running sum, right? Maybe max is running sum. We also should multiply running sum with the current character. If it is big, if the starting fresh is bigger, we make max is actually running somewhere. We can see max as do you know cadence algorithm? I thought I do. But I guess I resembled it to Hausreber style problem, and but they differ because the fact that we need to make it like a chain, like the subarray should be contiguous, it changes the way we define our recursive function. All right, the definition change also changes our code basically. Because I'm familiar with the Hausreber problem style DP problems, like saying that I minus 1 is a subproblem, and now we're gonna compute at index I. All right, I can define the recurrence relationship using those, but here when I try to apply this very same logic, then running sum should mean I mean we would be able to return running sum as an answer if this question was something like a Hausreber, but it isn't, because the definition of our problem is the best result ending at index I. All right. Yeah, actually it quite resembles like a best result that ending at index I resembles to best result from index 0 to I. Like they resemble, but it's asking for product, not sum. All right. I thought we are solving cadence algorithm, but it doesn't matter. Like we can change only one operation. I was doing for remembering the cadence algorithm. Alright, alright. Yeah. In cadence algorithm, it is summation and it is maximum product. So it is new version of cadence algorithm. Thank you for pointing that out. Um, so we can change this to this one. Um, but we learned something new. It changed a lot. Does it? I remember a question where we should discover two paths. Oh, yeah. So that's why we have something like min, right? Yeah. You're right. That's why we have something like min, because we may get a high result by multiplying two negative numbers. So that's why we need to discover those two paths. Yeah. All right. Like I thought, I was trying to remember the cadence algorithm, and then here we have min, and I thought, what does that mean? All right. This is product, and yes, as you say, it changed a lot. So we need to discover uh, two things at the same time. I mean, maximum and the minimum. All right. Then what? Now that I know running some holds in each iteration, so we also should store maximum among them, and we also should store. Let's say we can store the minimum. What are we gonna do with them? You should run your code to easier to see why it's wrong. Uh, I got your point. Um, maybe we can add. All right. Now maybe we can add running mechanism to our application. I understand your point. Why we need why it is different than cadence algorithm, because in cadence algorithm we only store the maximum. Here we need to store minimum as well, because by multiplying two negative numbers we can get a new maximum. Basically, this is why I have solved this question before, and this is what I remember from it. um, let's make our app be able to run the code. Mm, let me try. We discovered two paths. Actually, we discover. How do we discover min and max at the same time? When? What are we gonna do with them, basically? Because summing two negative numbers give us a positive number. Actually, not to lose negative running sum. Actually, because in the cadence algorithm, negative running sum was not giving us a better result, so we were getting rid of it, basically. Um, but here we shouldn't get rid of it, because next character can be negative as well, and we can sum. All right, in each iteration we should multiply running sum with the current one and update max based on that, and we should make running sum available even if it is negative. Basically, how can we do that? Using min method apparently, but how? If the current minimum, like running sum multiply with the current character, like this one. If the current number is smaller than multiplying with some, all right, let's say we are getting our minimum using this one, and in each iteration, like how do we communicate, how we are gonna communicate with min and max, you know? We now have the min, but what are we gonna do with it? Mm. Create another timestamp, and I realized that this question is not a cadence algorithm but maximum product array, but it was good practice to remember how cadence work, and we figured the this even slight difference means a lot in cadence algorithm. And now I try to solve maximum product array, and I remember we were discovering two paths. So and in cadence algorithm we can get rid of the you know negative running sum because it won't do any good to us. Hmm. And but here we should discover two, I mean, two ways basically, but I couldn't figure out how we, like, I mean, the reason is like by multiplying two negative numbers we can get a bigger number, but I don't know how. Like, this is what I remember from last time I studied. Create a timestamp about this. Karkus said it is still cadence algorithm. That's interesting. I thought um like only the summation version of it cadence. And also we can make our app mm, run some code on it. Thank you. Now I need you to make our app like I want a run button basically, and I want to be able to run up my code in both in maybe in recall mode. All right, in recall mode at the run button, and I want to click on it and I want to see compile time error, runtime error, and output like a basically a lead code version. But we have this feature on lead code. Maybe let's open lead code max pro because we need some input and output as well. All right, guys, I'm too hungry. I guess I will have my lunch and then continue with this question. But I really wonder how we combine these. Yeah. Let's take. What time is it? Alright, let's take 30 minutes break, guys. Thank you, Lazy Sycamore and Carcus. I will try solving this question on lead code. But I still don't understand, like, the definition of the problem, right? The best result ending at index I. So why it doesn't mean, I mean, or why does it mean contiguous, right? Like, before giving a break, let me ask this. And also, like, can you also teach me, like, we have talked about this, but I don't understand how like this small thing can affect the course of our solution basically. Like, because we have one definition in Hausdorff problem where we literally say that DPI means the best solution from 0 to index I. But here we don't have it. Here our problem definition is the best solution we get that ends index I. So like, what is the difference? So in the like a in the in the first one, we also like it also ends at index I. In the second one, it's also in the ladder one, former and ladder. In the form ladder one, it also ends at index I. But the start point I think differs. But you didn't mention about it, all right? You showed the same parts in both, recursive functions basically. You also explained the, the core part where in cadence algorithm it should be contiguous. I get it. But how, not mentioning about the start point help us determine or making it contiguous. All right. This is the part I don't understand. And also, yes, and also like using the minimum. Like, I understood the core logic, but there are some other points that I don't understand. So another point I don't understand is, how am I supposed to use min? And like the core logic is multiplying two negative numbers can give us a better result than multiplying two positive numbers. So we should keep those negative numbers basically. Maybe it means we should keep those negative running sums, right? So create a timestamp and after that explain those, all right? And then I'm gonna take a break. Now I see why Lazy Skimmer said that, um, do you know cadence algorithm? It is product version of it, and as he said, it changed things a bit. And now we need to figure out how we can keep the negative numbers. But this solution will be correct for what type of question? Yeah. Let me ask this to AI as well. Actually, for kind of house rubber kind of problems, it will solve. But how about the number wise? What would it get us? Your premise is the bug. House rubber's DP does not end at I. Where does it end? You said in the first one it also ends index I. In the latter, uh, yes. That's the misconception. House rubber's DPI is not required. Oh, now I see, guys. Is not required to end, but it might end, but it can also not end there. That's the difference, guys. In cadence, let's see, in house rubber is not required to end at all. DPI max. Take I and the gap at I minus one is legal. Mm. Mm-hmm. Mm. In cadence, start fresh, but still includes I. Extend also includes I. In cadence, both branches contain nums I. There is no way to get DPI without nums I. It's forced to end at I. In house rubber, Like a dp I minus 1 is literally don't take house I, so dp might be a solution like while I minus it does not and I. It's it's best anywhere. Hmm. It's best anywhere between these. All right. Mm-hmm. All right. All right. We in like we determine the possibility. We literally set the start and in and index points. I mean the possibilities. We define the possibilities. But in cadence algorithm, we strictly say that it ends here. It ends here. In Hausreber, the result that can end here. All right, there's a difference. Yeah, yeah, yeah. All right, all right. The difference is real. How does not fixing the start make it contiguous? You're right that I anchored the end, not the start. We fix the end at I, the start floats freely. Contiguity is preserved by how the extend step glues. Like while we are extending, we can, uh, if we are thinking it from index I perspective, like element I's perspective, there are some other elements before us, so we can append it or not. The start flows freely. So what about the start point? Like I don't know the start point. Contiguity is preserved by how the extend step glues. Yeah, let's see. Best summary ending at I minus 1 ends at I minus 1. Alright. DPI. We extended it, I think. Ends at I. I minus 1 and I are adjacent, no gap. Because DPI minus 1 is guaranteed to end at. Because DPI minus 1 is guaranteed and so if it is guaranteed to end there, so we know that we have that character, we have item at index I minus 1, we have that item, and I minus sits right next to I, gluing nums I on creates no gap. The result is still one contiguous run. The start point can be anywhere to the left, we don't care where, because every extension only ever takes on immediately adjacent element. Contiguity is maintained one adjacent step at a time. Why the loose definition would break contiguity? Suppose the EPI minus 1 meant best anywhere in 0 to, yes, so this is a good thinking method, 0 to I minus 1, and base run actually ended at index 3 while would be gluing index 7 onto a run ending skipping 4 5 6. That's a gap, not a subarray anymore. The loose definition can't keep things contiguous through the recurrence. That's exactly why Kalen is forced to end anchor. Forced to. So end anchoring is the thing that guarantees adjacency in the extend step. Which is the thing that guarantees contiguity. House rubber doesn't need it because rubbing allows gaps. May skip I versus must include I. Is what cascades into last cell is the answer. This is the summary of what we have done. Where is our notes? How you actually use min for the product? Yeah, this is my another question. Let's read it as well. Oh, Carcos. In house rubber, you are continuously extending the result, ending in a DP array of yes. Each index holds the best solution so far. And each new house extends based on previous. So your total solution is the last index, yes. Max subarray problems end up having DP array a little like So you want to keep track of the best seen so far, as it might not be the last element. Max subarray problems end up having DP array a little like -2 1 -2 1 -2 So you want to keep track in a house rubber it is increasing like DP array, or the DP is the solution array increasing. So when you reach the end, you already have the answer. So this is the version that I'm quite familiar with it, because it resembles to post-order traversal. When you get results from left child and right child, and then you find the answer. But here we have something different. Like the array we have, like the DP array, end up having DP array like -2 1 -2 4. So you mean on top of our recursive function like a DP array, we need another thing to get the answer we are looking for. So this isn't a question of making our DP answers like producing the correct answer right away, but instead using it in a way that also storing the maximum amount then will give. Alright, so basically we need intermediate step, like we use maybe our DP array like intermediate step. Alright, yeah, like -2 1 -2, so it alternate kind of changes. So but the answer is the maximum of them. Yeah. It now it clicked. Thank you Carcos. And I wanna paste it here and also learned. Yeah. Now it is clear. Yeah. So our function, like a DP function, cannot produce an answer right away, as it does, as it were doing for our house rubber. Because in house rubber, at each index, it was giving us the result. So the question might have asked you like a func 5 or let's say func 10, right? Like you can start finding solution like a func 1, func 2, func 3, right? You go, and when you reach like a func 10, you have your answer. Like I'm familiar with this. Finally, I'm familiar with this. But this is something a little bit slightly different than that. Thank you Carcos, I appreciate it. Our DP produces this, all right, not the answer. Yeah, this is exactly why. um all right, like I can understand from this part. Now how about the contiguity part? like like we define our function like ending index I, and we don't care about the start part. How does it provide us contiguity? Yeah, so mm, uh, so now the part I want to understand is again, show me other examples where like maybe other, I don't know, like in this problem it is not like house rubber problem, because in house rubber the DP array accumulates, all right, as it goes, it advances, it produces answer, and it gets closer to the answer we are looking for. But here we don't have that thing. Our DP, our function cannot produce an answer that will accumulate to the real and will get a real answer, right? And like it has something to do with the contiguity, I understand it, but how come defining our function as like an ending index at I, like we forget about the start point of it? So like I really want to understand the problem definition, right? How did we come up with this? And can you also show me some maybe other DP problems? um, because most of the time the way we define our DP is actually giving us like accumulates and giving us the correct result, right? I guess Caden is a little bit different than that, right? Actually, the last DP problem that we have solved, there we had a data structure that was kind of like this. For example, we have studied this um, maximum total value of covered indices problem. um I guess it was this, right? Like a problem where we were using prefix. I guess this here we don't have prefix. Maximize fixed point after delay. I need to find this. Longest strictly increase substring with no. Which problem that was? Let me ask it to AI as well. I guess it was not a DP problem, but a hard problem. I have solved a problem where we were using prefix idea and we were defining our DP using those prefixes, but I forgot the name of the date code problem. Um, in the hints, it also gave the DP definition, and we were using prefix idea, but creating the problem definition is hard, and also was hard, and also there were some other logic that we used on top of DP, like a recursive relationship, basically. Can you find that problem? Let's see if it can find it. I guess yes, I guess this one. Yes, it is this one. Maximum sum of m non-overlapping subarrays. Yes, and it is again subarray. So I guess there are lots of problems built upon subarrays. You are given an integer array nums. At most, oh my god, this is this is hard, guys. Yeah, it has found it, and oh, it is actually in our notes. Yes, like here we also had something for on top of the DP definition. Max over valid. Yes. Something like this, I think. What is the last subarray? The other logic on top, you remember, is prefix factoring. Actually, no, it was not like that. But for example, max over valid j, like I don't understand this part. Karko said, not sure if it helps, but another way to explain this is that in Hausreber, the DP array represents the best results so far. In subarray problems, the DP array represents the best result ending at this point. Yeah, like the best result ending at this point, but I still feel like um I still feel like, for example, um like these are index, all right? And if we find a best result at index 0, and then here, and if we find best, result ending at index 2, like I still have the feeling of, when I reach here, I'm gonna have what I'm looking for. I mean, actually, what am I gonna get this? Why, if we do this? Base result at index 1, base result at index 2, 3, and 4, ending, ending. Base result at best result so far, the best result ending at this point, ending, like I wanna, like Lazy Gamer said, like best result out of all subarrays which end here. The best result out of all subarrays which end here. Let's try drawing some subarrays ending. Let's for example, uh, we have this array, like, all right, and when we are here, the subarrays we may have, or let's say here we may have is, we have all the subarrays, right? 1, 1, 2, and 1, 2, 3. So among all of these, the best one, the best summation, for example, is this. All right, I'm doing this right, correctly, right? All right, ending here. So the best. So all right. So let's try again. 1, 2, 3, 4. Let's see. No, like 1, 2, 3, and 2, 3, and oh, that's interesting. One ends at index 0. Carcus. Anyway, I need to stop being lazy. Gotta go get some coffee and food. All right, all right. Thank you, Carcus. I wanna have my lunch too. Thank you. Take care. Enjoy your coffee and food. Lazy 1, 2 ends index 1. Yes, yes. Uh, ends index 1. I mean, yeah, but um, I mean, if we say we got the best result ending at index 2, right? I mean, let's imagine, let's imagine what this returns, all right? What this returns? What does this return? The best result ending at index 2, right? So array 1 does not contribute to the answer in DP2. You said something interesting. Does not contribute to answer in DP2. Array 1, 2 does not contribute to. Yes, like I should understand this. Yes, yes. Because in my mind it contributes. It let me take a screenshot. This is important. Like, because in my mind it contributes, like it accumulates. I mean, it somehow not accumulates as we have in house rubber. Array 2 does contribute to deep. You said something. You said something crazy, lazy skimmer. You said something crazy. Let me see. If I understand that, then I will understand the definition of problem. My friend lazy skimmer said this. Can you please create a PNG file showing in an example? I'm showing this on an example so that I can see with examples, basically, because I want to understand the definition, like a recursive definition, like a DP definition of this cadence algorithm, basically. Yeah, I should understand this because I think it contributes. So you are telling me that 1 2 does not contribute. Yes, I will understand eventually. Lazy Kimmer. I'm talking about your example where Oje is like 1 2 3 4. Yeah. So like we have 1 2 3 4. So array of this. All right. For example, this is DP2, right? I mean DP1, DP0, DP2, DP3, and so for DP0, subarrays are 1. Yes. For DP1, subarrays, yes, like a 1, and then 1 2. No, you are saying 2 and 1 2. Yes, like this is the part I'm doing wrong. This is wrong, and this is wrong. No, 1 2 is all right, but this is wrong, and this should 2. And for DP2, 1 2 3, all right, and then 2, all right. Like this doesn't seem different than I thought, but this does. Yo, I don't understand, man. What did I say? I mean, if we have 1 2 3 4, right? I thought if we are here, we have like a subarray of 1 1 2 and 1 2 3. This is different. Yes, the difference is here. I said 1 2, but it is not. It is, you wrote, yeah. 1 1 2 1 2 3. No, it is not correct. 1 2 3 2 3 3. Notice 1 does not.
The magic was in your hands the whole time. Now cast it.
Oh my gosh, what did I do? 1 2 does not end at 2. Notice 1. Notice we are looking from this, I mean, ending here. So in this array, subarray, it ends at 3. In this subarray, it ends here. In this subarray, it ends here. All right. All right, now I see. Thank you, lazy Sikama. This is the subarrays that we are generating and we are evaluating. We are processing. Yeah, wonderful. Yeah, yeah, yeah. Because I thought we are doing like a 1 and then 1 2 and then 1 2 3, but this is not the answer for, you know, DP2. If it were, then we would have, you know, 2 3 and not 1 3. Yes. All right, now I get it. Now I get it. So DP2 stores the best answer out of. All right. Yes, 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 yes. um all right, all right. Now the next part comes. um what are we gonna do with, for example, DP3 and then DP4? Notice DP2 does not cover 1 2. Yeah, yeah, I see. I see. DP2 does not cover 1 2. Yes, does not cover. uh all right, does not cover. mm, all right. So now I should imagine DP2, DP3, DP4. Yes. So let's try writing DP3 too. In DP3, we would start like a 4, 3, 2, 1, and then 4, 3, 2, 4, 3, and 4. But in house rubber, the DP represents best answer so far. Hence, why in that one we can just return the DP n minus 1. Yes. All right. The definition is best so far. If you find the best so far for the last character, it's the answer for you. So now I'm trying to see what am I gonna do with these. All right. What am I gonna do with these? Like we have one like a these like a 1 2 3 4 2 3 4 3 4 4, and here we have these. Like what is the relationship between DP2 and the DP2 and DP3? Like for example, say the best overall answer was from let's say the best is coming from 1 2 3. So let's suppose this is the best answer. We cannot just return DP3. Yes. Why not? Why not? Because we don't have 1 2 3 here. In DP3 we don't have 1 2 3. Oh, all right, exactly. Lady Sycamore said. This is why. So this is why we store each answer and we get the maximum of it. But how come we don't have 1 2 3 here? Why don't we? All right. All right. We are starting and all right. This is a strange pattern with numbers. So we start from somewhere, not index, because 1 2 3 ends at index 2. All right. Not index 3. Yeah. All right. This is what it means to have something like some array ending at. This is the meaning of ending. All right. We don't have 1 2 3 here. I thought we have. I thought we had, but we don't. So DP3 does not include answer that we got from here. I mean, it may miss actually, right? Do we have something similar? Oh my gosh, we don't have anything something similar. How? I mean, oh my gosh, every one of them is different. So what would happen in DP4? So again, we won't have anything. Let's say 1, 2, 3, 4, 5. Tooth. They are different. Oh, all of them is different. Wow. Because we have now new number. Of course they will be different. Because as Lazy Skimmer said, in DP we have 4, but in DP2 we don't have 4. So it's gonna be definitely different. So the numbers, the subarrays we are evaluating here is completely different, completely. Every one of them, not only I mean, not single one, but literally every subarray we are evaluating is different between dynamic DP2, DP3. Oh my gosh, yes, I like, now it makes sense. All right, thank you. I appreciate this, gamer. Now it makes sense. They're all different. This subarray is different. I mean, that we don't have this subarray here. Nice. Yes, yes. Like it looks like, but no, we have 4. All right, all right, all right. Because in none of the subarrays we evaluated in DP2, we have like a 4. We don't have 4, so they're all different. Oh my gosh. Oh my gosh. Now let's open the code for the sake of Lazy Skimmer and try typing the code. All right. Um. Now, all right. Now I know the cadence algorithm. This is why. All right. All right. So now at least I know. All right. This is why. Now we need to figure out the minimum. The recurrence is like this. Um. So all right. We totally different. All right. So we should store it basically, right? Let me first create like a result. All right. Start from 0 or minus integer. I don't know. Integer mean value, right? And if the running sum, I mean, we should update results. Like we should just, I totally understand why we should store each dynamic DP answer, but now we have something different here. Something that we don't have in like a summation cadence algorithm. Result, we should assign it to mat max of previous DPs. Previous DPs. Where do we have DP here? In running sum or in, let's make it running product. But all right. But where do we have DP2, DP3, DP4? I mean, I should compare. Maybe our DP0 is this, yes. And here we get DP1. So we can compare it with our result. All right, this is how we update. All right, we now store our DPs basically. Yes. All right, this is so we have DP2, DP1, 2, 4, 3.
You were not chosen for the easy problems.
Oh my God.
You were chosen for this one.
So we have this. I can also connect this. So now we should have something here running product. The way we process, we create this thing. All right. We need to have something different. Like something about the minimum that is specific to our to this problem basically. But what that is. So all right, now let's think from the this part. Like we have mm, 3 2 1 3 2 and 3. All right, let's say we have 2 1 and 2. All right, um and we have 1. We start our running sum here, and we can multiply with the previous one, right? We can multiply our decisions are, we can multiply this previous, or we can start fresh. this literally this is literally giving us what we are looking for, right? We can append basically, right? Or we can start fresh. um DPI, all right, for example, dp2 is pick the subarray you get by combining ri here is 0 1, or I should make it 1, dp1, combining r1 current element with dpi minus 1, which is dp0. There is a all right, these are we can do this because we are sure that we have this element in the previous dp problem, because it is ending at 0, so we have this, so the contiguity continues basically. All right, now we can define our problem like this: ri current element with the previous dp problem. Yes, best answer out of all subarrays ending. All right, now I understand ending at I minus 1. Pick the single element subarray starting fresh. Yeah, so yes, but how about the negative part? I mean, like you mentioned, like what you shared is cadence algorithm basic, right? DPI get the current element, right? Maybe maximum current element, or current element, I mean I, right? Current element, let me try typing down. Get the current element, start fresh, or get the current element and the previous sub problem, because previous sub problem is also ending I minus 1, so we have continuity. I'm just talking about general subarray. Yeah, all right, this is general subarray. Yes, yeah, I get it. Now the thing, like the special thing about this problem is, now that we understand the this general formulation, it is about understanding what kind of subarrays we generate, basically understanding the meaning of ending at index I. This is the meaning of ending at index I. And then now it is time for us to 1 2 2 to understand the, because we may have negative numbers, right? We can have negative numbers, so we should be careful about it. But how? So we should observe basically, right? For example, this is dp1, right? While calculating dp1, we are adding, like we are appending current character with the previous subarray basic and previous sub problem, right? Or we start fresh. Um, but what if the previous sub problem gives us a negative one? Let's say -5, or yeah, -5. If we are -2, then we can get something to store here. We may get something to store here if it is negative and we are -2. Appending with the best answer dp0, all right, which is 1 in this case, but could have been different. Yes, appending with the best answer. Appending with the best answer. We may have best answer from I-1. Yes, so previous sub problem. Yes, best answer. This is I-1 sub problem. All right, this is I-1 sub problem. Best answer coming from dp0 basically. But what are we gonna do with it? Like, we can discover appending or starting fresh. But if it is negative and if we are positive, then we are gonna end up getting dp0 is I- sub problem. Yeah. 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 dp0 is, since our I is 1 here, our previous sub problem is this. The 1 is just the previous element. Yes. Yeah. Previous element, previous sub problem. I mean, this represents the best ends coming from previous sub problem. Yes. Like how you draw the red arrow, it's wrong. I mean, by drawing this rectangle, I meant sub problem. I mean, we can have, for example, here the previous sub problem is this. This is how I draw. I mean, this is sub problem. Yeah. I mean, I draw sub problem like this. Like, this is our sub problem here. Got you. Yeah. Actually, actually here when I try to the previous sub problem, here it includes, since it's best basically. All right. It may be 1 2 or 2 or nothing. The dp array already stores the best. Yeah. All right, stores the best. All right. Now, what do we do with the best? All right, so dp I-1, all right, plus the current character or starting fresh. So for example, we discover, actually this one, for example, really, sub problem. But this one is not a sub problem call, but only a choice. Like drawing decision tree is kind of hard, kind of changes in every problem basically. Left part includes function call, but right part does not include function call. So they are not same basically. So dpi minus 1 restores the best result, but what are we gonna do with it? So 1 2 3 2 3 2 2 1 2, all right, and 1. The problem with starting fresh in maximum product subarray is that later a second negative number will give a better answer. Yes, yes. The problem with starting fresh, we have a problem with starting fresh. All right, all right, all right. We have a problem with starting fresh. Here I can see this is starting fresh, but here which one is starting fresh? This one's starting fresh. These are the candidates of best result. One of them is best, so our DP problem gives, I mean this DPI minus 1 gives either this one or this one. Wonderful, wonderful, lazy, wonderful. And this is starting fresh. And you are telling us that there is a problem with starting fresh. And that problem is, that's the general pattern. Yes, all right. That's the general pattern. Is later, but in this problem, starting fresh thing doesn't really work. It is because we may have, like, by starting fresh, we may lose possible candidates. I think is what you mean. Because I don't know why it eliminates some possible candidates for us. Let's say we have a negative number, all right? For example, this is negative, right? So if it is negative, in our previous solution, we start fresh with the positive one or bigger one. Yes, bigger one. You don't distinguish negative or positive, you distinguish smaller or greater, basically, right? For example, this might be, I don't know, man. You say starting fresh is does not help us in this situation, because I need to see the, I really need to see the negative parts. I mean, the parts that can cause problems. Starting fresh can cause some problems. Then I should type some negative things, right? Let's say 1 minus 2 and 3, minus 2 and 3, and 3, right? 3. Starting fresh gives us 3. In this case, there is nothing wrong with it. Let's try making it minus 3. So 1 2 minus 3. Yes, I guess this is the example, this is the case you mean. 2 and 3 and minus 3. So starting fresh gives us this one, and best result we are getting from previous is 2, and if we multiply it with the current one as well, we get minus 6. And if we get the maximum of let's say minus 6 and minus 3, it will give us minus 3. So there is no problem with that. I don't see any maybe I should also focus on the future, because there is no problem with it. So like return the maximum of it, there is no problem with that. But what if we have 1 2 3 and maybe minus 4 in the next one, I mean 2 minus 3 minus 4 minus 3 minus 4 minus 4. All right, so our problem discovers starting fresh, right? starting fresh, and the possible, I mean, best result coming from here. For a second, let's assume we have a optimal way of finding it, and the optimal result is -3 actually. I mean, our approach should return -3 as a best result. We don't know how, but let's assume it returned that. And how are we gonna decide if we should? So we can. All right. The the way we decide is, all right. Either we start fresh. Starting fresh gives us -4, or we can multiply, I mean, previous with the current one, which is 12. So if you get the maximum of it again, there is no issue with that. I need to see the case where it may cause the problem. Oh my gosh. Like, what if it were 4? Let's try with 4. Maybe let's try 2 minus 2. All right, let's try. Like 2 minus 2 minus 3 minus 2 minus 3 minus 3. 3. All right, best result. I mean, like, we assume that we know, like, our function returns the best result, but we don't know how would it do, how is it gonna do. But best answer is -2, right? Best answer is -2. All right, so our options is either start fresh with -3 and multiply -2 with -3 and 6, and we get the of course we should get the 6. Yeah, so we extend it. I still don't see, because the style I'm using is, but answer is 12. Oh, that changes. That changes. Answer is 12 because, yeah, 6 and, oh yes, the real, so our algorithm tells 6. Yeah, and this is DP2. There is something wrong. DP1 and DP0 and RDP2, and RDP1 returns -2 and DP0 is 2, and even maximum of them is still 6. So our function returns 6, but the correct answer is 12. All right. Why did it happen? Because our function returned, thank you, Alaise. Because our function returned maximum, right? Maximum of it. All right. This is how far we can go with the maximum. All right. But what if it returned minimum? All right. What if it returned minimum? The minimum is -4. So instead of returning only maximum, imagine a structure where it returns both of them, minimum and maximum, and you multiply with both of them, right? I mean, you calculate with both of them at the same time, and then you return the max. So it returned, I mean, the minimum answer that our previous sub problem can return is, -4. You can start fresh. Oh, that means there is nothing wrong with starting fresh, lazy skimmer. There is nothing wrong with starting fresh. I mean, the thing we're gonna discover is still same. Either we can start fresh, or we can get the maximum and multiply, or get the minimum and multiply. So now we should have like a 6 and 3, right, and maximum, and minimum, which is minus 4, and multiplication is 12. This is multiplication, this is 12, and this is starting fresh. All right. All right, so this is for minimum case. I mean, this 6 is maximum, this 12 is minimum. Yes. I mean, not maximum, all right, you get it. And we do two operations using the maximum and using the minimum, and this returns 12, and this returns 6, and we return, let's call it x and y. We return, or we store, I don't know, let's store it. I don't know why, but let's store it. We store, I mean, x and y basically. Cadence algorithm works because of the nature of summation. It can throw away a smaller running sum, but in this problem we cannot just throw away a smaller running product. Yes, like I mean it is not, I mean there is nothing wrong about starting fresh, and also multiplying, like I mean multiplying with the maximum. I mean our sub problem should return actually again our sub problem, I mean I was gonna say our sub problem should return minimum and maximum, but how is it gonna do that? But starting fresh will be useless. It will always be either greater than equal the min, or smaller, less than or equal to max. It will be somewhere in the middle, so need to do it, I think. Yeah, I realized that, like, we are getting only one thing from our sub problem, right? Not two things, as in the running min and running max. Cadence algorithm works because of the nature of summation. It can throw away a smaller running sum. It can throw away the smaller running sum, so that's why we use maximum. Oh my, like, since we can throw away smaller, we use maximum. Like everything has different meanings. Because of the nature of summation, we can throw away a smaller running sum. Yes, imagine a running sum, right? Sum, and this is our current correct. So because of the nature of summation, summing -1, let's say -5 with current won't give us any better result than starting fresh. That's why we get maximum. But in this problem, we cannot just throw away a smaller running product, basically. Yes. Yeah. Because it can give us, I mean, the minimum can give us, but better result in the future. But the thing is, how is our DP recursive function gonna hold min and max at the same time? I mean, maybe imagine a function where some sort of array, or let's not call it array, but min max array, all right? Min max array. Let's length of 2, and maybe first one result will have min, and the, at index 1 it will hold max, right? And now we can call a function like it is about starting fresh. It can throw a smaller one, because think like, if we keep a smaller running sum, then we add the rest of the array to the smaller sum. This sum will always be smaller. Will always, oh my gosh, this sum will always be smaller than just adding the current element. Yeah, with the rest of it. You don't really need to do top-down recursive DB. You can think more in terms of cadence algorithm. All right. Do you know how to implement cadence algorithm implementation? I mean, yes, like a for loop. I mean, actually, I was I was trying to do the cadence algorithm solution here. I think I know it. Starting from index 0, we assign first character to there, and in each iteration, I know it. So I also, yes, like this, yes. So, and also we store, together we studied and I understood why we need to store DP0, DP1, DP2, because they are all different kind of subproblems, and we need to find the biggest one. This is why we store. Yes, it's more like variation of this. Don't worry about recursive. All right, forget about recursive function. But how is our sub problem? We are just doing a bottom up. Yeah. We are, yeah. This looks like a bottom up, yes. But my question is, what are we gonna have in our sub problem? Because if our sub problem returns only maximum, then this doesn't good. So our sub problem should return minimum and maximum, maybe. If it is gonna return minimum and maximum, maybe we should have some minimum maximum array, right? So in each our call, we need to store both minimum and maximum. So as you have, we can store running min and min. All right, in variables. In variables. All right. So min and max. All right, min have max, and we have a for loop. We started from 1. We know that our current problem can be written as using a subproblem. But does it include best or worst? Like in cadence algorithm, even though it is DP, we don't actually need any DP array, just a variable like current sum. Space optimized. Like now the space optimization part is even above the bottom up. I guess I will understand that soon. All right. Now I should understand, lazy segment. I should understand the what does our subproblem include. You said that starting fresh does not help to us at all, and we need min and max. I don't know, man. I don't. Current sum, it just, you name it, running sum. All right. Think like this. We have current sum. And then you multiply it with some number x. So this is the core operation, current sum. All right. We have current sum, and we multiply it with current number. No, not current sum. You mentioned about space optimization. All right, there. Now it is running product. Running product, and we multiply with the current character, current number. What does current product include? I mean, what does it include? However, these new products might be higher or lower than the previous running product. Yes. All right. It can be. All right. It is not always the maximum. Yes. You say it can be, and also it must be, because so that it can give us some better result. It should be, not always the highest one. It should also be sometimes maybe smaller. And also based on whether the running product is already positive or negative. Positive or negative. Therefore we can like store both sides, higher or lower than previous. The key is that whether running product is already positive or negative. Running product might be higher or lower than the previous. It should be in the example in the style I was doing. It was always the max. It shouldn't return basically every time max. We need to find a way to return minimum as well. Running product can flip from very low negative and to very high positive and vice versa. Yeah, it is dynamic. -1 or 1, for example. But if it is smaller than our minimum, update minimum. If it is higher than our maximum, update our maximum. All right, that's it. So I mean, if we find it smaller, update smaller. If you find maximum, update maximum. So we don't worry about the sign of the current one. We just do, and based on that, we update our minimum or maximum. All right. We do that, but so we can store. Yep. So we can store like running products, like 2 running products instead. 2 runnings, one of them min, one of them max. All right. So what I mean is that actually I am using 1 running sum here. I mean running product, right? Multiply with current, and if maybe max equal to if it is larger than our max, update max. If it is minimum, like smaller smaller than our minimum, we update our minimum basically. But we have running running product is answer, right? Because in the solution we had answer, max, and minimum. All right. So we have maximum, minimum. In each iteration we have this. All right. Now we need to connect this with running product, I think. It is not maximum or minimum. Both of them. So what should we do with running product? Let's say we have minus 1, 0, and 5. We have the minimum and then the maximum. We store this information in each our sub-problem. What should our sub-problem return to us? What should it return? BP I minus 1. Think more like we have dp, and in this we have min and max information. Min is really like a minimum running product and vice versa for max. All right, we have these informations, all right, in a sub problem or the main problem. This is purely mathematical, you know, like in summation we had this feature, but in multiplication you know, this is minus 25. Oh my gosh, the answer you gave, what was it? 2 minus 2 minus 3. So returning maximum was not a way. We should also return the hold the minimum as well. And try update this result based on that. All right. We try with maximum and minimum, and then try and then save result maximum of them. All right. Try with 2, find which one is bigger, result that. All right. Basically, I think I get it. The thing I have, I mean, in my mind is like we have max and min. We should try our current number with, you know, sub problems max and sub problems minimum, right? And then take the maximum of it, right? Takes the maximum of it, and maybe even it takes the maximum of it. Let's call it A, and since we do this calculation in each index, result it, store it in result equals maximum result. Yes, this is the answer. This is the answer. So in each iteration we need max, like I mean max that we can get from our sub problem, minimum we can get from our sub problem, and then multiply with these with the current number, and then get the maximum of them, and then store it in our global. Alright, alright. This is it, right, Daisy? This is it. And now, how do we store max? I mean, how do we get max from our sub problem? I mean, like dpi minus ones max, and I think it is using variables, right? Running product max, running product, and use running, yeah, minimum running product, yeah, maximum running product, minimum running product, yeah. All right, maximum running product, minimum running product. All right. All right. So we should. All right. All right. So we should maximum running. This is maximum, right? And we should multiply it with the current character, right? Current number, and we should also minimum right. We should also multiply this with the minimum, and and get the maximum of it. But how do we recalculate max running product? If it is if maximum running product is bigger than multiplying. All right, so we literally this is how we update maximum running product, and also we should do the same for to update the minimum running product, right? All right, we have now maximum running product, minimum running product, and we should get maximum of them, comma minimum running product, and this is our and I don't know, like, is it answer? So this is what we are gonna share with the next problem. I mean, this is the thing we need to store in the current sub problem. Let's say dp2. This is the answer. This is the answer. But we don't need to store it. We just maximum running product. So we updated our maximum running product. We updated our minimum because we need them both. I mean, we need both of them. We need both of them. And we multiplied them with the current integer. We update them. Like here, should we get these? I mean, or this max running sum? Oh, I guess. Yeah, welcome, Frigmash. How are you? Welcome in. We are doing this problem. How are you doing? Now, I think that should I pass this one here and this one here, or the maximum? Like, should I use maximum running sum and minimum running sum and no, we shouldn't return. I mean, we don't return. Pretty good. Woke up slightly late. How has this been? Um, it was good. It was good until I decided to review the first question in our greedy list, and it's been almost even beyond more than 2 hours. But Lazy Skimmer had a lot. I internalized the ending index I logic, and why do we need to store dp0, dp1, dp2, and why we need to find maximum of them. This is cadence algorithm. um, Now we are solving the version of it, maximum product subarray. It is almost done. Like, I haven't even had my lunch basically, because I really want to understand this before taking before before taking a break. I really want to understand this. Oh my gosh, it's been all right. Yeah, I really want to understand. And also, this is yesterday's application, Fligma, and also you are able to change the color of it. All right, let me check it. You can use color command and update the color of this application, and the VS Code as well. Yeah, you can do it. So we need both minimum and maximum. Basic, yeah. You can update the color. You can try it. Actually, maybe you can. I don't know. Like, for example, color with red. You should try running your code. All right. Let's see. Let's see what we have get. I mean, return the running sum. Return, I guess, answer. Let's try. I smaller than length of nonce. How do we multiply? How do we multiply integers in Java? It's nums I, not I. Alright. Alright. I thought for a second there is something wrong with my star sign. We don't have. Alright, nums. Alright. I got to head out because I gotta go get ready for. Oh, but if you are here when I'm back, I'm 100% positive make it. Alright, take care. Have fun, man. Thank you. Take care. I hope it's gonna be good in your. Dentist. Take care. I appreciate it. So expect, oh my gosh, how am I supposed to debug this? Output 2 and expect 6. Where maybe we should add some debug, like we should store minimum and maximum in each step, because we can update our minimum and maximum. We update our maximum using maximum. We update our minimum using minimum. Oh, this should mean, right? Yeah. We should update minimum. Like, we are trying to find even worse than line 16 has some issues. Yeah, like it has where is result? We don't update. We don't up. All right, I will get there. We have minimum. We have maximum. We should try, multiplying with these. All right, we have now these. What are we gonna do with these? We should. What should we store? Not minimum, not maximum. Because multiplying negative with negative can give us a new maximum. We don't do anything about it. Think about line 13. This answer, we have, let's say we now, like, we know max running product. All right, max, we have max, we have min. We have max and min. Of course it is gonna return always maximum. All right, it's not gonna return like this seems silly basically. Like, it's gonna always return the maximum, but instead, what should we store? We should store maximum of what we get. Like, this is easy, man. Come on, this is easy. What we I mean, what we get, which one is higher? Yes. um, and also it shouldn't be max running product, or maybe, I don't know, maybe it should. All right, this is it. Multiply with minimum, multiply with maximum, save the maximum of it. Yes, save the maximum of it. But should we do this before or after calculating the minimum running? One, two, we have minimum running product. Let's say we have minimum running product, we have maximum running product. All right, let's say maximum is 10, minimum is -5. Yeah, we should multiply it, and this gives -5, this gives 10. Yeah. Wonderful. -5, 10, and of course we should store this somewhere. This is the, yeah, we still store maximum running and minimum study no matter what. Yeah, so all right, just remove that part. It is easy, man. And then, come on, we are done. Come on. We are not done. result. Where is result exactly? So we started from here, and as we find running product, what is running product? Forget about running product. We don't have single one. We have max running, minimum running. In each step, we basically append or actually we literally append. We don't discover. I mean, we multiply minimum with this. We multiply I mean current number with maximum. And we update our minimum and maximum and go with the next character. For example, -5, 1 and 3, let's say. Alright. And now this gives -5 as minimum. And now this still gives 10 as maximum. We multiply, get 30. We update our maximum. We get -15. We update our minimum. This is maximum and minimum. What do you say, lazy skimmer? I I will take a break otherwise. I don't have my lunch yet, and like we store maximum and minimum. But actually we don't use DP here. Why? I think yeah, take a break and then alright. Let's try having 30 minutes break. Alright. Thank you everyone. I want to try not yeah, alright. Thank you. This is the crucial part. Yeah, I totally agree with you. 30 minutes break. I'm gonna have my lunch and come back, alright? See you after the break, guys. Take care. Could be useful to yes. Of course. I totally agree. I totally agree. Um all right. See you after 30 minutes. Hello guys, I guess we are back. Alright. Um I had my lunch and now I have more energy. Alright. Are you here? Lazy. Lazy gamer. Are you here? I guess I figured it out. um I mean, while I'm having my lunch, I thought I figured it out. So we are calculating the max, right? And then minimum. Uh, we should. Yes. So we should actually. This is correct. This is correct. Actually, let's run it. This is not. Welcome back. I fell asleep earlier. Like fiesta. That in Italian, what was the name of siesta? Siesta. Sleeping is good, man. I'm happy for you. During day. um, I think we are doing correctly. Like this is the minimum. This is the maximum we get. I mean, this is the minimum, and if we multiply it with the current number, then maybe we can get even bigger, right? Uh, and we store it in our answer. Yeah, but the thing is, we don't use. Actually, we use. We use, but. We. Alright, we should remove this part. We are multiplying twice. Let's run it. And I guess it was wrong, right? Oh, we have one one correct case. I'm quite happy. Let's look at the wrong case. Our output is 24. And expected is 6. So here, guys, it is not important. I mean, DP idea is kinda not necessary here. Let me think, guys. In each iteration, we calculate. I mean, we update our max and our minimum. Actually, the thing with the minimum is, guys, this can be bigger, right? I mean, this can be positive. So, for example, multiplying -5 with -5 will get us 25. Like, we don't, we lose that valuable information. We shouldn't lose it, basically. So how about, guys, I get this part, all right? And do this operation here, right? Again. Comma. Comma with max. Yeah. Yeah. Yes, I guess now, guys, we figured it out. And this is the wrong answer. Even worse than previous. Guys, be easy, be relax, guys. We got this. We got this, guys. Come on. Like multiplying current number with the minimum may give us, you know, quite a number. How about we just, I mean, compare these two, but I mean, like we are doing this, we're gonna get the same answer here. Minus 16. What's going on here? Max running is a first character. Like max running, yes. Like we are multiplying with the current character. We are multiplying. I mean, like we can get even smaller than our minimum. We can get even greater than our maximum. Um, hmm. Let me try this. Like I don't have any hope, but how about we just use, I mean, max and min here. How about this, man? Come on. uh, like how did we, you know, multiply some stuff and get 2, man? I mean, how did we calculate 2? It isn't. So we are, because we are doing it again, this is like, this shouldn't be this way. I mean, maybe this can stay this way. And menu, how about this one? I don't know, man. It is now better, 24. But still we are calculating 2. We are calculating, like, having, we cannot have 2. We cannot generate 2. How? I mean, it means maybe, like, if it is not a subarray, like if it is correct subarray, we wouldn't see 2 here. We are creating our subarrays wrongly, apparently. Max running product. So basically, guys, in Cadence algorithm, like we had these numbers, right? So we were getting the maximum from our sub problem, basically, and we were, you know, deciding, starting fresh. Why don't you start, man? Come on. Maybe, like, you know, the start, man. Come on. Among all of our previous subarrays, like, I mean, among all the subarrays, but where did we, like, where do we calculate all of the subarrays? I mean, let's imagine we have this one, all right, and imagine index is here. The previous sub problem is this. Yeah, so it should, you know, I mean, we have, for example, we have this subarray, this subarray, this one, 5, 6, and 6. These are our subarrays basically, and we are, I mean, Cadence algorithm, you know, was giving us the maximum of it. We may have, because we may have negative numbers, right? All right. Among these, it was picking the maximum. But how was doing it exactly? Maybe first we should focus on, like, we should maybe assume that it was returning maximum, and it was returning maximum. But for example, that maximum ending at here. All right. For the subarrays, I mean, like, writing like this is kind of wrong actually. Um, because this is one of our subarray, right? This is our another. This is our next. This is, and these ones. All right. Among these, no. Actually, like, not among these. Forget about. Among these. Try figuring out why. Welcome, lazy. Try figuring out why your current code is wrong by printing. Like, by printing. I will try. I will try right now. Um, like, among these subarrays, like, these were our previous sub problem, right? I tried, like, I tried, but I didn't understand actually, lazy skimmer, why and how I can return to. This means I'm creating subarrays wrongly. There is something wrong with creating my subarrays, and now I'm trying to focus on what is our sub problem. I mean, previous sub problem, and how do we generate our um, subarrays basically. Like, think implementation is similar to Cadence algorithm implementation. Like, while I'm having while I was having my lunch, I thought I figured it's like variation of Cadence. Mm, variation of Cadence, but in Cadence it was, you know, it was summation operation, like a sum operation, right? And here we have, like, we have two things at our hands. Um, like a maximum, like, and the minimum. But the thing is, we may get maximum from this. All right, if we do this math min operation, we may lose. I think we are on right track with the ideas, just implementation had issues. Like, I find this part suspicious. All right, because this may mean even higher value than our max, right? We shouldn't lose it basically. Or maybe to not to lose it, if it is bigger than 0, let's compare it with our Mm, if it is all right, if it is bigger than 0, we should. All right, this might be for me. Thanks for thanks so much for the stream. All right, see ya. Good night. Good night, Americana. Take care. Take care. That's why I say print things so you can step through what is. We can print, but which part? I mean, let me try this first, and then because if it is positive, then it may give us even bigger result. This one. So make it min. All right. If it is less than 0, we can update our minimum. But we should update our minimum nonetheless. Oh my gosh. We have minimum. How how can we find our minimum? By multiplying with the current one, but it can be negative. Yeah, we should do this, man. Yeah. If it is maximum, we do it. If it is minimum, I mean, if it is negative, yeah, we should. All right. How about this? How about this? Let's run it. How about this? It is now even. All right. So you are telling us that print. Where should I print? So maybe let's remove that part. But I'm sure that we are losing some some candidates. We like print ln. Let's print this, for example. Max running product. Max running product, and let's print the minimum as well. And let's see what values we get. Six, 2, 6 minus 4. Max min. 6 minus 4. Max running sun. So 6, 6. 6. Like, since I don't know, we cannot see the current subarray. If it were a way for us to see the subarray as well, then it would be quite helpful. But all I can see is now the running products. Don't fix the code, but only make it such that I can see my subarrays. You cannot see subarray because the algorithm actually does not enumerate every subarray. Yes, does not enumerate every subarray. Really? I thought it was. I thought it was. I mean, actually, yes. I had another question. like, is it generating all these subarrays, and then, you know, find the maximum um maximum subarray, and subarray means subproblem. mm, Subproblem versus subarray. The DP recurrence relation structure actually collapses subarrays. The DP recurrence relation structure collapses subarrays. So, like, we have subproblem for index I means best answer out of all subarrays which end at I. I mean, DPI means, for example, 1, 2, 3, 4, 2, 3, 4, 3, 4, and 4. This means best answer out of all subarrays. All subarrays. And we multiply it with them, right? For example, here it is 24, it is again 24, it is 12, and it is 4. DPI means this, alright. So they are not the same. A subproblem can have contribution from many subarrays. Oh, they are not the same. A subproblem can have contribution from many subarrays. A subproblem can have contribution from many subarrays. Given integer array names, find a subarray that has largest product. We will do it, guys. We will do it. Let's push ourselves. Come on.
Solve it or debug it. There is no third option.
As Lazy Skimmer said, solve it or debug it. Also, to generate or enumerate every subarray is too slow anyway. Yes, yes. And I thought like if it is, generating all of this, and how can it, how can it do in a short, fast manner? How is it doing in a fast manner if it calculates these? But the way you put is, I think I should think about it. So DPI means answer out of all subarrays which end at I. Yeah, maybe. So how about DP I minus 2? It is 1, 2, 3, 2, 3, and 3. And what is the relationship between DP I minus 1 and I? It is decision of starting fresh or extending it. Yes. If we extend it, we get this. If we start fresh, we get this. Extend this, start fresh that. Extend, yes. And what does it include? If it holds the maximum, let's say 1 2 3. But this is summation. I mean, normal Cadence algorithm, it is summation. And it means for it may but since they all include the last character, it is valid. We can select any of them basically. I think maybe you could even try forgetting about the DP idea and just think like how to modify Cadence algorithm implementation to. All right, let's try this. In Cadence algorithm, we had a mechanism to store like a DP to DP, like all the answers basically. All right, we can do it again, I guess here. And we were using mathmax. Like comparing our previous answer. Oh, maybe like we don't have start fresh here. Because in Cadence algorithm, it was like this. Like we were starting fresh and extending it. Here, every time we extend. Yep. We should, I mean, should we try starting fresh again? I guess yes. I guess yes, right? I mean, because earlier you said that starting fresh harms us, or may harm us, something like that. And I thought we shouldn't use starting fresh as an option. All right. Let's try, because if we don't start fresh, then we wouldn't be able to create all the subarrays, because one of the subarray is basically literally this, like, or that, right? And maybe they are possible candidates. So so start fresh, extend. Yeah, sometimes it's hard to word thing. Yeah. I understand. So we start fresh, we extend, we start fresh, we extend. But that I have that question again, because I mean, we may get a quite big number from this. All right, quite big number from this. Let's say this is -5 and this is -10, right? And we return -10, but yes, good. Yes. How to handle this? Most probably, like today, while I was working on this, I've seen something like making these like we need to take this into account basically. But so far this is good. All right. If it is, I mean, if it is smaller than 0, less than 0, or if it is greater than 0, we should also compare it with, I mean, our maximum again, because this might not excess, not proceed, max, not excess, proceed, anyway, extend, I mean, not max, I didn't, I couldn't find the word, but it can be bigger than exceed. It can exceed our max. All right. Yes. So, but yes, yes. But if it is yes, if it is greater, yes, yes. If it is greater than 0, we again should compare it with our max. But this doesn't explain the error we are getting here. Oh, now it is 1. How? Which numbers did you multiply and get 1? Come on, man. We are doing something wrong, you know, deeply. 48 we are getting. And you also said that we don't try every possible option. Let me. Now we are thinking about the fact that we don't explore every, basically every subarray. We don't try every subarray in this solution. And also I'm trying to solve this by, thinking about cadence algorithm and focusing on the differences and similarities. Create a timestamp. Try to figure out why your answer is so big. Like, um, it means we multiplied more than we need to multiply things more than we need to. But why? Because in each iteration we start fresh and extend, hoping for finding smaller. And at the end, the answer is in the answer we also have this thing. What do we store in our answer? In our answer, we should basically store um we should basically store, like, we have minimum, we have maximum. Yeah, it is correct actually. Like, actually we update minimum and then should we I don't know, do this. I don't know, I don't have any reason, but it must make it smaller at least. Yes, print. um don't try to guess in your head. All right, all right. What should I print? I can print answers to see it. Answer. uh Answer. Like, minimum running product, and running product start. But if it starts from 0, then multiplying it again and again, I don't know, let's run it. Answer 6, 9, 12. Actually we we are getting correct answer, but somehow we keep going. Why we keep going? Maybe because of this part. I mean, maybe Maybe print something else. I mean, I can print max running sum and minimum running sum, but they don't mean anything. I mean, actually, they might be. They might be because the first is, I mean, let's print them too. Come on. What would we can lose by um printing them by printing them? Also print something so you know where one iteration ends. In each iteration, like this one. Uh, Never mind. You put description. Hmm. Iteration ends. Ended. Let's see. Answer is 6. Max running, minimum running. Minimum running we can get, like we should be, I mean 6, 12. Minus 12. Do we have minus? I mean, should we? You said we don't, process every subarray. View more. Oh, we have more. Yes. Um. Oh my gosh, the minimum is not minus 24, and we don't see even minus 12. Max running product. Max running product is yes, starts with 6. Yes. Yes. Minimum is not 3 though. Why this is 3? It should stay at 2. It should stay true. Say 2, 2. Not true, but 2. And it seems that we are multiplying max and min and we are getting positive 12, but we shouldn't do that. Like we shouldn't multiply min and max, or I mean, come on man. Min running product we have. We are taking min. We start fresh. We extend it. But the thing is, why I see positive 12 over here? I shouldn't. And also the first min, like first min running product is 3, it says, but it isn't. Where do we, how does it calculate 3? Because current character is 3 and it also multiplies. Think like what if, I mean, like this is 3 and it's we lose line 16 and line 20 both run in one iteration. Why is it bad? I mean, my idea was we can get bigger result than our max by multiplying with minimum. All right, this was my idea. Like this, like why this is bad? Why is this bad? This shouldn't be bad. I mean, if I multiply with minimum and get a positive one, then it might be our new max candidate. But just think about code only. Think about code. Code only. Forget about algorithm and think about code. Do you mean like this? I mean, we get maximum of max running if line 16 runs and 20 runs too. Then what is it doing wrong? Maybe we should just use this one, right? Remove that and remove that. We already multiplied this. If it is positive, then it may be our new candidate. I guess we have fixed this part, right? Yes, exactly. Yeah. We already have what we need. All right, let's see. Yes, max is correct, minimum is correct, and max running product is -2. How? It might be multiplying more than it should. Before you fix that, yeah. All right. We multiplied again. Here, max running. It says max running -2 because it multiplies it, our previous one and get a very small number, but -2 is better than that, so we assign -2 to that. But and actually it's a correct, yeah, this is correct. This is correct. This is correct because we are, we need subarray. This is correct. Min running, yes, this is also correct. Wonderful. Like at least the max and min seems, they seem correct. Minimum running product, yes, even minimum, this also is correct. Amazing. Like numbers are amazingly correct, but the output is wrong. Output is wrong because but I don't see any reason why I put here on top or bottom. Right, there is no difference for me to do that, to do this either. But when should we store our result. We have running a max and min, and we have max, and we have max, but we multiply with this. Like this doesn't seem good. I mean, my idea is we may get a bigger result, but this doesn't a fair comparison. All right, this isn't fair. We didn't multiply with max running sum. Maybe instead of this, how about that? No. How about minus? How about this? How about that? But is it correct way of multiplying with negative number? Let's see. Yes, it seems correct, guys. Let's submit it. And a wrong answer. Come on, man. We have passed some tests. Oh my gosh, guys. Who invented this code, guys? All right, we have some tests passed. Let's see what we are use test case and then run it again. And all right, output is 4. Our output is 4. Expected to minus 4 minus 4 minus 3. Answer is positive 4. No, this isn't right. No. Max running product is 12, and our goal is returning this one, right? But we don't return it. Oh my gosh. Create another timestamp, and this is where we study. Oh my gosh, just implementation is tricky. What did we write here? Actually, forget about that. Now create another timestamp, and now we are trying to understand what are we missing. Actually, we have some test cases passed. There's test cases that are passed, but we are missing something, right? Oh my gosh. Now we don't have cloud on our side. So let's focus on case 3. Actually, we literally have the correct answer, but the answer is not always max running product. Yes, it shouldn't be like the answer should be either max running product or maybe even the, you know, negative of minimum running product, basically inverted version of minimum running product. But here, for example, both of them are 0, but answer is 2. And actually, like, what do we even return, man? We return our last found answer, and that answer is supposed to be maximum. And even, okay, but I don't know how to hint more without giving answer. Like this doesn't return, like it should return 2 here actually, but it returns 0. Do you just want to see my answer? I feel like you have tried a lot. Yeah, like we should continue. We shouldn't spend that much. Yeah. Send, show us your answer, lazy skimmer. Show us your answer. And also try this comment. Also try that comment. I want to make you trusted in our database. Let's see. This is Java? Oh. You code both in Java and Python, I guess, right? We make them. You are making them start from 1, not with the first character. Oh, for me. Thank you. I will add you into. Let me make you trusted. Now you are trusted. You can try again. What was I looking for? I was looking for, like, we are literally making our first character this one, and we can actually, but if it is 0 we shouldn't. I will quickly code up a little cleaner version. Your way also works. That's interesting. Carcus, all right, it will be great, Carcus. So you literally iterate through every integer in our list. This looks like updating linked list, right? This was our. This looks like temporary. Actually, it should work, but it doesn't work right now somehow. Maybe I should start my Twitch daemon. Yeah, temporary. All right. So this is for minimum. All right. You started fresh or extended. And this is exactly what we have done. I mean, no. Current mini. You use mini again. You tried finding a bigger one, greater one on mini. That is interesting. Like we had minimum, and you hope that by multiplying with the current number you could get even smaller than that. And also you start fresh and you extend, and now oh my god, this looks like using alt mini. Maybe this is the key. Using alt mini, you multiply it. And answer is our answer is you are checking only this, like only with maximum, because in maximum you also all right, you write your answer into maximum and you only compare maximum with the answer. Yeah, we cross both ways because remember sign can flip. If you don't use alt min, then we will multiply too much x. I guess I should be careful about my alt min. Let's remove this part. All right. We start fresh. We extend. This is good. We start fresh. We extend. This is also amazing. Wonderful. All right. These are correct. All right. Start fresh, extend. Start fresh, extend. And if minimum is drop my solution in arena. Approve. Oh my gosh, guys. What is this, guys? Max sum subarray, pro subarray. All right. First character until the end. I don't understand this one. And for this one, if the value is smaller than 0, you change minimum and maximum. Oh, because I mean, is this always correct? I mean, both of them can, for example, -1, -5 and +5, for example, or let's say -5 and 6. Then 6 will be it is max and minimum. It is max and minimum, but we don't know it's how far they are from 0. But if even if they are far away, equal distance, then doing this operation won't cost anything. But imagine, let's say we have +3 and -5. Yeah, again changes. Yeah, again changes. I didn't understand, but it changes. I don't know, guys. Max min. We update. You start fresh and extend. You start fresh and extend. Amazing. And you only use max. You don't process minimum. You don't process minimum because apparently you handled minimum here. I didn't understand the second method over here. I guess another solution, I suppose. Right? I guess it is another different solution. Another trick, for example, here. If it is positive, you take it. If it is negative, you don't take it. If it is positive, you take it. You add it. This is sum. This is sum. This is production. as I saw prod, I thought production. I mean, yeah, not product. Production. Yeah, now it is sum. All right. So I guess the trick is here. Because here you don't process minimum anymore. My way is just like the same thing. Yeah, because both ways, because sign can flip. Yes, like if we don't use alt mini, then we will multiply too much x because we are changing mini. Do not my solution arena. Second one is for maximum sum. Yes, I just got an wrote. All right. Thank you. Like this is a trick I need to understand. You start fresh or extend. You start fresh or extend, but you only compare with maximum prod. So, all right. I guess I'm trying to do same thing here as you guys did in your solutions. If it is positive, like mine should also work, guys. If it is positive, then it has the capability or chance or possibility of being greater than even our max. And if it is greater than our max, we update our max. This is exactly same thing that Carcus did here. I mean, not exactly. Yes, when negative value comes, it is safe to swap max and min as sign flips. Then I process both min and max to see if they need to start again or extend. And due to the swap, max always holds the higher value than min. Yes, max always holds higher value than min. All right, I'm kind of doing the same thing. And why? I get error 2 here. Let me status, right? I guess Cloud is giving some error. Yes. All right, guys. I'm trying to do same thing. But apparently we are missing a point. I mean, even this taste too shouldn't. Yes, it does. Oh my gosh. Max running is 0, min running is 0. I guess the point where I struggle is understanding how max and min work actually. I mean, it gets the maximum. It gives the greater one, but we start fresh, we extend. We start fresh, we extend, and this should work, man. This is quite similar to Carcass solution. And let's look at Lazy's solution again. integer min value. There are not one, not two, three, four, five of them. um, I guess I need to do some practice with matmin and matmax. So, we start fresh, right? Extend. What are we doing here? We're not starting fresh or extending, but instead, but instead, like this seems odd to me because we literally multiply with maximum, but we compare it with our minimum. I mean, I like calculus solution better, but notice, for example, line 10, this part, this can be a possible new min. Ah, I didn't think of that part. I only thought about the minimum part that it can be positive, but I didn't think of the part that even maximum can are new minimum. Yes, yes. Possible new min in case max is big number. Yes, yes, yes. All right, all right, all right. Yes, yes. The last part I was missing is this. Yes. All right. Now that I know that this might update our minimum as well, what should we do? Multiplying maximum running product with current may give us even smaller than our minimum. So we can we can we can do this. Yeah. We can literally do this. Yeah, we can compare it with this one, I suppose, or which one I should compare with the current character. The idea is this can give us a new smaller, right? If it can, then I should be able to compare it. Yeah, why not? I mean, I thought maybe I'm gonna do, some extra multiplication. So yes. But it would be great if we do this based on if condition, but matmin is our if condition. I mean, there is no harm. Yeah. Let's see what we have. Output 2, expected 6. Max running product is 6. Yes. Actually, now, where do we update our answer? We don't update it anywhere. Our answer, you guys used mathmax, so let me use math. Like most probably kinda this, but yeah, we should. But we are checking with 0, but we don't do the same comparison here. Why setting minimum running product again? Because we said that the sign of this or should I check the sign of this max running product or the sign of the current character and current integer? Or maybe we don't need to have an if statement, only, you know, having this mat max. Oh my gosh, guys. Max running product is 6, 3. And then max running product is -2, yes. Minimum running product is -6, yes. And then in the next iteration, it is 4, yes. And minimum is, this is also correct. Alright, the thing is, the thing with our code is, you know, this assignment, right? Oh my gosh, I did nothing. But I did actually. I think I've written this part, but I didn't think it was gonna work. Let's submit it, guys, and it's gonna. All right, I'm quite happy it gave us wrong, because I didn't want it to be correct, because I didn't understand it. Most probably, the issue the issue with this is, like we are literally, we have a condition here, but we don't have a condition for doing this assignment again. Let me write the meaning. All right, we do this because start fresh and extend. We are doing this for, yes, start fresh or extend. Here we are doing this for in case oh my gosh, in case the minimum, as Lazy Skimmer said, minimum can be our actual new maximum. In case, let's say -1 and -1, or -2 and -3 and -3, min gives us new max. All right, this is for it. This is for the same thing. No, this is for minimum being maximum. Here maximum, I written it wrong here. Let me copy this part. Yeah, minimum, actually not minimum, the production of, not production but product of, where is product of, this one, guys. Product may, oh my gosh, min running product. But when we try this, we get some, you know, actually we said that we already include this inside it here, and yeah, actually we've done this before, and we were getting, like, we were doing again and again. Yeah. So this is for minimum being maximum. But remember, you are changing the products when you do. Remember, you are changing the product when you do equal. Yeah, we are changing them. What about them? Yeah, we want to change. So I mean, yeah, yes, they change. I mean, max, like, this is start fresh extend. This is start fresh extend, and this is for this is hmm. So since we should check the sign at the top as Carcos did, because at this line 14 I'm not available. I mean, it is not correct place for checking if the minimum is you know, if the maximum has minimum, because we already assigned that. We already changed this maximum running product over here, right? And I guess this is what Lazy Skimmer is trying to tell me, guys. We already passed that because we assigned this is now our new max. This cannot be our new minimum, for example, minus 100. This cannot be minus 100 because we assigned, we updated. Before updating, we need to have a mechanism for that. And the mechanism for that, guys, I don't know which mechanism we can use. When line 14 runs after line 10, notice you will potentially be doing nums I twice. Oh, yeah. We've done this mistake, right? Yeah, we've done this mistake. We should remove it. Sorry, we should remove it. We should remove it, and as Lazy suggested us earlier, use test cases and run it again. Like, I've done this mistake multiple times today. Expected 24. Maximum running product, minimum running product. Minimum running product is not -4. It should be -12. Since Cloud is not helping us, now it's time for me to open DeepSeek. And make it show us some examples in mathematics. So we start fresh, we extend, we start fresh, we extend. Now this, for example, is for max running. Like, we lose something here, guys. All right, this is what I mean. when we use this here, it is already assigned, and it is not negative anymore. I mean, it is, it is fixed, or it is already processed. It loses the possibility of having a new mean here. It is not our new mean anymore. Like we should do something like Karkus did. Like, this is the mechanism I'm looking for. All right. Let's try this, and then it's gonna work basically. All right. He checks if the current character is negative. Then I won't have to do this assignment, right? I'm just gonna most probably start fresh and extend, extend, and forget about even this part. And assign max running product to minimum running product, I think. And assigning minimum product to integers temp. How about this? How about this? How about that? Like Karkus's solution seems amazing, but I didn't understand. Like, I understand, but next time I need to use this, I may not be able to use it. I guess I need to solve more questions. At least I understood the meaning of ending at index I. Yeah, even understanding that part was quite crucial. And also I understand, that's why I also understood the reason why we need to, like in Cadence algorithm, why we need to store each sub problem basically. But now the thing I want to understand, like I won't continue, but the thing I want to understand is the relationship between sub problems. All right, I mean, what is our sub problem? And Lazy Sigma said that we don't process each subarrays. Let's see class status again. All right. In maximum product subarray problem. What is the relationship between sub problem and then current item? Let's see if it is working. I mean, the cloud, because I guess it doesn't work. Oh my gosh, guys, I feel so tired. I feel so tired, guys. Come on, and even cloud doesn't work. Try again. Thank you, guys. Like, I learned a lot, at least. I mean, because I thought I understood Cadence algorithm, but I realized I understood wrongly, basically. For example, in the animation, I thought that the running sum is basically, our sub problem. But the thing was, running sum is, ending at index I basically. And after seeing the subarrays that we are generating, now it makes more sense. For example, 1, 2, 3, 4. Running sum. Like, I promised myself not to spend, above 1 hour to a single LeetCode problem. But today we have spent quite a time. That's all right. Like, this is the quite fundamental problem, and like, there are different versions of it. So if you understood this very well, then it will help us. So running sum can be this or this or that. Among those, any of these will be okay to connect. For example, we can have 3, 4. We can have 2, 3, 4. We can have 1, 2, 3, 4. So this is one of our subarray, another subarray, and this is another one. And our code is basically the maximum. Yes, the maximum. Yes, the maximum of the previous the ending at previous index basically. All right, ending at previous index. This is the definition of it. So this gives the maximum of them, and if we add the current character, then we would get this one. But what if the subarray is, let's say, -9, -9, -9, and 4? All right. The first subarray is -9, the second one is -9, -9, and the third one is -9, -9, -9. So these are our subarrays, and this is our current. So even finding the maximum of them doesn't give us optimal solution basically. All right. And our new option should be starting like a new one. I mean, instead of extending basically, instead of extending includes two things. All right, extend to include two things. First one is selecting maximum among subarrays, and the second part is using the current character. This is extend. The start fresh is start fresh is giving us only the last character. All right. So yes, when we look at the our possibilities, we can say this: one is starting fresh, one is picking the maximum of them and then adding our current. All right. So about the about the product version of this cadence algorithm. Now, like, we will multiply, we will get product of it, and the idea is, as Lazy Gamer gave us, okay, like something like this was right, and like imagine our subarrays is this and this, and our last element this. If we try to get the maximum, which is 4, we get minus 12. But if you get minimum, we get 6. So it is not obvious, like it is not guaranteed that we get what we need. But if we select only maximum or minimum, all right, because it depends. And it depends part is literally here. It depends. No, yeah, actually yes. It depends, but we use the current element to handle this dependence basically. We didn't look at the subarray sign, but actually we kind of did, because if it is negative, I don't understand why we did this. We change them. We change literally position of max and min. What do we get by doing that? I mean, actually, we change the position of max running product and min running product. Min running product is -4 and max is -2. If we change the order, but if the current process element is negative, yes, it is negative, so what do we do? We make min as -2 and max as -4. This is interesting. And then we start fresh and extend. No, I don't understand. I don't understand this movement. I understand why we need minimum and maximum. We need them both. Alright guys, I don't know. It's been 6 hours and CLOUD doesn't work. If CLOUD was working, I could try updating our Did you see this comment? Yes, when negative. Actually, yes. Let me read it again. Yes, when negative value comes. When negative value comes, it's safe to swap a sign flips. Yeah, alright. Then I process both min and max to see if they need to start. Yes, and due to the swap, max always holds the higher value. Max always holds higher value than min. But after the swap, since we are gonna multiply with the negative one, we're gonna get positive 12. For example, here we're gonna get positive 12 here. We're gonna get positive 12 here. It is because we change. This is good. This is good. Yeah, thank you, ladies and gentlemen. All right. This was wrong. Like what I have understood, but at least now I understand better. Let me say. But again, running some ending at I. All right, ending at I. We process all subarrays ending at I, and it represents the maximum of them. Maximum of them. Maximum of them. Yes, each of them is different, by the way. There is no relationship between, and there is, of course, there is a relationship between the dpi minus 1 and dpi, but somehow not that too much. There is a relationship with that, but not that too much, that much. um mm, Product subarray Java solution. mm, yes, I want to see. Yes, I want to, let's see what other people talk about this. What did they talk about? mm, oh my gosh. Initialize current. What do we have here? We have we have different approaches. Let's see. Naive approach using two nested loops and creating every subarray, I think. One, two, three, four. All right, we are trying every subarray. Track of min and max. The main idea is to traverse the array while keeping track of both the maximum and minimum product, ending at each index, which is the approach we have used. A zero resets the product since any subarray. Actually, we don't have any case for zero, but somehow our algorithm worked. I don't know. I don't understand how. Maybe it has something to do with the max, actually, like mat max, actually. Because even if we find something like a zero, but if we have 10, we get the maximum. That's why we handle this case basically. Max. There are three integers here. Max product ending at the current index. Like ending at current index. Like I I really like this idea. Ending, for example, at index 3, right? This is nice. Max product ending at the current index. All right, I don't understand. Actually, this is what we have done, but oh my gosh, what else we have? Let's see what neat code. Tell us array and dynamic programming. Hint. Alright, we know this hint. Try to identify a pattern by finding the maximum product for an array with 2 elements and then determining what values are needed when increasing array size to 3. Perhaps you only need 2 values when introducing a new element. Hint 3. We maintain both the minimum and maximum values and update them when introducing a new element. Like this means we are processing the the item that we are processing in our for loop, basically the current item. 3 cases we are gonna consider: starting a new subarray, multiplying with the previous max product, or multiplying with the previous min product. Actually, this is kinda apparent. I mean, if you know the cadence algorithm, then this shouldn't be that hard. And we spent 3 hours, guys. The max product is updated to maximum. Yes, these 3. While the minimum product is updated to minimum. You also track a global max product result. This was my solution. Let's see. We have 3 cases. Start fresh extend. Right. Start fresh extend. Like I can understand these. Starting a new subarray. Starting a new subarray. Multiplying with the previous max product. Or multiplying with the previous min product. Previous max, previous min. X is start fresh. Yes. Min X is multiplied with the previous min and max previous max. Start fresh min X. Alright, this is one of them. This is another. But how about this and that? This is minimum. Because we may get minimum from maximum as well. Yes, because we can get a new minimum from maximum based on the case. Like you handle this, but how come you don't get any error? Because I got many errors. I tried to do the same thing. Line 9 and 10 is longer way to write matmin X. X minus. That's why in one of the solutions that we have looked before in that white website, there it was using 3 arguments. Like it was using 3 arguments, and that's why instead of making it in one line, we are using we are actually explicitly doing, and it should be understandable for me actually. Yeah, we do it for both mini and maxi. Yeah, I think you just need to implementation practice. All right. I'm gonna do it, man. I'm gonna do it. Let's open another one. All right, guys. This was the first question. The second question is jump game. Forget about this. Let us find some maximum product summary. Actually, yes. This is the one we have sold. All right. All right. Now I have lots of notes. All right. Let's edit. Add some notes we have created. Yes, yes. I need to, practice more. Um, practice more, and yeah, I will think about this later. All right, the relationship between subarrays. Actually, I got this, but I need some time and I need to rethink. Not now, but later. And also, I wanna have your solutions, guys. Lazy commerce solution. And this is the Caracos solution. Thank you, guys. You are best. You are the best. Mm. All right, let's go. Patching array. So it seems I didn't solve it. Let's try solving it, guys. Where is our timer? All right. Oh my gosh, it is hard. Are we ready for a new hard problem, guys? Are we ready? Come on. I wanna hear we are ready sounds, all right? We are ready, right? I am about to die. No, no, no. We are good. We are good, guys. Let's hydrate and you know, try looking good. Let's go, guys. Let's go. We can do this. Given a sorted integer array. All right. 1, 2, 3, 4. 1, 2, 3, 4. And an integer n. Amazing, guys. Add slash patch elements to the array such that any number in the range can be formed by the sum of elements in the array. Return minimum number of patches required. Our array is 1, 3 and n is 6. Combinations of nums are which form possible sums of. Now we add patch 2 to nums. The combinations are 1, 2, 3, 1, 2, 2, 3, 1, 2, 3. Possible sums are 1, 2, 3, 4, 5, 6, which now covers the range. So we only need one patch. I understood 10%, guys. Nums in sorted in ascending order. We don't even have any hints. All right. Let's see what we have here. Given a sorted. So let's say we have 1, 2, 3, 4. Add and patch elements to the array such that any number in the range it can be formed. Any number. by sum of some elements. Um, and 6 means from 1 to 6. 1, 2, 3, 4, 5, 6. We are looking for, and we need to generate each of these numbers. I mean, we should be able to generate each of these by summing them up. We have, for example, 1, 3. All right. Uh, which number we need to patch? I mean, 1, 3, 1, 3. Which form possible? Sums of 1, 3, 4. We first find the combinations of the input array. For example, 1, 3, 1, 1, 3, right? 1, 3, 1, 3. Like we should create combinations, but which combinations? Right? Combinations of nums are which form possible sum. Alright. We should generate the combinations and we should sum them. Alright. And we now have like a 1. Let me even use green. We have 1, 3, 4. All right. We need 2, 5, 6. Now, if we add or patch 2, but why did you pick 2? To nums, the combinations are like this gives 1, this gives 2, 3, this gives 4, guys, this gives 5, and this gives 6. So that so we only need one patch. Like this seems like a DP problem to me, but apparently this is greedy problem. If it were like a DP problem, I would try generating everything. But the thing is, I would try exploring basically. But the thing is, which numbers I can use? Like, can I, for example, try patching 25? Can I try patching 25, or it should be a single digit number? Do we need to do this? I think better to do easier problem. Yeah, it would be nice, man. But which easy problems I should pick? For example, from greedy. How do you study greedy problems that are greedy, easy? Do you do like do you sort? I mean, do you filter here? For example, easy. Topic is greedy, right? Let's start with easy, man, right? All right. I can, for example, DI string match. Let's try this one. Do a list like NeetCode or Green5. Alright. NeetCode 150. Let's see which questions we have. Which one should I pick? Like a greedy, alright. We have 8 problems. But the thing is, most of them I have solved. But for example, there was a question, like a greedy problem, alright? And I couldn't manage. For example, which problem? For example, two-city scheduling, alright? I mean, solving these does not guarantee you're gonna be able to solve every greedy problem. This is the part I hate, basically. Like, there must be a certain questions, and after solving and understanding them, but maybe that limit is 1,000 questions, alright? 1,000 questions and solving them 3 times, maybe then Maximus Abere. We have solved this. Jump game. I have studied this before, and this one. I have solved this one and this one. I have solved these actually. Valid parenthesis string. Yeah, it is. Yeah. So this doesn't guarantee every because like each may have its own unique thing actually. Cannot really guarantee. Yeah. This is the hard part about LeetCode. Just need to hope for the best. Yeah. yeah. But knowing the fundamentals is the best way actually. I mean, you should know the fundamental, like the best frequently asked questions apparently. But I have studied these. I should study graph. Maybe we can try solving linked lists. It's been a while. Do you know all of the? So, like, I can try sliding. I can try these. I have solved 10 or 15 questions on linked list. 10 or 15 questions on trees. Maybe 6 or 7 questions on backtracking. Maybe 1 question on try. I have watched a video. For graphs, I have solved 2 questions. 2 or 3. For dynamic programming questions, I have solved maybe 15. Or maybe 10. I mean, maybe 5 2-dimensional and 15 1-dimensional. For greedy, we have solved many. Yeah. For example, I haven't solved math grammatic or bit manipulation any. But we can try solving array and hashing. Yeah, like these are familiar. Yeah, most of them I solved because yeah, I have solved most of them, but I need to do some review, all right? Because solving them once is not enough. Let's try this one. Contains duplicate. Let's try solving them fast because reviewing them is also important, you know. All right. How do we creating a hash map and checking their frequency, and if there is one that has or maybe I can use a for loop basically, and if like the core idea with this is like you literally like a used array or something, right? And if, for example, let's have a used array or something, right? But what is the size of it? We don't size might be length. And the idea is, if you used this one, you increase it, and next time you increase it, if it is, you know, if it is not 0, you can return boolean if you find any. So in on, basically we can solve this in on. Let's try it. Smaller than. So that's why I hate greedy. I mean, nums length. I don't hate. It's quite good, but for example, in the, like, you remember, right? There was a question, the stamp. You remember, right? Stamp. Like, we need to imagine from reverse. Like, come on, man. Like, we were like a unstamping. Like, all right, I get it, but I mean, if used array nums I has bigger greater than 0, then we return false. And also, if not, we make it equal to, no, we can increase it, right? Increase it by 1. And if this doesn't return false, we return true. Yeah, I guess this is the solution. Let's go with some. Oh, followed. Oh, thank you for the follow. Rise fakes fire. Thank you, I appreciate it, guys. Let's go with, actually today my goal was creating some YouTube videos, but maybe, guys, tomorrow before the stream I will create some. Actually, like, I tried solving this cadence algorithm. I thought I will be able to handle this, like, in, actually it is maximum subarray, but where did I find, anyway, my goal was completing this one, and it was product, and it took some time. And we couldn't review it, all right, because my goal is creating YouTube videos, all right, and like YouTube shorts, all right, like a 1 minute, 2 minutes, and we're gonna review, basically, all right, in a fast manner. It would be great. It's gonna be great. So, like, this should run, guys, right? And when we initialize an integer array, the default value for it is 0. Oh, rise fix fire. Also, hello, I also have a question. I've been trying to install Linux to my new gaming desktop, but I keep having file problem failure, and I have dynasty to not to be the USB sticks, all my BIOS, but it keeps failing with the boot. We can solve your issue right as soon as Cloud comes back live, all right? Rise. We're gonna solve your issue. Let me check the status. Because it's, yeah. So maybe in 1 hour or so, it's gonna come back alive, and we're gonna solve your question right away. Don't worry at all. Stay tuned, all right? Thank you for the follow, by the way, again. It should work, guys. Let's try. Where is run button? Guys, I don't see my run. Oh, because it says sign in. Why do I? It is neat code. I thought we are in lead code. we copied the correct part, right, guys? Yes, see, guys, it's okay. Numslang. It is because array. We don't need to use this because it is property basically. I'm trying to see if this installer works. Balena Etcher, that is for basically Linux Ubuntu. Let me take a screenshot so that I save. All right. Let me edit as to do. All right. Rise. Fix fire. All right. Index out of bounds, but why we are getting it shouldn't, we shouldn't be getting, maybe +1, right, guys? No, if the length is 5, if the length is 5, we're gonna have 5 elements in it. No, like this is wrong, guys. What I mean is that increasing, look at test case. Open test case. 1 2 1 2 3 1. Hmm. 1 2 3 4 and index 4 out of bounds for length 4. It must be because of like is it because of nums or used? We have 0 here. Let's say it is length is 4, right? And we can have 0 1 2 3. When we give this, we get 4 and we try to reach 4. It is because used array. My idea was something like this. I guess we had this issue before, right, Lazy Skimmer? Like it is because how we initialize our array and length of it actually. We should find the maximum, all right, maximum character and then create with that, but that might cause us. So maybe instead of array, why don't we use array list? How about that? But I really love this usage, guys. Like, I mean, we put, for example, a character, right? Let's say, and we increase it. I've seen this pattern before. And I tried using it, but if we have, let's say, if look at constraint, yeah, let's say numslang, yeah, nums value can be greater than I mean, nums value can be greater than the length. So should we create an array with this size? No, that to cover all the values, your array will have to be like in length. Yes, this doesn't seem good. Oh, maybe which will exceed memory. All right. We need 4 and we need an array size of 4, and we're gonna insert Maybe like these guys. We're gonna insert, I mean, we're gonna insert um, nums I. And since no, it can be negative and it can be 0 as well. So how about we create a boolean? This is some sort of implementation detail that later skipper loves. um, so like we don't need to create that long array. Length of 4 is quite enough, and we can assign a value. But however, we are gonna control check if it has value or not. I mean, if it is assigned, then it is used and we can return false because it is repeating. Mm. What do we do? I'm thinking of the way for making our array has a like a default value. Maybe we can. What is the default value of boolean? Of boolean array in Java? Is it false? Object is null, but if we use object, then it can be costly. Let's try. Let's have running solution first. Let's create a boolean. All right. This might cost a little bit, and if used I is not null, then we can return false, and if we didn't return false, then we can assign true basically. Yes, this can be a solution, but let's see the solution. We return true but expected false. Why? What is the condition? Return false if every element is distinct. We should return false if all of them is distinct, but given an integer array nouns, return true if any value appears at least twice. The question is kind of different, right? Yes, it is different. If any value appears more than once, this is duplicate, but on LeetCode, it is kind of different. At least twice. But they are same. At least twice means if any value, if it says, alright. So when we find a duplicate, we should return true. And if all of them is distinct, we should return false. If we find duplicate, we return true. If we didn't find any duplicate, we return false. And this value doesn't matter. We can assign false as well. Oh my gosh. Do I understand something wrong? 1, 2, 3, 4. 1, 2, 3, 1. Expected true because we have we have one duplicate and we should return true. Why don't we return true? Why don't we return true? Print. All right. We should print. I wanna print system out print ln. Please print I value. And let's see how far we go. We all right processed every character, and we don't go inside it basically. We return false, right? We return false. We don't enter here. But do we? Let's print this value. And see what value we have inside this used array. We always have true. Maybe the way we check the if we have something or we don't is kind of wrong. How do we check? How do we check if boolean array value is not? Try system out print arrays to string. To string. Arrays to string used. We have a arrays.sort and also to string method, and yeah, we haven't. Forget about this part. Come on. Arrays. Like it starts with true. True null null. True null null. True null. And we said. Alright, this is actually correct. This is actually correct. Hmm. Is it? Like, I mean, it start with 0. I mean, true. We assign it true. And in the next iteration, it should go, it should catch this, but it doesn't catch this. Let's print this one too. Hmm. Actually, yeah, let's print this, man. Let's see. What if array is like 4, 3, 2, 1? It doesn't matter. I mean, you mean if every character is unique? If they are unique, we should return false. After first iteration, what do you want? What do you want use to look like? After the first iteration, I want to use look like, um, having. I mean, it can have true. Oh, sorry. We should do this in 2 pass. I think 2 passes, right? My goal. It's very hot in my country. It's like 30 boiling in the UK. Oh, it is not too hot in Turkey nowadays. Luckily, uh, at the moment, one of these, enough for me. But in maybe a few weeks, it will be hot here too in Istanbul. My goal here was increase when I find the same character, not every time. Yes. I only have like a small fan. I wish I had air conditioning, but I have to pay euros to install that. That looks expensive. Like, I think after first iteration, when I equals 0, used should look like at the end. What I imagine, guys, what I imagine. I really love, as I said, I really love this idea, right? We literally enter, let's say, a character, and we increase it, and next time when we but we are using different different indices, like 0, 1, 2, 4. So index is different. The value, all right. And when I try to use the value, then we hit the memory exit. So now we are trying to find another one, and I thought maybe we can use boolean, and I tried using the new boolean idea with the using my previous idea. Like, I love this usage, but this doesn't work here because we don't have fixed array. And Lazy Skimmer says, what do I want after first iteration? Actually, first I should think about why doesn't it work. After first iteration, I equals 0, use should look like. Why does it need to look like that one? When nums is 4 3 2 1. The element 1 occurs at indices. Element 1. Maybe we can focus on what happens when the all elements are distinct. When every one of them is distinct, it means we don't have same character. What happens when we have same character, same value? Like if I were maybe able to use the value, then I could use the value inside here and I could increase its frequency basically. You want to be able to use X to check if it already appeared. Yes. Yes, exactly. I want to be able to use this notation basically. Maybe not character, but an integer value, for example. But I cannot do this here because the value can be, high value. Therefore, after first iteration, use should look like, because the true is at all right, now we placed to the positions. All right. Position what? Let's say we have, but we have, because true is at index 4. Given an integer array nums, after first iteration, what should we do? Used for accessed index 4. Used for, but you used the value of that. I mean, we cannot use value of 4. No, you mean the index 4. Now I'm trying to create a connection between index and the value. I cannot use the value. We are talking about index. We are basically using the values as index. Yes, but I tried applying that, but I got out of bounds exception. We are basically using the values as index. Yes, like I also want to do that. I mean, because when you create your use array, you are using numslang for the size, which is size 4. Yeah, which means indices are yeah, but what should be the size of my used array then? Should I make like a 100, maybe 1,000? What should I think? Oh my gosh, I don't have. Like last time we had similar issue. Like last time we had issue like this, we used max element +1, but here it might not work because we may have an array of, let's say, 100 and then 1 2 3. Then if I try to use 100 as an index, that's fine. How? I guess I'm missing a simple point. No, it matters. It matters. You need to make nums with size 101. But in that case, I need to find the maximum value, and then find its one bigger version, one greater version. Then I should iterate through array once, and I don't know. Using values as index won't work in this problem. Values can be larger than them. Also values can be, oh, yes. Yes, also values can negative. Yes, yes, yes. I forgot. Yes, then for negative values you can shift it across. But anyway, you cannot do this because your array might need be up to due to constraints. Yeah, length is also I mean, this is high, which is too big for liquid memory limit. Yes, yes. So we cannot use it for, as you said. It is because negative, and also it is too high. So we need another detection system for detecting the duplicate. I was using this method before, but in this question I cannot use it. You think of a separate data structure, or what does mean sparse data structure? If I need to think another data structure that I can use in this problem, let's think about linked list. Can we use it now? A heap? No. What else we have? Binary search, two pointer. These are techniques. We have array. We have array list. We have linked list. Like array will use up like maximum space. A sparse data structure is like one that uses up minimal space. For example, here we go. Here we go. Send it. Like, in the case your nums array 112, array will be size, but a sparse data structure will be size 3. Yeah, I mean, it's like one that uses up minimal space. Like array will use up like maximum space. What do you mean by this? Where most elements are empty, zero, or null. Anyway, if you don't know what's going, don't worry. Just think of another way. Without needing coordinate, basically index, how do we know that we use duplicate? I mean, you mean, actually you said this, but I mean, true. You said like a false, 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 and true, meaning what? Meaning 4 is used, or I mean this one is used. This is interesting. At the beginning, you set a data structure. At the beginning, you set a data structure that works. Linked list or something? Linked list, heap, I set. Array list, I set. At the beginning, you set a data structure that works. Oh my gosh, what did I say? Um, array list. I wonder if we hit. I mean, when do we return? I mean, as soon like do we return false as soon as we find the duplicate one, or we wait until we process all the ones? What is a data structure that can be used to check if a number has already been seen? Like, we use hash map or set. Set is for unique. Alright, we're gonna add to set, and set will give us wrong, I mean false, right, when it hits duplicate. Alright, let's create set. But like, how does it work, man? Like, people created set is, I mean, they must be let's create with this one. We were creating like this one, right? And in a for loop we will try adding in our set the current character. So I should have thing about, you can just do a new hash. Oh yeah, on the right side we don't need. Yes. I all right, when it hits kind of like this, right? We return false, and if we don't return false, no, actually we return true. When we hit the right sets. I don't understand these emojis, guys. What is the definition of it? It is, I don't understand. We return false basically. This should be correct, guys. And instead of used, all right, I should have thought about the data structure maybe first. This is good. Eating a snack like watching you, and eating popcorn like when watching. Oh, nice. And we can add this one, guys, and boom, come on. And wrong answer, come on. We edit all the elements, so there shouldn't be any problem. 1 2 3 4, they are unique, and we return true. Actually we should have returned false, because they are distinct. Line 6 sus to me. I mean, I remember this, or maybe like this. Like, I didn't check what it returns. All right. When we add this, you know, duplicate one, it returns. It should return false. Something like that, guys. I tried that and that worked. I would say generally avoid doing side effects in if conditions. It is more complicated to reason about than you would think. Do you mean like doing like this? Doing side effects in if, like, I use this because um in some recursive functions we use, like, we call our recursive function like this, and if it returns false, then we, yes, like, use it also changes the set. Oh, so maybe we can use its reference or something, right? Hmm. I would say generally avoid using side effects in if condition. It's more complicated to reason about than you would think. The set modification is the side effect. Um, that looks pretty solid to me. I remember something about set being, how does set work in Java? There was something about it. Uncle Bob might have something to say about that, but then again, he is not a programmer. Mathematical set abstraction meaning completely prohibits duplicate values and generally does not guarantee any specific order. Alright. There was something about it. Mm. Set modification is side effect. We were adding elements to, I guess the thing I remember is like we were adding some objects inside hash map, and since we are adding their references, if we update the value using that reference, and then in that hash map it can false positive basically. This is what I remember, but I don't know the set modification is this side effect. Let me add this as a tag to do. This is good. This is about thinking about the correct data structure. All right, what else we have? What else do we have? Mm, wallet anagram. Let's solve this too. I mean, where are you, lead code? Anagram from left to right. What was that? Given two strings s and t, return true if t is an anagram. We were going from left to right and right to left, and they're gonna be same, right? It was something like that. Yeah. No. No. It is. We are gonna create a hash map with the frequencies, and we're gonna check if each character's frequency is same or not. If they are same, then they are anagram. Yeah, it should be like that. Is a word or phrase formed by rearranging letters, different word phrase, using old original letters. Exactly once. Yeah. Follow up. Anyway, let's So the thing, guys, we should all right, we can use an array, right? Forget about HTML. We can use an array. Like I can use, like we can use the method that we have mentioned, all right, in the previous question here. Come on, we can create a character array. Let's call it X, all right, and the length will be the length of the string, right? And the idea is, guys, we're gonna increase as we see a character, and we're gonna decrease it, right, when we see but then we would need to iterate on string S and then on string T, then, but it is all right, I guess, like a 2 on, and it means on, right, basically. Length is n, but the thing is their length can be also different, so we should be aware of that. We shouldn't assume that their length is same. So now we can use the approach I was I wanted so badly in our last question. It was this, guys, car at I, and increase the frequency, basically. Like, good idea, just length part is a little suspicious. Yeah, we assume their length is same, but they can be different, and if their length is different, we can return false right away, right? If their length is not equal to, think about the second constraint. All right, they consist of lowercase English letters, which is even better. We don't need to worry about the exclamation mark, question mark. They are cut English letters, which is amazing. I feel so happy about it. Well, what do you want me to say, lazy? S and T consist of lowercase English letters, which is amazing. Like, there can be nothing better. But I guess there is something about it. But if their length is not same, we increase. Oh, this is character array. We can create integer array, right? We don't need to. We know the character array. We increase, and we can loop again, right? And we can try decrease it. But if we hit below 0, then we return false. This is good implementation practice. You mean try reading every constraint? You mean, I guess, right? Yeah. It really helps, because you can understand what the question really wants you to think, right? By looking at those constraints. I see. But in this problem, they look good. Yeah. We don't have empty array. Yes. The optimal, the best constraints that we have, we can have in this question. But I understand. We can use again. And now it is time for us to, guys, decrease. We're gonna decrease it, and if actually now we can, it is time for us to test, like, we can use this sign, like a minus operator, pre or post, right? Can I do this? Or anyway, let's decrease it. But this post means there was a rule about it. If you wanna check the condition inside the if, inside the current if, you should do that process before, you know, if condition runs, basically. There was something like that, but for now we can just do this outside, like a prior to that, and then check it again. But we can check that rule, I guess, like this one, right? No, yes. And if it is below 0, what is below 0? This is below 0. If this is below 0, then we can return false. I assume that default value of integer primitive is 0, so that when we initialize an integer array, in our memory we have an array of 0, 0, 0, 0. And Lazy Skimmer said that for primitive boolean it is false, and for primitive integer it should be 0. The default value, I mean, when we initialize. This looks legit, guys. And if we don't return false, then we can return true. Not false, of course. True, guys. Not ture, but true. Yes, this looks legit to me, guys, and let's try. We use character as if it is an array of something, but it is a method, not a... This is where I would definitely avoid doing the pre-post increment in the if condition, yes. Because this code and the version with the increment inside the if condition are not the same behavior, which can bite you. Yeah. I suffered when I'm solving a tree problem. Because I was giving, like, I was calling my, you know, recursive function like this one, and it didn't work. But I should I gave like this one, and then it worked. So there's a logic, like in one of them it calls your function and then increment your value, and then in the another one it increases your value and then call your function. But it might be tricky, you know. Let's fix that here. I guess it should be car, right? Yeah, it should be car because we are inserting character. Sorry, I changed it to integer, but if it is integer, how am I supposed... Yo, we should make it integer. We should turn character into integer. Your below 0 is inside... that is... Yeah, I should remove that. Yes. But... like this, it was integer array, but this returns a character. Does Java return character to integer if we use it as index? Let's try. Alright, let's have an integer index and let's assume this character is returned to ASCII or something, right? I guess it won't, it's not gonna work. Let's make it used. Like, the thing I know is like using this one and increasing, basically. No matter the type of the element in the array, you should be indexing with a number, right? Yes. no matter the type of element. Yeah, I need a number to use it as an index. Most probably Java will turn this into some ASCII character when I use it inside array notation. Index 97 out of bounds for length 7, guys. So it transformed, but now we have the same issue as in the last question. Come on, guys, what was it? Like, I remember such thing, but it seems that back then I didn't think about the length of the array. Like, I literally remember this notation, like this trick basically, right? Or maybe I should all right, I remember, guys. We can remove 97, right? We can use this and minus character A. Yes, this was trick, guys, to offset. Yes, right? Yep, nice. Yeah, we have to offset basically. 99 becomes 97 becomes 7. Should we do this everywhere? Should we use it everywhere? I guess in everywhere. All right. Oh my gosh. Index 13 out of bounds for length 7. Where does 13 come from? Because the character we have is A, B, C, D, E, F, G. Let's say H. And it is... I partially remember that trick, guys. Although we offset, still we have... Oh, maybe we can create our used array. Now that since we know... I guess this is what Lazy Skimmer want me to realize. Since we know our input, which is A to Z, we can literally create our used array with the size of, you guessed it right, 26. Right, guys? Or maybe 27, I don't know. Let's try. We return true. Why did we return true? It has a... We return true. It means... If it... if maybe... You return true on every... every case? No. I shouldn't be. Like, should it be maybe below 0 and equal to 0? Maybe this one is gonna solve the issue. No. Now we return false and expected is true. No, guys, like, we should be aware, like, we should be careful about what we use. My goal is like an increase as you used, right? As you have. And when you know, oh, the ID, we may have different characters in string S and string T, right? And in that case, before subtracting, it would be great if we just check if if it is bigger than 0. Do you ever use string t? No, I don't use string t. Sorry. I thought there is no harm using s. Yeah, yeah. Because since we now that know their length is same, I decided to use s here, but we should use t. um so it means even if their length is same, there is no harm using its name. All right, let's even make a t. um Or rather, it should be below 0. Below 0 part is correct because you can delete, and you can, when you try another, then it should return false. But we don't return false. Why? We increase the frequency because we didn't decrease it. All right, I just commented out. We still return. We decrease the frequency, but not T again. Be careful, my man. Let's go, guys. Come on, it was easy, guys. Come on, like I even didn't look at the screen, with my only one hand. All right. Two sum. Come on. I know this too, guys. Like I know this. Nice, GG. GG. VP. S. GG S. Guys, come on. I know this question. This question is about. Like this is the first question. Like when I started LeetCode seriously, I mean, about around 1 year ago, this is the first question that enlightened me. All right, we are gonna sort our array, right? Like sorting is a logic. We're gonna start from left. We're gonna start from right. And since they are ordered, they are increasing, they are in ascending order. Moving left pointer will mean you're gonna see bigger number. Like it is guaranteed that if you move left pointer inward, you're gonna get a bigger number. So we're gonna sum these elements at these indices, basically left and right pointer. If you reach your target, wonderful, amazing, good to go. But if you don't find, then you compare it. If your summation is smaller, then it means sorting. It is solid starting. Instead of sorting, what other idea you have, Cargos? Come on. Though it is a solid starting point. Like I mean, in this question, I don't know any other approach, to be honest. And how do we sort nums? I guess like this. Implement. Yeah, I'm gonna implement it. By the way, go. Oh my gosh. Yeah, sorry guys. To some. Thank you, lady. So the idea is, and this enlightened me, to be honest, guys, because like you literally build a logic. Like you are literally building a logic. Like you say, if I go right, I mean, if I go inward, then I'm gonna have a smaller or greater value. Then it will mean like this is logic, guys. This is logic, right? Integer left pointer 0, integer right pointer nums length -1. Since it is 0 indexed, we don't need a for loop. We need a while. And the thing with while loop is it is always hard to decide if left should be smaller or equal. But let's try it. So when left pointer pass right, I mean, we are gonna return false, but we can think about it. Why? Because in binary search, it is smaller than equal to, like, based on the question type, like based on what you need actually, right? Based on if you need to stop when they are at the same index, or if you need to stop when they overpass, like pass each other. Like it depends on the situation. If the number we have here, lazy schemer is pushing me, guys. But I agree with you, him, and like in implementation, for example, in the previous, like in the first question we have solved, like I didn't figure out I should have used set, for example. It was easy. So, but if you don't know, it is not easy, guys. If it is equal to target, we cannot return boolean because it wants us to return, maybe we can create even an integer array, right, using their indices. And now the logic part, guys. If the summation is, let's say, smaller, meaning we need to find a bigger one, guys, come on, then it means we should move our left pointer to right, guys, because you guessed it right, there is only one direction to right, it is inward again. And if you move it inward, we're gonna have a smaller number, guys. And because our array is sorted, so if the number we get is smaller, meaning we need to find greater one, we're gonna move left pointer inward. Yes, I guess that is it, right? Yeah, I guess that is it. If the total value we find is greater than target, then it means we should yeah, new this, all right, this, and then curly bracket. Yeah, thank you, ladies and gentlemen. This one, exactly, thank you. And then we should move right pointer inward. Yes, and when our left pointer meets right pointer, it will mean using same character. That is it prohibited to use same character twice? I guess yes. It should be. It should be, guys. There must be something about. Yes, we have. This is what lazy schemer was talking about, guys. You may not use the same element device, and this is thanks to this phrase, we can stop when our left pointer meets right pointer, when they are same, basically. This seems easy, I mean, not important, but it's quite important. So it also says this is guaranteed that there is a valid answer. So we don't need to worry about what if we don't hit this case. We don't need to worry about, because it is guaranteed that we're gonna hit this case. Oh my gosh, compile time. Maybe, guys. It is because Java prohibits us to use return statement inside a condition, because that condition might never be right. Java doesn't know that is guaranteed at compile time. That's why we should return. No. Yes. So we should return. We should save that indices in an answer. It's because you don't. Yeah, basically yes, because Java doesn't know. Like we know we're gonna hit this point, but Java doesn't know. Uh, so answer 1, I guess. Integer answer 2, 0. And then instead of returning them here, let's make answer 1 equal to left, answer right, and then try returning them. But guys, don't make it like this, because even you can return inside as long as every branch. Yes, of course, if you guarantee, I mean, yes, but I didn't. We don't have any. We don't have return statement in each branch. So yeah, thank you for sharing. Like in try catch, no, like just keep what you had. All right, let's remove. All right, inside the first if, it is fine. All right. And now try running this. All right. Send us. Should do you mean in arena? Oh, Karkus sent another one. Twosome. We were we using twosome? Yes, we are using. No, like you click. Oh, this one you mean? We have left and right here, yes. But the thing is, are you sure? I mean, it shouldn't work. No, it shouldn't work. I mean, because it should work. It should work. Is because we are gonna hit this. Well, it compiles. Yes, it compiles. Now my logic has an error. I see your point. We kind of lied to compiler to compile itself, but my logic has its own mistake. I'm gonna fix it and then it's gonna run. I get your point. Because here left and right isn't correct, but they don't need to be correct, because we're gonna return this, and somehow, why on earth? Yeah, it doesn't matter. Yeah, yes. Expected is 1 and 2. We return 0 and 2. 0 and 2 returns 7, guys, and it is not equal to target. What are we missing? What are we missing, guys? Like it should work, guys. Come on. We are summing them up, checking if it is sorting. It is. Your indexes are messed. Oh, yeah. They are messed up. Yeah. We don't have anymore. We don't have them anymore. Yeah. We don't have their indices, guys. Come on. The answer expects indices of the original array order. This code could work for the question that asks us to return false or true if you can find target or not. But these as indices. Alright, alright. You can still fix this. I mean, apparently not after sorting, right? Oh, we can do this by creating copy of. How did it? Maybe when we hit a target. No, man. Like, maybe we can create a copy of the original array and and we can. I don't want to look at the car. I don't want to look at your solution, Cargus, because like I want to try by myself and then I'm gonna look at your solution. I forgot about the indices. Um, let's let's uh, let's think about indices. Lady Skimmer says that we can still fix it. There is still hope. There is still hope, guys. Oh my gosh. Like some sort of hash map or something, storing the location, the position, as well as we can store basically in a hash map, right? Each character, but we can have multiple, like the same character twice, same number twice. Then if we have if the numbers, yeah, they can be duplicates. Without sorting, I cannot do this without sorting. I mean, then 2 pointers won't work. Then I should think about, like, we should create a copy of the original array, but then still we don't know which one. Like, we know their value. Now, is there a way to go from value to index in the original array? Maybe, like, if it were a way to go from value to index, not from index to value, but value to index, we need a way to go from value to index. Yep, exactly. Then it means we need to use hash map. There is no or not hash map but map, because it is interface. Let's use it. Alright, we don't need to, as Lazy Skimmer said. Now we need to go from value to index value. So I need another for loop basically. I cannot escape from this. Maybe even for each loop would be okay. And I should put value first. Come on. But what if, like, we may have same then maybe our structure of value to index can be list of. Come on, man, we are doing it, guys. Value, and that value can exist in multiple indices meaning a list, right? We're gonna do it, guys. We're gonna do it. Put the value, guys. No, value is C, literally. Put the value. We don't have index. We need a for loop. Yes, we need a for. No, we don't need. Yes, we need. We need, guys. Come on, because we need the index of them, right? All right, and and also, guys, the trick is, guys, we should also initialize, right? We should initialize something, guys, right? Because because guys, I don't know, but since it is a list, it needs to get initialized once. But we have should we use get or get or default, not get or default, guys. We are like, I'm trying to what is C, by the way? Value to index. What is value? Value is this, guys. Key is the value. Yes. Key of map is value, and the value will be list. There may be a list at the time we are adding, or may not be a list when we are adding. So getter default, how, I guess we have a note, guys. So I mean, get or default, let's see, guys. So key and value. All right, key and value again. Our key is, and our value, guys, is new list. I guess like this, right? So by default we yes, we need to do this, guys. For each value, I mean key, we need a list. So for basically, it means that for each key we need to initialize a new list, and the default value for that list is basically initializing it. So we are putting in the position of key to this value. But what is this value? This value returns us get key, or that value. So we should compute if absent. Actually, today I have seen it, but I didn't understand it. Compute. Why don't I have compute? Come on. I should have. I mean, I have. Compute. Come on, man. Today I remember I studied this. If, yes, if absent. Come on. No. Hold on, guys. Hold on. We're gonna do it. If up. What kind of text matching is this? I can literally see. Anyway, You can do like map compute, yes. Yes, I was looking for that. I mean, but I should be able to do that using getter default as well. Like here at the index. Come on, man. I have heard about it, but somehow it looked a little bit um complicated. But let's see if this doesn't work. I will try it with your approach. I should be familiar. I should be familiar with your approach as well. And forget about this. Let's try with this one, right? Map. But I really wanna this first. Let me try this, and then we're gonna try this, alright? Try your method, because I really wonder how it is gonna work. We initialize our hash map. We put our values. We initialize a new list if there is none. If there is, we get it. We add it. The index. We have now beautiful, amazing, tranquil, astonishing hash map. Our map. What was our goal, guys? I forgot our goal. Our goal. Our goal, guys. I mean, we should. So we needed their indices. So forget about sorting, basically. Forget about two pointer. How come this is two pointer? If I cannot sort them and use the two pointer. So we now have. Oh, so no. We need it. We now have the indices in the sorted array. We need to reach the value of these. We should reach the location using their value. So we're gonna use, guys, nums. This is first value, and we're gonna use nums right. This is our second value, and we have them in our map, basically, right? I mean, we have them, their value. Now, guys, imagine there are no duplicate ones, all right? We should we can return something like this, right? New integer again, and as lazy skimmer said, like that one, and map dot get using value. Come on, this is our first, and this is gonna be our second. But the thing is now, guys, they can return a list. Like, I mean, they return a list. Maybe we can get the first one. No, we cannot get the first one. Yeah, we can get the first one because I mean, you can use the same number at index 0 and at index 5. Like, if they are same, there is no harm to that. So we should, how do we, I can use get method again with the index. Come on, We are doing it, guys. We are doing it. How about this, guys? From our map, using our value, we get the indices array, I mean lists. We get the first element because it doesn't matter how many times it occurs. I mean, yes. And this is the second values list. And we get the first element. But are we, I mean, is it guaranteed that we have an indices of these values? Yes, we have. Yeah, it is guaranteed. I mean, it is guaranteed. Let's run it, guys. And oh my gosh. Map. I mean, this returns a list. Oh, there is no return statement. This is gonna be lit, guys. This is gonna be. Oh my. So we should remove the parentheses, guys, because it is array and the length is a property. Oh well, I tried. I keep getting this every word file not found. So about your question, oh now, all right, it is time for you, Rise. You said, yes, you said this one, and now it is time for us to ask it to Cloud. My friend asked this. Could you please help us out? Press enter and also all right. We will run. So let's try again, guys. Come on. In line 8, the answer is cooking, rice, fire. It's gonna be ready soon. We should use ArrayList, guys. ArrayList is a concrete class. Concrete class. List is an interface. Forget about this and use lazy skimmers approach. Let's remove that, or let's remove that, guys. Let's remove it. We can do this anyway. He said something like this. And let's run it, boy. Come on. Right. Come on, this time. Guys, I'm gonna get angry, guys. Come on, what do you say? Key is not key. Keys was the value, right? This is the key. All right. You need to replace key with the key you want to put. Yes. Add I online. Do you mean K? Not. Sorry. I is the. We should. Yes. All right. We are storing the indices. Yes. Thank you. Come on. I wanna see some. All right. At least case 1 and case 2 is great. Case 3. That's the case. That's the edge case, because we are getting the first occurrences. First. Yes. Like this is real mistake. Forget about the previous mistakes. I mean, not fully forget, because using this is important. Accept this. Forget about the remaining compiler errors, but this is important. We are using if we have like a duplicate characters, this is about here. If you have duplicate characters, I mean, like, is there a data structure or something that will get us? I mean, if there are multiple entries, is there something that, I mean, will give us the first one, like a pop or something, right? Do we have something like that? Because when we get like this returns a list of indices, all right? List of indices of the item of the integer. And if there are like if there are the duplicates of this 12, I mean 11, each time we get the first one, now this is not algorithms, this is not about algorithms, but data structures. Let's look at the answer we need. Happy to help. You can do like rise, fire. I'm getting the answer for you. You can connect to our arena, all right, and you can see this there, all right. I am sharing this in the chat, all right, and the room code is this. You can reach it from here. Lazy Gamer said that you can do like check if value 1 and value 2 are the same. And then if they are the same, check if the index list of for that value in the map has at least 2 size, and then return like I didn't think of that, because I forgot the meaning of this. Yeah, this nice. But what if we have like a 3 or 4. I mean, what are we gonna do then? Then returning the first possible choice is enough, right? All right. Adding this is adding that is gonna solve our problem. because returning on one possible solution is enough. This question doesn't ask return every correct indices, right? Or does it? Only one valid answer exists. As Lazy Skimmer said earlier, guys, if we didn't have this one, then we would end up finding all the indices that equals to target. We would have to store them, basically, right? But since we have this, we don't need to do that. Oh my gosh. Now, guys, I'm gonna do something. If what did Lazy Skimmer said? Actually, I don't think we need to check for at least size 2. I mean, maybe we can say like if they are same, basically, because left will always be less than right. Like, I mean, I don't know, guys. So if they are the same, the list must be at least size 2. So the value. So if we reach target using the same value, actually here they have their indices but wrong indices, but they value we should get. But if value 1 and value 2 are the same but left and right are different, yeah, left and right different. If value 1 and value 2 are the same, if they are the same, then if they are the same, I should take a break. If they are the same, guys, like we use get 0 and get 1 basically. If they are the same, come on, guys, we got this, guys. We got this, guys. Easy. If they are the same, make it 0, make it 1, forget about the rest, run it, guys, and cd accept it, guys. Come on, this was easy, guys. Come on. Like, I copied the logic of Lazy Skimmer. I sent it an image. All right, let's see. Approve. All right, let's see. My friend sent me this image. So what is the issue here exactly? Submit. Yes, I'm gonna submit right now. And I don't want to see any red thing. Thank you, guys. Thank you, Lazy Skimmer. You were best. And can you please continue and finish what you have started, and also check our status of our daemons, because currently in my chat I cannot use I guess color command and voice commands. Make sure our voice model is running, and make sure every daemon related to our Twitch is they are working correctly. All right, check it. I'm live. Make sure you don't crash anything. All right, be careful, my man. GGS. Now compare it to my solution. Yes. Let's see how did Carcass solve it. He used normal hash map. Right, alright. But how did he handle the multiple indices? Let's see. Let's see. Come on. In on. Oh, he didn't sort the array at all. Wow. He get its value. Oh, then that's nice. I guess I've seen this approach before. He get the value if it if we contain or if we don't contain. I mean, yeah, if we contain. Yes, if we contain, if there is an entry with this key, which is the value, not the index, the value, we already have that value. Next time we hit the same value, guys. Next time we hit the same value, he returns the index of the current one and index of. I guess here we are gonna store the index. Let's see. We are storing. Yeah. Like I kind of remember this this pattern, this technique. Like target as target minus value. This is good. This is good. Yeah. I've seen this. Yeah. I've seen this. Yeah, this is good. This is good. Let me take a screenshot. Where can I put this? I don't know, but here 2 point. Do we have no? Do we have greedy? Actually, this is not greedy, so maybe we lead code topics and 2.2. Yeah. I've seen this technique before, and it is smart. It is smart. Yeah. I've seen this before, but I didn't remember that I can use it here in this question. Nitro Banana to install Linux, but every single time I try to install, so I don't know how am I supposed to fix it. It is easy. It is easy. It is easy. My friend told me this. Please, you can make an online search. All right. You can find some forums or something. Make sure you handle his problem. All right. We need to fix it. What is the time complexity of your solution? What is the time complexity of this solution? Like, since we sort, it is n log n basic. Like, as soon as we see, like, it is n log n. Forget about anything. And n log n, and this is kinda on, so it makes n log n. I think I would say n log n. Also, look at this way to handle indices. Let's see what we have. Yeah. Oh, integer compare. Oh, we again sort. This might be the first time I see the compare method, guys. In one of our streams, we checked the methods of integer class. But I guess I didn't see. Like, I know compare to, right? To some. We create an integer. We, in a for loop, we store. What is this? Like, we stored its index. So, what are we doing here, guys? 0, 1, 2, 0, 1, 2, 0, 1, 2. All right, continue. I guess it's just initializing it, since it is a wrapper class. we sort um, in ascending order, I guess, the integer array. And then this is starting, this is end. Yeah, this two-pointer approach applied here, guys, is applied here. When unless as long as left is smaller than r. Oh, nice. From the yes, this is nice. In nums array, so instead of like we used hash map, but here we don't use it, so it is maybe better in space optimization manner. He literally is using nums array, and to index it's use value. Now the thing is, guys, like the danger of using the value. Hmm. Hold on, guys. All right, let me take a break, like a quick break. All right, I'll be back in a maybe 10 minutes. Then I will read it. I kind of understand it, but how did you solve the problem of out of bounds exception? Because using this approach has its own danger, right? We've tried using this before, and I got out of, I mean, it is out of bounds exception many times, as you remember, guys. But how come we don't have that kind of issue? Like remaining part is easy, like we know it, but this part, and this is also looking good because now Java compiles. Uh, yes, it compiles, right? Yes, it compiles, and yeah. Let me um. What is the time complexity of calculus? On. It is on. Yes, it is on. It is on, and yeah, I've seen this before, but I forgot. And this is cool. This is good. No, like I want him to derive or figure out. No. When I was reading it, I told it. I mentioned the time complexity. I mean, I said in on for loop, as far as I remember. I also found use of I also found use for AI. I was too lazy to write it out in Java, so I wrote it in Go and had AI. All right, this is the best use case for AI for you, I guess, guys. We just need an array of indices which will get jumbled on the sort. No danger. Yes, I need to understand it. I need to understand it. It only has valid as yes, that is the key. But how did you manage to use only valid indices? Like this is the part I need to see, because on line 5, yes, like I didn't understand this. You only iterate. I'm gonna understand it. But let me take a. All right, I will understand it. Let me take a quick break, guys. All right, I'll be back in a 10 minutes. All right. I really love your solution and the Carcass solution. Um, Let me also OCR and let me add two-pointer and also which yes, and also All right, thank you guys. I'll be back in a 10 minutes. These solutions are great. Both of them are great. All right, see you in 10 minutes, guys. And make it 15 in case anything happens. All right.
Breathe, the solution is already inside you, waiting to be typed.
Hello, hello. Welcome back, guys. We are live again. All right, again. So we were studying these lazy schemer solution, and like the compare method is the method that I don't see frequently, basically. But this usage caught my attention. Attention. Um, like because lazy schemer done this without worrying, all right? Because when I when I did the same thing, I got out of bounds exception, and he also said that since we are doing this part basically, and now we don't need to worry about it, right? And I didn't get it fully, because I mean we literally, 0 1 2 3 4 0 1 2 3 4, like we are storing 0 1 2 3 4. So what is the meaning of it, guys? What is the meaning of storing these 0 1 2 3 basically? And he also sort them. Actually maybe another clue is here. Yeah, keep practicing implementation to the point where you also never have to worry about out of bounds. Yes, yes, yes. That is a good goal. Absolutely, absolutely. Um, and also I need you to run that motivate command again, Lazy Skimmer, and I guess this time it's gonna work. Motivate command or push command. Yeah, could you please try it? I guess now it's gonna work.
This bug has never trained a day in its life. You have, end it.
Thank you. It works. It is simply because every value inside the array is only between 0. Yeah, I know, of course. Come on, man. I know it is, but how do you use it? How do you use it? I can see that. And by actually this is the key, I think. You compare nums I, not at I. Yes, that is why it is not dangerous, because in nums at I will give some number from 0 to n minus 1. Yes, yes. Um, mm, we have nums array, which is this, right? This one, guys. And we have I and j. Mhm. Um, so I set n to numslang. We'll give some numbers. But by doing this sorting, what do we get? Like, I mean, this is the core part. I mean, you sort, and for example, at line 9, the sort line is not related out of, I know, out of bounds is this. I mean, we have the indices, but it is related because this sorting makes you able to call these, right? I mean, the indices are correct inside bounds. I get it, but also I want to understand this part. Then you can see. All right. So you mean I can copy the solution and maybe paste it here, like that one. And erase to sort thing to add. You want me? Yes, yes, yes. System.out.print ln, and in erase class we have to string method, and we can literally turn this array into, you can get your solution again from submit. Oh, nice. In a, yes, thank you. This is not a good case. What do we have here? What do we have here? Let's, and What do we have here, guys? 1 0. Oh my, you literally, like, it's like a magic, and magically you get the as if you sorted our nums array and you stored their indices in the sorted array. This is like a magic, guys. What kind of magic, what kind of dark magic are you using, Lazy Skimmer? I started being scared. What kind of dark magic is it? Is this? I guess I need to be more familiar with using this notation, guys. I've seen these in a few different cases. I need to be more familiar with this because this is the magic. And I wanna add this inside to do. I need to be more familiar with it. Yeah, like this is the magic part. And after you have their indices in supposed order, then how are you using them? Alright, this is one thing, and the other thing is how you are using them, basically. So alright, at array is like that, but how about nums? Nums is state still, and the magic, guys, the second magic is gonna happen here. Now I is 0, L is 0, and R is 2. L is 2, R is 2, L is 0, like a left and right pointer. Hold on. We have left pointer and right pointer. I thought there is a sound coming from my, I think it is coming outside. Left and right pointer, yes. And when you, all right. As Lazy Skimmer said, let's print them, all right, because he's always telling me, telling me to do this one, and I wonder what we have with this one. All right, this is enough. Let's run it, and let's see with my own eyes. We have 1, but what is 1? Maybe I should look at, yes, 0 0 0 0 0 0. The at array this one, and this one, and it is 0 0 0. How about this one? Maybe I can just copy and paste and see, guys, R, and then maybe I can try with this one too, and we can also make it this one, and let me try also this one. And I really wonder, and let's see what we have got here, guys. I guess, oh my gosh, like we convert from a point to another, and we use it to do it back again. At array is contains the supposed order, basically, right? You can look at it and you can easily understand it is the it is the it is the index of that item if you sort the array. Then what? um yeah, yeah. So when I do, I get one, and yes, I guess that case is not so useful. Yes, since I mean, since it is already in ascending order, and like this case is also not helpful. Maybe this one might be helpful. um so basically you sort, right? Basically you sort. You have an array. You have an array that contains like nums et l nums et l equals nums 1, which means yes, I like this one. Nums 1, which means 2. So you get what you want from nums array, but what you want, I don't know what you want, but you get it what you want using at l. And at l is telling you the index of what you want, basically. And you computed that index by that dark magic. Using dark magic, guys, he managed to create what he wants, and here he just basically using it. There is nothing complicated with this one. He is just using, like, after generating at l and at r, I mean, yeah, basically, or after creating at, right, after applying after casting this dark magic, basically it is easy. We can just use left and right pointers on this array as normal, but the at will redirect to the original array index. Yes, I get it. I love this solution, lazy skimmer. I love this solution, uh, because this is the first time I use this kind of logic. I like this logic is good. This logic is good, and Carcus so logic is. I've seen the Carcus logic before, but actually we use this kind of logic in a frequency as well. I mean frequency problems as well. I remember some questions that we use, like a instead of finding two things, you subtract from your target, and you only use only one value, basically. So this is yes, this is a, as you call, a mini pattern, knowing this approach. Yeah, and this is O(n), and your time complexity is n log n and O(n). That makes n log n. But if we compare our methods, I mean, if we compare our methods, uh, if we compare our methods, which one is which one is better? Oh, I didn't. Yes, let me submit. No, this is my soul. Oh, where did our solution? It's okay. We can just. Oh my gosh, guys, I am kinda lost. Where did your solution go? Um, it is still slower and log n because of the sorting, but this index sorting pattern is useful. I strongly believe that it is useful. It is smart. If you need to get back, if you need to get back the original index, yes, yes, get back the original, yes, yes. If you don't want to change your um, original array, yeah, yeah, it is good. It is good. We can continue. Um, I think mine is still on the other side. I guess yes. No, this is another code. This is yo no to Sam. This is contains duplicate. This is to Sam. This is to Sam too. Like the code changed. I mean, I can find the link you have shared here, and I can open it again, and I can copy the code and here paste it. I guess this is my no. This is just I paste it now. I can submit it. Let's see. Oh, yours is faster than mine. Space kinda is same, but yours is faster. But my first solution is even better because that solution, guys, it's Carcass's solution, where we handle it in ON. Uh, like, come on, man, where are you? Yes, like I remember. Yeah, yeah. This is 2 milliseconds. Um, if you need to, yes, I think mine, yes, nah, same time. The MS difference is just like a server variation, sometimes faster, sometimes slower, based on like, interesting, interesting, interesting. But I written down this approach. Like one day it's gonna help me. Like I can feel it. I can feel it. Thank you. Now, guys, let's continue. I think I can just get this and make it full screen. Contains duplicate valid anagram to some and group anagrams. I have solved this question too. Anagrams. I have um, I have solved this question too. And also, lazy skimmer, you can use hint command in our chat, like using exclamation mark and then hint, and your hint will be here. um, so, given an array of strings, group anagrams together. Yeah. What kind of anagram? Like I have solved this, but there is no string in. Hmm. So basically, we will create an hash map, store, like 1A, 1E, 1T, but if we have two A's, two T's, two E's, no, no, no. We already have our string array. All right, all right. We need to iterate basically and store. I mean, we need to store frequency somewhere eventually, right? Let's look at the constraints as Lazy Skimmer told us. String length is 1. All right, we at least 1. No. So we have some strings in our string array, and their length between 0 and 100. So our strings in our string array can be 0, a length of 0, and 100. Mm, what makes them in a group? Like these have 1t, this 1t, 1e, 1a, and this one also has the same amount of e's, same amount of a's, same amount of t's. But is it guaranteed that every string that we have in our string, is it guaranteed that their length is gonna be same? Is it guaranteed? Uh, is it guaranteed? There is no string in that can be rearranged from. So I mean, we're gonna need, something like this, right? We need to process each of the strings, right? Um, let's say ate ate not, and no, let's use ate, eat, and tea. Ate, eat, tea. What are we gonna do about them, guys? Like, like, we need some sort of hash map, but how am I supposed to use that kind of hash map? Um, that kind of hash map. Uh, like, we need to know, how, like, oh, I think I remember, guys. I have a mini pattern, all right? As Carcus suggested in our last problem, guys, I have some mini patterns as well, all right? That pattern uh, was about something else. Like, that pattern was like having a key, basically, right? There was a mini pattern where you create like, you turn, you were making, let's say, at 8, all right? You were turning this into some sort of key, and you were using that key to search others, but I guess we cannot use it here. Or maybe we can, guys. No, we can, guys. Come on. Um, we sh- mm, like, I have an idea, but I don't know if it is optimal way or not. But we can turn like a values, right? No, it is too costly. We can turn we can iterate each string and get its key. Basically, yes. For example, maybe not values. Yeah, maybe values. Maybe no key. Key. Uh, key set. Something like that. We can return key set. We can create, for example, if we have like a 6 number of strings in our string array, we can create 6 number of hash maps and populate them, and we can iterate those hash maps and group. Oh my gosh, this doesn't look good, guys. This doesn't look good. Like apparently we should have another for loop and create. I mean, do we need like a 6 number of hash maps? I mean, anagram means same number of characters, same number of characters. Um, Same number of characters. How am I supposed to? How am I supposed to group? Let's imagine for a second we have what we need, right? Let's imagine we have an hash map of mm, of what? The anagrams has the same number of characters, and if something has same number character of another string, what do they share? They share they share same amount of characters, and when we look at their hash map, we're gonna have same keys with same values. Same keys, same values. Same keys, same keys, same values. I mean, by values, I mean the frequency basically. Values mean their frequencies. So imagine we created 6 number of hash map, right? Imagine we create 6 number of hash map and we populate them. And imagine, and there is a method in Java. Today I have studied it. It is something like map. it was map key set. Let me. It was map. Not entry set. Not key set. Group anagram. All right, we have. Oh my gosh, what was it? Or maybe it was entry set. No. Yes. Yes, kinda this one. Let me copy. And I don't know why, but our search mechanism does not. Yes, I guess this one. Yes. Entry set. Yes. Map entry. Uh oh my gosh. Map entry. Then what, guys? Our array, our hash maps structure basically, and then entry set. All right. Our map structure. I don't know what kind of structure we have for our. Let's make it integer for the sake of time. Integer. Let's make it a, and not key set, but entry set, right? Entry set, so that we get key and values together. But this is for only one map. We should be. We need to return list of lists. Basically, we should have lists. Do we have hints? No, we don't. Why we don't? I have studied this question before. I have studied this question before actually, guys. But let's see. There should be same keys with same values. We can literally compare. We can literally um, iterate through all of our hash maps. All right. We can have a list of hash maps, and maybe we can iterate them. And if a hash map contains same keys with same values, maybe we can have some sort of key, as I said before, and we can use that key to recognize if we have another hash map in our list base. If we have, we should group them, but actually maybe I should stop thinking like I should stop trying to make it run like a simulation, because simulation it may not be an optimal way for us. um, Actually our lists contains those strings. Yes, I thought they are in order, I mean, but they have their own lists, and in each of the lists we get like um for example, oh my gosh, what is this? All right, it's stopped working. um so come on, we have S1, S2, S3, let's say, and we know, like, we need to create a system where we can understand what that hash map includes, consists, or contains basically. um all right, how do we create an ID basically for a hash map? And we should be able to create the same key for other hash map that contains same keys with same values. And in the previous question, what did we do with anagram? Actually, we use another method there, right? Although they share same name, this question is different. Like, I strongly believe that hashmap is gonna help us, and that key thing. So we should also have a mechanism to know which list is for which one, basically. I mean, yeah, we need a mechanism to store. For example, they are grouped. How do we create those groups? Based on what? Based on that key. We should create a list. We should create some sort of list. new array list. And add our string, for example, here s, we should add it to that list. How do we locate? How do we create location address? Or maybe without needing location address. But we should have, I mean, otherwise how would we know, for example, 8 is here and it is, I mean, it should go to the list that we have 8 in it. I mean, we should some sort of locator, right? You can return the answer in any order. So order does not matter, but we should a mechanism for understanding which and we don't know the size of the answer, so that's why we use array list. But let's say we have a list and we put our answer. I mean, what is the key, for example? Actually, and also we don't know how many lists. Yeah. And for example, which key are we gonna have for this list, for example? Let me type array list and let's see what we have. We add a new list, like we are creating a new list, and we are getting the list at index 0 basically, but this is an example. What else do we have? We put maybe that key we can use, like, can we use that key? This is hash map. Or this compute if efficient method that Lazy Skimmer mentioned earlier. No. No, this wouldn't help either. No. This is interesting. Like, I mean, I don't see or maybe, for example, we have 8, right? We have it, we have t. So for example, a is 1, e is 1, and t is 1. We can create some sort of key using these. I mean, we should be able to. I mean, why not? Yes, I remember, guys. This is the question where we use key, like a A1, E1, and T1 can be the key for our hash map, and we can use that key to fetch. Um, all right, let's focus on that key thing. All right, because I think this is the way. Imagine like now we should focus on how we can create that hash map. Which hash map? Like a 8, like a this hash map. Um, for each character of that string, to characters, I think, right? I should also study these methods. I mean, the conversion methods. Um, the map is gonna be what's gonna be like key value. So maybe character and then integer. How about that? And this is our map. And actually, we should create a new hash map here, and then we should put C, right? And get or default, right? Map dot get or default C comma 0 and then plus 1. So we populate our hash map. Then we see the same character again, we increase it. And we should also store this hash map inside something. Which kind of something? I don't know. Can it be a list? Can we have list of this kind of hash map? I suppose yes. All maps. New should I write array list, guys? Array list and hash map. I don't know, nested. But maybe the inner for inner part. I don't know. This seems nice. Now we should, after creating, we should add our map there. With what key? We have actually no. This is list all maps list, and we should add our newly created map into this one. And also now focus on creating that key. Now we need a key, and I don't know, guys. Like if I knew this is the correct way, I would try, but I don't wanna continue. If it is not correct. But I remember something like this key. After populating, like after storing all the hash maps, um, also store their keys, and we should have a mechanism for getting. All right, we can create another hash map and store our maps there based on their keys, so that when we have a hash map with the same key, we can literally um, have it inside the same value part of that hash map, so that we can easily return it. I guess this is the correct solution. I mean, this is supposed to be correct. solution. So we have like ET10, all of the strings, and we iterate every single one of them. We create a hash map for what? For this one. I mean, for this one. Um, I mean, we only process the 8, and we have mm, we're gonna have 8, for example, here. Hello, Aymanat, welcome, welcome. How are you? How are you? How are you doing? We are solving group anagrams problem, and let's push me a little bit.
This is your table. The bug does not leave it alive.
The bug does not leave it alive, guys. I have some new comments. You can also use those comments. Let me check if I gave you. Yes, you are trusted. So I'm trying to create a hash map that contains the frequency of these characters of the S, the current S. Current S is this. We are iterating each character. We are putting each of its character inside of that hash map, and we also store that hash map inside our lists. Maybe that list should also be a hash map, most probably. But for the sake of time, let's focus on um, creating all the hash maps. So now our next focus is, maybe, guys, yes, after creating these hash maps, how can I create this one as a key? And how can I use that key to find other hash maps with the same key, basic? I mean, this key. Maybe we can create another method that will return, I don't know, but imagine it returns what? Imagine it gets a key and it returns a hash map. Character. But how is it supposed to know which hash map we are processing? I mean, we are processing, but it has the key, so it should also take a hash map or list of hash map. No, it should return boolean, or I don't know. Let's take a key and also a hash map, basically, right? Let's make it integer, doesn't matter for now. But here we're gonna have a for loop, and we need to create this key basically using this map. Like using a map, how can I create that kind of key? Because I will compare them with the given key basically. Let's see. So we should basically iterate each key of our map, right? Map dot not only key, but we need the key value. Key value, yes, yes. So map dot map dot entry, and then structure of our map. Actually, structure of our map is not integer, but integer character. And use entry set. Actually, we literally have written that here. So now we have keys and values. So I'm gonna create, I cannot create a string, but I can create a string builder. Oh my god, this is too long, guys. New string builder, and I should add a dot get key, right? Get key, and append it, right? And then sb append a dot get value, I suppose. And then we should convert this string builder to string, right? Because in its class most probably we have this. So we have this magical string builder in at our hands. We iterate through all the key values, key value entries together, right? Like a includes key and value, right? Key and value, key value. We get, oh my gosh, we get it, and we get it. We now we have the key. Oh, we shouldn't return it, but we should return. I don't know how to use Tenerife, so we should return basically, guys, if our key is, what is the correct way of comparing two strings, guys? It is easy, not value of, not compared to. We can we use compared to? Compared to EQs, something like EQs. Do we have like value of, I forgot. Let's see how to jumpare two strings in Java. The equals, we didn't have it, guys. Equals to what? To sp dot to string. If they are equal, we return true. If they are not, we return false. So we now have this key at our hands, guys. Wonderful. So now we have a helper method. Now, and we also have our maps inside a list. But now, how am I supposed to use? How am I supposed to generate a key? Like, maybe we should store all the unique keys, and then maybe we first should create those keys, and then we should iterate all of the strings again. Oh no, we should iterate through the hash map of. Now we need a mechanism for transforming hash map to list of strings. We can focus on one of them. Checks key with the given map. Something like this, guys. Something like this. Do you have any idea, guys? Otherwise, I'm gonna look at the solution because I don't wanna spend, you know, much time. Like the idea is having a key of hash map and try finding hash maps with the same key. Key means this basically, and we can literally create key like this, like a character and then frequency, character and frequency. We have a helper method that checks if the given map has correct type, and now we should use this function inside some sort of for loop that will compare every map that it has. So imagine we have a for loop where we iterate through a list of maps basically, right? A list of maps basically, all right? Integer character. So what we have is a map basically, like this kind of map. Imagine we iterate this one, and each element is this one, a map. And imagine we use this our method, and our method will tell us but which key we are gonna use. We may need to, I don't know, guys. I'm gonna look at the solution, I suppose, guys. Group anagrams. Let's see what we have. Lazy skimmer. Let's see lazy skimmer solution. Let's see what dark magic he used. All right, let's see. We have a for loop, and we turn each string into character array. We sort them. I didn't think about sorting at all. Yeah, I should have thought about it. Sort them. I also did like frequency counter solution. Yes. I wonder this one actually. Let's see. Let's see frequency counter solution. What do we have here? String, current string, So we are alright. We are iterating every character of every string. Yes, every character of every string. This is for every character. This is for every string. We are getting every character, and we are increasing it basically. Alright. We have this magic here, dark magic here. We've used it. We have used it in our previous question. In our previous question, we also have used this method too. We create an array list. Another magic here, guys. I don't know. We erase dot equals. From our array, frequency array, from our frequency array, we compare this one. Since we sorted, if the consecutive two ones are equal, this is good, but I should spend more time understanding it. Let me, oh my gosh, let me take a screenshot and edit into our to do and lazy skimmer, and the question is group anagrams, and then the other solution is, yes, we have a for loop. We turn each string into characters, we sort those characters, and we create another string map groups string. Yes, I guess I was looking for something like that, like a keys string and then list. Probably better way to do this than how I did it though. Let's see. For example, this is the this is a good way of creating a string. We sort those characters we create, so those strings will have actually same if they share same amount of occurrence frequency. Like, I guess the Carcus solution is kind of thing that I was trying to do, like a key and then list of strings. I don't know. Let me also take a screenshot. Carcus. So we have in the integer array. We do this mini pattern again. We use now compare to. All right. I don't know how to do it basically, but I should study this, guys. I should study this compare to, and in the previous solution, the dark magic that I called, I should study this. Anyway, we sort whatever this is. Actually, not at, but we sort this XS. For each word, you sort it, and use that as key and append the unsorted word to hash map. For each word, you sort it. For each word, you sort it, alright, and use that. Now, sorted version we're gonna use. Alright. As a key, yes, I remembered the key concept correctly, but we had issue with the implementation. Key and append the unsorted word to hash map. Append the unsorted word. Unsorted word to hash map. I kinda understand, but we have an integer. All right. I should be familiar with this. Did I paste this solution? Did I paste this solution? I guess I have. Lazy sycamore and the carcass. Wonderful. And no, yes. Now we have. Array list. List of strings. This is answer. We add a new array list. Oof, oh my gosh, guys. List of what? List of. Oof. No, guys, no. This start. No. No, guys. I will study this. All right, guys. Give me a sec. I'll find my solution and let AI convert it. All right. Like I remember the key approach, but I should be familiar with these this implementation, like a compare to method and like a compare to method and this like this sorting approach. Like these are some of the implementation details. All right, guys. Yeah. For example, how do you store a frequency? How do you create a frequency table for each character? Each character, and you increase it. So you basically write 0, 1, 2, 3, 4 basically, and you increase. You now have an array of frequencies of those. I should study this, guys. I should study this. And here we have that dark magic. This mini pattern. I don't know what we are getting after this arrays.compare. I don't understand it. Yeah, no. I should study, guys. I should study. I should study this question. Yeah, but I like, guys. Today we have solved good questions, and in our next stream we're gonna continue solving that list. Basically, I like this lazy skimmer. I like because these are the questions that I'm not too not familiar. I'm kind of familiar with them. We can finish these. We can alright, array and hashing. We can finish 2 pointers, sliding window. Alright. We're gonna finish them all. Yeah. Our goal is finishing every one of them, guys. And then we can continue with the greedy problems as well. Greedy is something else. But we have some implementation details in these problems. I should be familiar with them, and I will create some notes about arrays basically. I mean, today I have created these notes for array list and hash map. These are for syntax, but post solution tutorial. Alright, these are for like a syntax wise, but also I will create another note for why did I I'm gonna create another note for like a question wise, I mean implementation wise. All right, All right. We have a hash map. String is most probably the key, and these are the strings that share that key. Yeah, yeah. Like this looks quite elegant, but I should learn your solutions and also this one. Ignore my solutions. This is the this one. I like when I studied this question, I solved this approach of key, but I didn't couldn't figure out how to implement it. So using a for each loop, we process each string, we turn them into characters, we sort those characters. uh this is how we create this key. Oh, sorting is slower though. Kono Suba Life. Welcome in. Sorting is costly, but compare comparing it with other solutions, it is it might be a good solution. Of course, everything has its own cost, but you know, you pick yeah, everything has its own trade-off basically, right? Welcome in, by the way. Kono Suba Life. Life or Kono Suba Life maybe. um so we iterate each strings, we turn each strings into characters, we sort those characters, which mean for example, if we have like a eat 8, right, every one of them is gonna be um at 8 8, right, 8 8. So we have that 8 basically, ATE 8. We have that 8 as a key. Guys, I should know using this method, guys. Come on, come on. Today, this is the second. I did some lazy. You can also paste here. Um, you can also paste your thing here if you like in the chat. So do compute. Come on. Compute if absent. Like today, this is the second time I see. Maybe the third time. So we have anagram groups, and anagram group is gonna be no like. Or we're gonna use it to create. What do you host your website with? Like a. What do you host? Like I have VPS. Like I use Hostinger, and there are lots of like all of my applications in that VPS basically. One CPU, one core, but it handles website things. I basically translated my CPU solution. All right, all right. How did you go? All right. So we have anagram groups. We use compute if absent. I should learn this method. We have anagram groups, and that the key and the value of is eat 8 EA to the game. Like we have those. I mean, this is gonna store the strings with the same key basically, right? Yeah. So but how do we populate anagram? Yes, how do we populate this hash map? Compute if absent. This is the key. What is the key? Key is key, basic. The key we have generated. And then, guys, we have another key here. New array list. If absent, it creates another array list. It populate an array list, but if there is one, it just add a word basically. Which word? Which word, guys? Word is the current processed string basically from our input. We basically generate our key, generate its key. We generate its key. We generate its key. You can avoid the sorting and implement your own key generator. Yes, actually I kinda, yeah, I didn't create, but where you count the frequencies into a list of length 26 and use that key, that as key. In Java, I think you have to convert that list back to string, as hashmap doesn't accept list as key. Yes, I think so. Yes, I think so. Let me. This is cool, man. This is just cool. Let me paste your code. Yes, yes. Actually, Karkus actually gave me the hint, but I couldn't figure it out. I should have figured it out as soon as I've seen this one. All right, guys. Like I will study those methods with examples. All right, I should be quite familiar with this. Like I shouldn't think about how to populate a hash map. Like as soon as I've seen this one, I should have known what I should do. All right. Basically populate, and we add that word to that key, to that address. The address is generated in on, and we return a new array list of, for example, I don't know how to do it, but I understand, but I should be familiar with this version as well. Like we are getting values from this one, which is strings. All right, we get string. I know. We use, like, we get strings and we create array list using them, but no, the values are not string, guys. List of strings. Sorry. String is key. We literally create an array list of our like, using these ones. Yeah, I'm thinking about what value we have. Value is basically string. I mean, not string, but list of strings. All right. I put my Haskell solution. Oh my gosh, I've seen Haskell in college, in one of our lecture. Did you? I guess you didn't share it in our. I don't know. In C++, my solution was not ugly. Let's see. Come on. It's on the arena. Is it? Why did I miss it? It seems it is. I'm not sure if I have to do something to publish. You are Kono. You should open the chat and paste it. I'm Kono. Yeah. You can open the chat by clicking on this one. Is it in live code? Oh, all right. All right. I see. Thank you. Thank you, ladies and gentlemen. Yeah, it is even live, man. Come on, we can update it. This is Haskell sorting solution. Oh my gosh, guys. But this is Python, right? What is this, guys? This is Python. How is it Haskell? This is literally Python, right? Haskell is one-liner. The command is the solution. Oh my gosh. I did it in really? Haskell, like where is Haskell used actually? Like for the systems where you search some, some text, and it should be fast, or some, you know, core elements, right? Where is it used actually? I guess it is used in, you know, some core systems. I mean, that should be quite fast. And anagram and C++ solution. Let's see what we have here. What is vector, lazy skimmer? I've seen this quite much. I mean, whenever I, you know, watch a video on YouTube like about C++ or something, when I, you know, come across it, I hear vectors. Group anagrams. This is the argument. This is the type of the argument. You are getting size of those, I mean, that strings. Vector is just like array list. All right, all right. Very handful then. You create an array list of integer 26 for each character. I guess you declare it, but you didn't initialize it yet, right? Anyway, it's like the same as Java's. All right. So basically, yeah. So basically, you have, like, you create a frequency table, all right, for each string. No, for each letter in each string. But how do you reach it exactly? I really wonder. I should learn it. Like, how do you? Yeah. I mean, I should be more familiar with arrays. That's why. Range is stored. We have this notation in Java as well. I mean, integer, like a column, and, you know, something like that. I haven't used it, so, but I should be familiar with that notation as well. Push back. I don't understand. This looks cool. Let me take a screenshot. Oh my gosh. And lazy skimmer and paste it. And also we can get the solution of Konos, and Konos solution is both in Haskell and in Python. Let me paste it. Kono Suba Life. All right. Just you can see lot less typing. All right. Aymanat solution. Let's see Aymanat solution. Oh my god, we have different solutions. This is interesting. Let's paste it and see. Haskell is used everywhere, or should be. I agree. Let's see what we have. Another Python. Oh my gosh, why this is so short? Aymanat, come on. What did you do here? What kind of dark magic? Another. What level of dark magic is this? You are processing each string. We have studied this in our streams actually. I mean, join method. Um, what was it do? I mean, what does it do? It was joining. You sort. You sort basic. All right. You sort the string we have and join. I forgot join, man. Come on, guys. I should review them frequently. There were two methods. One of them was join, and one of them was, I don't know, like a splitting, maybe split. Yes, join. So you have a dictionary. But you don't have anything inside it. Because it is we are inside soluble, right? If you have You basically you have done the same approach as Carcus. You use key and append it. This is exactly what Carcus said, and I remembered partially the key concept. You get the value from that dictionary and append that string if that key exists. If we don't, you assign a string, assign assign what are you assigning here? I mean, list of s. For example, this is eat, for example, EAT, right? You are making it a array of characters. Um, it creates a list of values as the value. Oh my god. All right. Let's look at the Carcos's solution again. All right, Kono shared his code here as well. Let's look at the Carcos code. In Carcos's code, we have this hash map. We have key. We sort them. We insert at key that word, and you insert that key. You append if there is that key, but if there is if there is that if we have that key, if we don't have if you don't have if you don't have it, you create a list of values as the value. um Haskell. All right, Python. Agreed. You're supposed to fight me, and so okay. um I used sorted though. Yeah, like not sort but sorted. It joins an array into a string. All right. Its function is joining an array, which array, into a string, So yes, this is string. This is our array, which we have sorted. Um, sorry guys, let me check this one. Oh my gosh, not this one, but all right. So you should learn. Yes, I should learn. It joins an array into string. All right, all right. I will create some notes, guys. Like example. All right, example notes. Yeah. I will create some like a question and uh, like its solution. I mean, for example usage of join method in different cases. Split. Yes, it is split. Supply split. Yeah. You should learn Python for interview sometime. A lot of details you don't need to worry about. Yes, look at it. No, like I don't bother. I mean, it doesn't bother me to this doesn't matter me. I just memorize them basically. Like I can understand it because I'm familiar with Java. Added Go solution to Arena. Let's see. Come on, guys. What are you doing, man? Are you crazy, guys? We have Go. We have Haskell. Like, come on. Um, where did you edit? Karkus said, edit Go solution. Oh, let's see. This one. All right. I thought this is a Konos. Oh, this is Go then. I see. I guess you are using a Go because in the previous solutions that you shared with us, you use this. Go is also in my list to learn actually. We have like these are I guess you. What is this, man? The return type? This is the parameter. Is this the return type? Yes, it is. We have make here, map here, key type, all right. We have range, all right. You iterate through all the strings. Your key generator, and your key generator is, yes, this is the mini pattern that I've seen. I'm seeing everywhere basically, like you're using an array, and as a key you literally use you know, the character itself, and you increase the frequency of it basically. uh, but how come you generate your key? I mean, you, this frequency array is the key, all right. But then how are you using it? All right, you have an array that contains the frequency of the characters, all right, all right. But how are you using you, all right. So you generate your array in anagram groups. You share the reference of that key array. What is anagram groups? What is I'm not familiar with. I guess it is hash map. Anagram group, some sort of hash map, and you are giving. In Java, we've done this too. You you give you put the key. Um, you put the key. Edit Go solution to arena. This one is optimized to not use sorting. Yeah, you don't like sorting. You you um you don't like sorting, and come on. Now you have a good collection of different yes, yes. Thank you guys. I appreciate, like, it is amazing. It is amazing. It's it feels good, man. It creates a list of values. It creates a list of values. Oh no, Ayman has said this. Array with string s in it. Array of one string. Ayman had, so key is values after I append. Um, no, key is not values. The value part that your key has in your dictionary is becoming value, not the key itself. I mean, did I get it wrongly? Anagram group is hash map. Anagram group is hash map. Key type is a custom type I made, so I could use array as the key. Array as the key. I guess we don't have it in Java. Yes, yes. This is interesting, guys. Using, I mean, our key in Java was like literally a string. Here we use array basically. First line of code is where I create key type to be an array of length. All right. You literally type it basically. I mean, you decide this. I mean, the name of this, right? Key type. Key type is array of 20 20 characters, I suppose. 20 bytes, 26 more bytes maybe. Nice. Like, did I copy this code? Like, we don't have this thing, as you said actually earlier. Did I? Yes, I guess. Yeah. No, this is Java solution and this is Go. All right, guys. I appreciate it. It is nice to see like a Haskell solution, Go solution, C++, Python. That's nice, guys. Now our goal, our goal is now set, is fixed, guys. We're gonna Like we're gonna cover all of these basically, guys. All right, we're gonna because otherwise, like if I spend 4 hours for a for a single for a particular problem, it doesn't feel good, right? It doesn't feel good. Like spending 4 hours. Like I'm not supposed to do that, guys. Today we studied like a 4 5, like a 4 question, guys. Um, except the other ones we have, except the ones we studied earlier. All right. We're gonna cover them all, guys. We're gonna implement them all, guys. All right. Lazy love this. We're gonna implement them all. And this is gonna be fun. So, allow me. It is interesting to see how languages overlap, and also some features that some have and others are missing or doing differently. Yeah. Exactly. It is enlightening. Yeah. Um. So guys, give me 8 minutes. I'll be back in 8 minutes, and maybe we can solve top k frequent elements. Like I studied this question before as well. Top k frequent elements. Top k frequent in or read code. Actually, this is the thing that I love about languages, Tikarkus. Um, the underlying idea behind these languages. What type of things that can be done differently. What other things that cannot be done differently. Like seeing these patterns is fun actually, because they share some fundamentals apparently. They have to, but sometimes author of those languages decide to do other way. All right, we're gonna continue with this, and let me check my RAM usage. All right, it is not too bad. It is not red. All right, guys, let me take around 8 minutes of break, and I'll be back in 8 minutes. See you after the break. we are back, guys. We are back, and I hope our music will. Yes, our music is also back. We are good to continue, guys. Let's try this question. um, so pop K frequent elements. Actually, guys, maybe we can leave it for this for tomorrow, and I can prepare some notes for you know, those methods that we have mentioned earlier, like these methods, for example. I should be familiar. Okay, compare and for example this one, and also for example not this one, this is Go, but compute if absent, for example. This is quite you know, fundamental, essential method. I should be able to, you know, populate this type of anagram. Like it can be like integer and list of integer, or integer or list of string, but this type like a key, normal key, and then list is quite common. Yeah. So it was a good day, guys. I appreciate it. We've done a great job. At least this is for me. It was great. So tomorrow I will create some other boards. For example, for, you know, mostly arrays, array list, hash map, and then maybe priority queue, like the other common classes, right? I will generate some nodes, and then some nodes for, again, with usages. For example, I have an example for compute if absent method. Um, compute if absent method. Uh, but maybe it was because I didn't figure out the structure of hash map that I need to have. That might be the issue, but I should be familiar with these. All right. What else we have? Yeah. So, and also we have lots of good questions from our list, basically like a greedy problems. And also, guys, today we studied cadence algorithm. It was great because I figured that I didn't understand the meaning of ending at index I. All right. Now, Lazy Skimmer, you know, contributed a lot in this part, as well as, you know, Carcass, and we generate the things we generate is, you know, um, like a I've seen, I understood now. All right, like a 1 2 3, and then 2 3, and then 3. All right. It was good, and because I was thinking, I was seeing this similar to you know, the house rubber or knapsack problem, like a post order traversal thing, like where you expect answer from your children, basically. That's your sub problems. But this question is a little bit different because it doesn't return what you need right away. It returns helpful thing, and you process it, basically. We studied this. So it's it's been it's been quite good, guys. um yeah, in our chat, in arena, we have lots of solutions, and I hope Rise Fix Fire also got its you know, solution. I asked to Cloud. I hope you also, you know, find something insightful and solve his problem. And tomorrow, most probably I'm gonna have another admin day, um, because I wanna create some YouTube videos, guys. For the last 2 days, this was my goal, but today this question got me, and then it didn't leave me. All right, um, all right, all right. But it was good. It was good. And tomorrow, for sure, all right, we're gonna create like a I have another instance of OBS, and I'm gonna like create literally YouTube videos live. You can watch me too. I mean, while I'm creating them, like a simple, not simple, but like a 1 minute and 2 minutes, 3 minutes, and then maybe like a 5 minutes or 10 minutes long videos as well for the questions that I think I know. While we review the topics that we have studied, mm, I want to have like a compact version of them so that it is easier to review basically, right? Because you know every one of us use YouTube, and I use YouTube a lot. I love YouTube Shorts. There are lots of fun stuff there, and I spent 1 hour like nothing, and it also it can also be your study platform as well. uh, yeah, it is fun to study there as well. And also today I've realized that if we complete this neat code list basically, it's gonna be so fun, guys, because all of these questions, like, I've studied these before. All right, it can be 2 years ago, 3 years ago, or 1 year ago, or maybe 6 months, or maybe 1 month ago. I've seen most of the questions, all right, here. Container with most water question, because tripping rainwater, we have solved this, we literally solved this question in our streams. uh, I haven't I haven't, I guess, run it. Did I run it? Anyway, but I implemented it mostly. So like, I'm quite familiar with these. These are quite common problems. All right, we're gonna complete them all. We're gonna create some YouTube videos too. I appreciated you being here. Um, it's gonna be good, guys. For example, I have solved almost all of the three problems here. All right, guys. All right, this three section is gonna be lit. Let me tell you this. I kinda not quite familiar with graph, but I know this question, I know that question, I know this question, and I know these. But the graph question I meant was something like, there are some like concepts in graphs, like, what was that? Um, Concepts in graph in LeetCode. I mean, some sort of special graphs. Uh, what was the? I'm not talking about the traversal techniques. Let me ask to AI. There was some not. There was some subtypes of graphs. I mean, on LeetCode when I was studying graphs, I've seen some. I know, like, there are some LeetCode problems, like even in graph, but you need to know certain type of approach and methodology to solve it. What were their names? Can you remind us? Like, I'm not familiar with those type, but in LeetCode, like here, like, I almost solve half of them, maybe all of them. Yes. Let's see. Advanced graphs. I'm not familiar with advanced graphs. One dimensional graph. I've solved almost all of them, guys. I have solved almost all of them. This is gonna be fun. This section is gonna be fun. Two di two dimensional time programming. I have solved again almost all of them. Maybe not the last edit distances. Yeah, I loved. Maybe last, and maybe not the last two, three of them. This is gonna be fun, guys. This is gonna be fun. Uh, Union find. All right. If it's about connectivity and union find, like, what are those concepts, guys? But I know DFS and BFS is gonna be fun. So I appreciate being you here, guys. I mean, you being here. See you in tomorrow's stream. I hope you see. I mean, you get some insightful stuff. and you enjoy streams. Take cares, and maybe I can look some channels to um rate, but somehow some channels does not let me rate them. Let's try to rate this channel. I guess it was like this, right? Oh my god. Settings do not allow you to rate it. Thank you. Take care, Lazy Skimmer. Lazy Skimmer, by the way, do you know? Maybe you don't know. I should check it. I mean, I tried rating some people, but I just can't. It is strange. Take care. See you in tomorrow's stream, alright? Let me try others. Interesting. Anyway, some people turn off getting rated. That is interesting. Alright, then switch to outro. See you guys. Take care.